Hello, guys, and welcome to this brand new course. Before introducing you this course, let me tell you I am Sajjad Mustafa from AI Sciences. I have done masters in computer science and I have an experience of over 5 years of working with governments and private companies on machine learning and data science projects. Currently, I am involved in a computer vision based deep neural network project where we are doing the surveillance, the human surveillance sort of thing. That's about my introduction, and I have an experience of teaching in a university for more than 3 years. So I will be teaching you, I will be instructing you this course. I will be just pushing you and telling you the theoretical concepts, and then those theoretical concepts will be implemented and we will be implementing live by using a certain programming language. So let me tell you something about the AI Sciences, our company. AI Sciences is an online learning platform where you can get registered and you can get courses and books by one of the most uh, eligible and the authorized sort of instructors from all over the world. You will be getting short books and short courses. For example, right now we are shooting the logistic regression course, which will be followed by then another course which is called random forest course. So it's really an amazing platform where you can get your online courses. So you should sign up without thinking. A lot of people waste a lot of money on different projects, and you can on different projects and different courses as well. You can get those courses for very low cost on this website, which is AI Sciences. So aisciences.net is our web address. So guys, let's talk about the course. Our course title is Introduction to Logistic Regression. Now, what is logistic regression? We are going to discuss about it. We are going to talk about logistic regression in our whole course. Our course will be consisting of almost more than 8 hours of HD video recordings that will be divided into more than 50 videos. And in this course, I will be telling you each and everything about logistic regression. Not only logistic regression, uh, but all the prerequisites that are required in order to understand the logistic regression. We'll be discussing everything, each and everything, from scratch, even before scratch, up till advanced level. So that's about the introduction, of course. And in next video, I will be giving you the reasons that why you should take this course, why should enroll yourself in this course. So until then, bye. Welcome back, guys. So the question is why you should take this course. What is the main reason? So let me give you three main reasons. Curtains of machine learning will be lifted for you. I will be explaining bit and byte of machine learning for you. If you know nothing about machine learning, it's totally fine. Everything will be explained from absolutely scratch. Although we will be discussing about the logistic regression mainly, but since logistic regression is a part of machine learning, so first of all, we will talk about what is machine learning actually. So if we will know, okay, this is machine learning, then we will be able to describe or define or code or learn that what is the logistic regression, which is our goal. And then we will be practically implementing a lot of projects. Uh, for example, if we will be talking about logistic regression, in order to implement the theoretical part that we will study. Initially we will study the theoretical part, and then that theoretical part will be implemented in machine learning, sorry, in a programming language. And whatever we would have been learned in theoretical part will be exactly implemented in the light of logistic regression on a certain projects, so that uh, all things will become clear for you people. Because only studying the theoretical part and not implementing anything practically will lead us towards the confusions. So everything will be implementing, we will be implementing practically. And how we will be implementing practically? So we will be using Python as a programming language to implement our theoretical parts for logistic regression. Now, what is Python? Python is a programming language. Is it just a programming language? Why we are using Python? There are dozens of programming languages available. Why Python? Question. So the answer is, it is most widely used programming language. Okay, but you can say, I don't agree with you. Okay, I'll take you to a survey by, let me remove it. Okay, by Stack Overflow. Stack Overflow is a very famous website. uh, I hope you all familiar with Stack Overflow. Programmers use this website a lot. So Stack Overflow says the growth of major programming languages in a few years. So in 2012, you can see that Python is almost behind everyone. Every programming language was far above than the Python. But with the passage of time, if you see, with the passage of time, Python has grown a lot. Here we go. Machine learning breakthroughs and machine learning, actual implementation started somewhere around 2013, 2012, and so on. And you can see the rise in the graph of Python from exactly that point. What does it mean? It means Python is a very specialized programming language for machine learning and that data science related projects, and also the deep learning sort of projects. Python is very vital. Python plays very vital role, and Python provides you so much readable functionalities, so that you can easily implement machine learning or data science concepts in it. That this is the reason the rise in Python's graph over the recent, let's say, 8 years. You can see that it is going above and above and above. It is not looking behind. Now, this is a survey of 2018. In 2018, you can see that Python has already crossed the JavaScript and Java and C Sharp and PHP and C++. And what this Stack Overflow anticipated, Stack Overflow thinks that uh, Python will be, let me do something like, okay. So Stack Overflow thinks that Python will be where Python will be standing in next few years. So Stack Overflow thinks, I'm sorry for that confusion. Okay, so Stack Overflow thinks that in from 2018 to 2020, right now it's 2020. So Stack Overflow anticipated that Python will be growing that much. Python will be beating other language with that much margin in 2020. And right now we can easily see that Python has complete dominance wherever the machine learning or data science project is required. Other than that, it's not only important language. The reasons behind its importance are, one of the main reasons is it is really easy to learn. It is really easy to code very complex logics by using Python. So Python will be used as programming language. Let me repeat myself. Initially, we will be studying theoretical part. Let me represent it with T. Then we will be implementing that theoretical part practically in a programming language that is called Python. So for that, we need to learn Python. For those who don't know anything about Python, good news is we will initially learn Python in this course. Once we will be done with Python, then we will proceed toward machine learning. So that's all from this slide. And let me give you a little bit of motivation about the machine learning. Some areas where machine learning is right now, it's working. Some areas of applications of machine learning are virtual assistants. We all know that chatbots are really into industry right now. And then predictions while commuting. Again, it's almost about the chatbots. Then video surveillance is that in Beijing, the capital of China, they have they have a system like uh, cameras monitor the citizens, and if citizen do any violation of law, they automatically reduce some points of that person. So those points will be later on used for the jobs or something. So if a person drops some garbage on road, points will be reduced, and if a person picks up that garbage from the road, the points will be increased. So ultimately those points will be used for the jobs. uh, so it's just a demo, and they are going to implement in following year in China. So it's all about video surveillance uh, and using machine learning and deep learning. Then social media services, of course, we all know that how much machine learning is involved in Facebook and Instagram and stuff. If you look at one ad, you will be start looking at a thread of those ads. And then we talk about email or spam email filtering. We all know that Gmail or Outlook or other websites do that for us. Behind that, um, exactly logistic regression is implemented. Other than that, online customer support, search engine result refining, product recommendation, again, machine learning comes into play, online fraud detection, and in healthcare. Let me tell you a very interesting thing. In probably last year, there was a competition in China between doctors and AI. So it was like AI versus docs, and AI won that competition with a margin. Competition was about predicting the cancer. So while looking at patients' reports, AI agent had to predict that if that person has cancer or not, and doctors also had to do the same job. But the accuracy and precision and efficiency of AI agents was much higher than the actual doctors. So we can say that in a few areas of life, AI is beating human being as well. So I hope you guys are a little bit motivated now. And in next lecture, we will talk about that why this is currently now it's the era of machine learning. Why not before that? So up till then, bye. Guys, let's talk about the history of machine learning a little bit. Not a lot, but just a little bit important things. Now, the point is, machine learning algorithms and machine learning breakthroughs were in theories in, let's say, from 1970s or 80s or so. So if we write it over here, so it was from 1980s, and right now it's 2020. Okay, let's see. Now, why after 40, almost 40 years, or let's say after 30 years, we have started implementing machine learning, and why now uh, machine learning has come into play? The answer is machine learning requires two things. One is very powerful machines that can, handle computations very quickly. And before that, we all know um, our machines, our computers were very slow. So we needed that fast hardware. And when theory was there, there was no hardware. But right now we have hardware. Let me give you an example. Let's talk about an article that shows that Google have just released its quantum computer details, and in a CNET article, it says that our machine performed the target computation in 200 seconds, and from measurements in our experiment, we determined that it would take the world's fastest supercomputer 10,000 years to produce a similar output. In short, quantum computers 200 seconds computing is equal to 10,000 years, 10,000 years of supercomputers computing. Isn't it amazing? Can you see where our computing power is going right now? So we didn't had enough powerful machines, but right now we have. The second thing is availability of huge data. Guys, data is like oxygen to machine learning algorithms. So there has to have a lot of data. But when theory was there was no data. Right now, theory is there, powerful machine is there, data is also here. And guess what? Bingo. We are going to implement everything because we have everything. And now machine learning can implement each and every, almost most of the algorithms that are defined in theory. So that's why right now it's the era of machine learning. Now, what is the future of machine learning? If you will get this course, what are the opportunities for you in future? So we can see we can easily see that hard labor jobs are being replaced by machines. Uh, you can take an example of self-driving cars. We can see that a lot of drivers have been replaced with self-driving cars. A lot of labor jobs, waiters jobs in Japan have been replaced with robots who are waiters, and machine learning is implemented even there. And then if we talk about with more powerful hardware, more power of machine learning will be unleashed. We have talked about it. And then gaming will also rise towards a whole new level, guys, because artificial intelligence agents are are beating humans with a huge margin. We all know that AlphaGo and AlphaZero have beaten the world masters of chess and Go with huge margins. So if an AI agent, if there is a match between AI agent and chess king or chess master, uh, AI agent is going to win, and we have seen that in past. You can easily Google it. And finally, no need for human surveillance. Everything will be done by using machine learning. There will be no need of implementing guards on buildings or banks or anywhere. So these are just a few, one of the things that will happen in future, and machine learning will play a vital role there. Now let me take you to a survey of Forbes. Forbes is a very famous auto survey magazine, and Forbes say that let's not read. You can read it if you want, but I'm interested in showing you a few graphs. So if you can see that after 2000, let's say 5 or 2010, the papers written in AI have increased that much. You can see the rise in the curve of graph. And then if we look another thing, if we look about investments after 2010 or 2000, let's say 12, the rise in investment in AI projects, in AI startments, you can see here. So you can easily imagine the future of artificial intelligence or future of machine learning here. Now, here, if you see that, uh, how many startups are there who are developing AI systems? You can see that the graph is rising. And finally, if we talk about jobs, then Indeed.com, let me zoom it for you. Okay, Indeed.com says that this is the rise in the curve of jobs about artificial intelligence in US market. You can see that. And the graph for shares in different countries is also there. You can easily, view it. And then finally, let's talk about the job openings and skills breakdown. Then these are the all AI related fields, and out of all AI related fields, that are machine learning, deep learning, neural language processing, computer vision, and speech recognition, machine learning's job openings are huge than the other ones. So guys, you can read the whole article if you have time. I just wanted to show you where is the future, and future is here. Future is in machine learning, guys. So that's all about this lecture. In next lecture, we will be talking about our course. Enough of motivation now. Enough of talking about past and future. Let's talk about the present. So I'll be giving you the overview of course, what we will be doing in this whole course. Until then, bye. Okay, guys. So let's talk about the course. First of all, after this introductory section, there will be a section, the whole section about introduction to Python. In this section, we will be learning the Python as a programming language from scratch by the studying the core concepts of Python, and then we'll be implementing the mini projects by using those concepts. So Python will be discussed in very detail for the very beginners till the advanced level, so that if we will learn Python good enough, we'll be able to implement anything, any programming related thing by using Python. And after learning the Python, if we will be good enough over here, we will be proceeding toward the introduction of machine learning, which is a pure theoretical part of this course. In this part, I'll be telling you the overall machine learning thing. What is a machine learning overall, generally, not logistic regression. Just we'll be talking about the machine learning thing, from introduction up till uh, advanced level. After that, we will be specifically talking about logistic regression. Now, what is a logistic regression? Logistic regression is one algorithm out of dozens of algorithms of machine learning. Now, why we are going to learn logistic regression in this course? When we will talk about logistic regression, before that, I will be telling you that what are the pros and cons of logistic regression, when you should use logistic regression, and what is actually logistic regression. So once we will be done with the motivation and understanding of logistic regression, then we will be implementing everything that we have learned over here in theoretical part. We will be implementing everything live over in this section, and everything that will be learned in introduction to machine learning part and logistic regression part. And after that, not after that, but even between that, we will be having quizzes as well. And almost in the ending of every practical video, every coding video, I will be assigning you a very little task that will be solved in next lecture. And we will be following this practice in most of the videos, most of the lectures. And then we will be doing a lot of projects, a lot of mini projects in introduction to Python course, and a few projects in implementation of logistic regression, implementation of logistic regression section. So that's about the introduction of course. And let's talk about who can take this course. Either you are eligible of taking this course or not. So let me tell you, if you have a few qualities that I will discuss over here, then you can take this course. If you know very little bit, and if you have a very little bit understanding of English, because our medium of communication is English. If you have very little understanding of English, it's totally fine. I'll try my best to use very understandable words in English, so that uh, even those people who have average knowledge of English, they even though they get my point. And then introductory knowledge of any programming language will be plus. If you do not have knowledge of any programming language, it's totally fine. we will be studying Python from scratch. But if you have any knowledge, it will be very plus. Otherwise, it's totally fine. It's just a plus point. Otherwise, it's fine if you have no knowledge of any programming language, since we will be doing everything from scratch. And then very basic knowledge of mathematics is almost required. You should know the very basic operations of mathematics, uh, so that when we will be discussing the logistic regression in depth, we will be discussing the formulas. This mathematics will be needed over there, but not the advanced level of mathematics, but just very basic level of mathematics. Finally, you should be willing to practice a lot. This is the most important thing, because practice makes the man perfect. I will be instructing you that this is the theoretical part and this is the practical part, and you can do the following sort of thing for your own practice. And I'm expecting that in the end of every practical video, when I will assign a task to you, you will be doing that task honestly by yourself. And I'm not interested if you have done that task or not. I'm interested if you have tried to do that task or not. At least you should try. Let me write over here. Okay, and finally, enough of introduction to this course. Now let's get started in next video. Until then, bye. Hello guys, and welcome back to this new section of our course. We are going to introduce you machine learning. So far, we are done with the introduction of overall course. Then we have done with introduction to Python in a bit comprehensive way, some hands-on coding in projects and quizzes and assignments as well. So I assume that you have got enough knowledge of Python that you can implement any concept in Python. This section will be a theoretical section. We will not be coding anything in this section. We will be studying in a nutshell or in a bird eye view that what is machine learning. And once we will be done with introduction of machine learning, we have already studied introduction to Python. We will be good to go that how and when to implement logistic regression. That is our final goal. So, guys, I hope you are following me along and you are practicing whatever we are implementing up till now. So, let's start our new section, that is Introduction to Machine Learning. So, let me introduce you with the official definition of machine learning first, and then we will try to play around. So, official definition says machine learning is the scientific study of algorithms and statistical models that computer systems use to perform a specific task without using explicit instructions, relying on patterns and inference. Now, it's really difficult and sort of hairy definition. Uh, so I will explain it. What they are trying to say. You just have to pay focus on the words that are written in bold letters. It says without using explicit instructions. If your computer is following your instructions, if your program is making decisions, only those decisions that you have coded in it, it's just called coding or it's called programming. But if your program is making some decisions that are not explicitly defined, that are not explicitly written in the program, this is where machine learning starts. Forget about how machine do it, how we will tell our machine to make decisions on its own. Forget it. We will study how to do it in this whole course. So leave it for now. Just try to understand that what is machine learning? Machine learning is, as this name says, machine is going to learn. It's machine learning. So if we can make our machine good enough that it can learn, and if machine can learn, it can make decisions as well. Those decisions that are not explicitly written onto the machine. So, how do we do that? Relying on patterns and inference. It's really, these are really technical terms that will be explained later on in this course, and I've made complete presentations on it, so do not worry about it. You just have to, get at what is the difference between if else statements and machine learning. If else statements are hard coded. If something happens, do it. If this happens, do it. But machine learning is not if else statements. The thing is same, both are making decisions. But in machine learning, we do not use, the decisions are made independent from if else statements as well. So that's a little bit of introduction of machine learning. And the goal in machine learning is to teach our machine in the beginning, and then in the ending, we will expect our machine to make decisions on the basis of what we have taught our machine. And in this course, we will learn how to teach our machine so that our machine can make decisions. That's a little bit of introduction of machine learning, and we will start from the importance of machine learning, and then we will study why this is an era of machine learning. Why now? We have already discussed it. Just a little bit of recap will be there, and then we will move on. So, history of machine learning. Machine learning actually started in, we can say that it started in late 70s or 80s. The theoretical part was started in late 50s as well. And then the actual work on machine learning started in, we can say that 21st century, because there are two reasons. Number one, the amount of data wasn't enough, and the machinery was not good enough that it can implement those theoretical parts. So now we've got tremendous amount of GPUs and brilliant machines, faster machines, and data is widely available. So it's a little bit about history of machine learning, and then uh, it's most widely used branch of computer science nowadays. Google says this. You will find these sort of statements in a lot of papers, in a lot of blogs. Let me show you one of them that says machine learning is most widely used branch of computer science nowadays. It is used by many industries in automating tasks and doing complex data analysis and so on. You can read it out. You can find bundles of blogs and papers on that says this sort of thing. So I think we're good to go. And again, as I discussed, why now machine learning? Why not 20 years ago? Because we've got powerful machines now, because we've got enough amount of data now, because we have got advancement of technologies and knowledge among the people now. These facilities were not available before. That's why this is going to be an era of machine learning, and it's going to be a very red hot sort of field in the future. That's all from the introductory lecture. In the next lecture, it's going to be a very interesting lecture, because we are going to tell you the difference between how kids learn and how computer learns. So, is there similarity between it, or these are two totally different things? So, we are going to discuss about it in next lecture. Until then, bye. Welcome back, guys. So, how kids learn and how computer learns. We all know that how kids learn. We know kids observe things in the beginning, and then we tell them this is horse or this is a cat. So they make a pattern in their mind that horse looks like this or cat looks like this. So next time when we ask them, what is this? They can recognize it. Okay, it looks like horse or it looks like cat and so on. Do computer also do it? How can computer do it? Uh, we will study. The whole course is pending. We will study it, how computers do it. But first of all, let's try to differentiate it. So, how kids learn? Kids learn by observing, listening to various things, and recognizing them without following any set of rules. Now, this set of rule is different for any kid. It will be different for different kids. That's why we say that IQ level or EQ level of every person is different, because they have different set of rules to recognize the things. For example, a few kids recognize this letter. It says A, and we tell kids, okay, anything looks like this will be A. And if we will ask our kids, okay, what is this? Sorry. So if we will ask our kids, forget it. Let's not discuss it. So if we will ask our kids, what is this? They may not be able to recognize it, but because they may know that A looks like green and it has edges and it's really neat and clean, but it's red color and it doesn't look like this actually. So they may say it's not A, it's anything else than A. So maybe some kid says it's B because B is red. Then we will, uh, kids will make mistake in the beginning. Then we will tell them, no, 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 no. You do not have to differentiate on the basis of colors. You have to differentiate on the basis of shapes. Then kids will try to, change their set of rules. They will try to learn some new things out of it, and then they will try to recognize these things. Then they will reorganize the model in their mind. You have to pay attention to this word. Then they will be reorganizing the model in their mind, and then they will say, okay, so anything looks like this, not exactly this, but anything looks like this will be A, and anything looks like this will be B, and so on. So kids make their own set of rules for everything. And that's how they learn by observing. They observe a lot of things. First of all, they observe something like this, and then they make a wrong decision, and we correct them. Like, it's wrong. No, no, it's wrong. It's also A. So they reorganize them, they learn some new things out of it, and then they start making decision. And if we ask them, okay, now tell me what is it, they may be able to recognize next time that this is A, although it looks like different from both A's, but they may be able to recognize it. And if they will not be able to recognize it, we will again correct them. And then for the next time, maybe they'll be able to successfully recognize it, and so on and so forth. We all know that our kids learn like this. Now come to the computers. How computers learn. It's actually almost the similar sort of things. A few scientists says that machine learning is just like a 7-year-old kid. It's as intelligent as a 7-year-old kid. And in the upcoming era, it will be as intelligent or perhaps much more intelligent than an adult human being. So it's just hypothesis. I'm just quoting a few scientists. So how computer learns? Computer learns by algorithms provided to it, following a set of rules for observing and finding patterns from the given data. Now, computer also learns by finding some patterns, and these patterns are made on the basis of set of rules that we provide them. For example, if we provide this letter A, our algorithm may learn something like this. Everything is 0, this gray color will be 0 and this black color will be 111. Okay, like this. And then if we will tell our computer to recognize something like this, sorry, ignore it, something like this. And now this looks a little bit different. Let me clean it up a little bit. So here we go. So if we ask a computer to recognize something like this, yeah, so it's exactly not the similar pattern. It's not the exact similar pattern, but it looks like the same. So again, if computer has learned a model in computer's mind, in computer's mind, that anything strictly like this will be A, then it's not A. Computer will make a mistake. We will correct our computer that, okay, you do not have to be that much strict, but something like this can also be called A because they looks like same, almost same. So computer will just learn like a kid because we have provided some data to it. Before that, computer knows only this is A. Now computer knows that this is A and this is also A. So anything in between them or around them can also be A. So it learns a new thing. For now, I'm again requesting you to not pay attention how it will learn. I mean, it's a question that how computer will learn. Computer has no mind. It's right. We human have mind, and computer do not have the similar mind as we have, but it can act as similar, almost as similar as our mind. So it's just an example how kids learn and how computers learn. Let's try to differentiate. Let's try to find some resemblances in the learning of computers and humans. So both are learning on the basis of data given to them. In the childhood, kids make a lot of mistakes because they have very few data, very few experience of life. As far as they live their lives, they have more experience, they have more data, they make few mistakes in recognizing things. I'm not talking about the philosophical mistakes, but I'm talking about categorical things. Another thing is in the beginning, both will make mistakes. As I said, the data will be lesser, so they will be making mistakes. And to the kids, their elders will be correcting them, and to the computers, their programmers will be correcting them. Uh, as far as machine learning is concerned, programmers will not be manually correcting them, but programmers will be uh, writing such an algorithm that algorithm will correct our program or machine learning models. Another thing is, if data is not clear, now what do we mean by data is not clear? Data can be wrong. For example, if we will tell our kid that this is B, this is not A, this is B. Now data is not clear, data is wrong. Now the chances of making mistake by a kid are higher. Just the case is with computer. If we will input the wrong data, it will not learn good things, and vice versa. Which means if we will provide very good data, if we will say this is A, everything correct and accurate, it will learn very good things. It's directly proportional. Learning is directly proportional to the amount of data as well. As we said that in the beginning, experience is lesser, data is lesser, so learning is also not that much accurate. As far as amount of data increases, learning also increases. Both cases, in the cases of kids and in the cases of computers as well. So this is a little bit of groundbreaking and roots of machine learning. Uh, I just wanted to make it a little bit I just wanted to compare kids versus computers, and we have not gone into the hardcore concepts of machine learning now up till now. From next lectures, we will be studying a few technical terms that we use for machine learning, and I think we are good to go. We have got enough of motivation, enough of this comprehensive background knowledge of machine learning. Now we will be doing the exact terminologies, explaining exact terminologies that we use in machine learning. Until then, bye. Hello, guys, and welcome back. Today, we are going to dive into the hardcore topics of machine learning. You just do not have to worry about it. I will make everything very simple for you, and I'll try to relate everything to our daily models, whatever we see, whatever we observe daily in our routine life. So these are a few fundamental things that we use in machine learning. Dataset, what is dataset? I'll define it later. Training data, testing data, outliers, model, training a model, overfitting, underfitting, labels, features, accuracy, and error. You may not be familiar with any of these terminologies or a few of these terminologies. So I'll be explaining every terminology for you. And as you know that, uh, as a few of you may know that, these terminologies are the basis of machine learning. If you have enough knowledge of these terminologies, you can say that you have very good basis of machine learning and you're good to go. So let's start from dataset. Dataset is the most important thing in machine learning. So what is a dataset? Let's start. So dataset is nothing, it's just a collection of data. And dataset is a table actually. And we know that every table consists of rows and columns. So every column represents a variable. As you can see that this is a column, this is a column, and it is representing a variable outlook. Okay, and every row represents a record. This is a row, and there are a lot of rows here. Every record represents every row represents a record, and every column represents a variable. For example, this column represents the values of outlook. This column represents the values of temperature, and so on. Each value in dataset is regarded as a data point. Now, this is one data point. This is, sorry, so this is another data point, and so on. Why these are called data points? Because mathematically speaking, when we plot these points on a map, let's say a 2D map, let's imagine in a 2D map, because imagining in 3D map is a little bit difficult. If we plot this temperature on y-axis and humidity on x-axis, then this point, this 85 may lie somewhere, maybe here. Let me change its color, somewhere here. Okay, so it will be a point, it will be a point somewhere in the graph. That's why we call it data point as well. And since this whole table is a collection of data points, that's why we call it a data set. The last column of data usually contains, not always, but usually contains labels. So this is the last column here. It's just a common practice. That last column will be containing the labels. Now it's a separate question, what is a label? Our next topic is what is labels. I will be defining you what are the labels. But for now, it should be understood that the good data sets contains label at the end of uh, in the last column. So that's all about the introduction of dataset. And in next lecture, we will try to study what are the labels. So until then, bye. Okay, guys. So far, we have got a little bit of introduction of dataset. Now we need to know what are labels and what are features. Labels and features. These two are the terminologies that are interlinked. This one data set contains of labels and features, not every time, but there, if we are talking about supervised machine learning, then this table will consist of labels and features as well. Now, what is supervised machine learning? Later on, we will be describing what is supervised machine learning and what is unsupervised machine learning. So if it is unsupervised machine learning, then there will be no labels. Why there will be no labels, I'll discuss it later. And how can we predict something without getting the label? Uh, can we do that? It's a question that will be answered later. But right now, we are discussing about the supervised machine learning, where we will be having a data set that will consist of features and labels as well. So, what are the labels? Let's try to study. So, a label or target label is also called target sometimes. So, a label or target is referred as the output of data. Now, if we see in our previous table, this is the output of data. If these four fields are, if these four fields can act like, can act like input, then this will be the output. For example, if outlook is sunny, temperature is 85, humidity is 85, and day is not windy, then we will not play. It's just an output. So label is the output of certain data. A labeled data contains label, which can be any output to classify the data, such as cats or dogs, etc. Just we have been classifying the data. If this will happen, I will not play. If this will happen, okay, I will play. Same the case is here. We can classify the data like if color is something like this, if look something like this, height is like this, width is like that, then it will be a cat or it will be a dog. So I hope you're getting my point. Or on the other end, we can also do that if a certain email will contain these much letters, these sort of words, then it will be a spam email. Otherwise, it will be a fine email. It's just an example. When a model is trained, it predicts the label of the given data, also known as classes. So we have got three names: label, I need to remove it. So we have got three names, that is classes, that is target, and label. These are interchangeable terminologies. Do not get confused if you are reading any other book or following any other tutorial. These are interchangeable terminologies that means the same. In machine learning, if labels are not numeric form, then we convert them into numeric form. What does it mean? For example, if label says apple and label says pear, etc., we cannot feed apple to a computer, because computer does not know what is apple, computer does not know what is pear. Our computer only works in mathematics. It knows the mathematical terminologies, the numbers, the integers. So if our labels are in English letters, then we convert them into the mathematical letters. For example, if we go to our data set and we see label is don't play, so we can label it like, let me clear the screen. Okay, so if label is don't play, I can say it is 0. If label is don't play, I can say it is 0. If label says play, I can say it is 1. It is also 1. It is also 1, and so on. So yeah, it's a little bit funky sort of one. Let me remove it, and let's say 1, 1, and 1. So and so on. You can label it out. Now the question is, if labels contain English letters, we have to convert them into numeric letters. The reason I told you, because computer does not understand this English. Computer understands only numeric language. So that's why we have to convert it into the numeric language. So guys, that's all about the labels. If you still have a little bit of, um misunderstanding or ambiguity about labels, let's talk about features first, and then we will merge these both terminologies together. I hope you will get a better understanding. So what is a feature? So far we have discussed only this part of dataset. Okay, we have not discussed about this blue box of dataset. So let's discuss about this blue box of dataset. Let's go to features. So a feature is an individual measurable property or characteristic of a phenomena being observed. So this is our red hot word, observed. Previously we used the term data points. In machine learning, data points are formed by features. So if we go back to our slide, here you can see that these are the features, these are the data points that we have observed. Someone has observed that if outlook is sunny, temperature is that, humidity is this, windy is yes or no, then I will play or not. These are just the observations. These are the observations. Features are made by observations. So a feature is a finite number which is observed by observer. In the beginning, we discussed about how kids learn. If you tell a kid that this is a kid will extract, kid will observe it in a way that if you will ask him later, this is what is this? He may get confused with it. So if you will tell kid that this is A, this is also A, then later on maybe kid will be able to tell you this is also A, because until now kid has observed a few features out of it. Maybe features can be the shape of this A and shape of this A as well. Maybe some kids are very obsessed with colors. They get to know that okay, anything red is A. So they may make mistakes when you will tell them, okay, tell me what is this. Okay, so it totally depends on how you observe anything. Features are just the observations of thing, and labels are the output of that observation. For example, this is the observation, what its shape, its color, etc., its size as well, maybe. And then the output that we will tell the kid this is A, the output A is the label. And same thing is written here. There are a lot of feature extraction techniques available in computer. As I told you, kids can learn by many ways, the many sorts of observations. And the computers, we have got a lot of feature extraction techniques by which we can make our computer to observe what is it, so that later on computer configures out, okay, this is A, this is also A, this is also A, this looks like A as well. Performance of model depends a lot on features that we have selected. If we will select wrong feature, for example, it was a wrong feature that any red shape will be A. It was a wrong feature because blue shape can also be an A. So selection of feature is very important. Color cannot be a good feature in if we are recognizing the letters. maybe shape can be a better feature, maybe size can also not be a better feature. So let's go back to our data set. Let's remove it. So if these are the features, if these are the features and these are the labels, now what is the connection? I will tell my machine if this will happen, then this will be the output, and so on and so forth. Okay, and everything. Then I will feed another observation. My computer will learn something out of it. What it will learn, we will talk about it later when we will be discussing about models. But computer will learn something out of it. Let's assume this, and then when I will say my computer, okay, tell me if day is rainy. Let's say R. Temperature is, let's say, 50. Humidity is, let's say, 40, and windy is, let's say, true. Now, computer, please tell me, should I play or not? How computer will tell me? Because computer has observed a few observations from here. Now you can see that this combination is nowhere in the whole feature set. It's a new combination, but our computer has learned some things. Just like a kid has learned this is A, this is also A, and it also looks like these, so it can also be A. So just like that, our computer will also make some inferences, some predictions that, okay, if these are the conditions and these are the respective answers. So if now if this is the condition, maybe this will be or that will be the answer of it. Maybe you can play, maybe you cannot play. Now, how computer decides, again, this question may bothers your mind a lot. How it will happen? Please calm down. We have we have this slide over here that will tell you how it happens. Model, we train a model, training a model. I will tell you later. So it's all sorted. Do not worry about it. So far, you just have to know that what is dataset, what are the labels, and what are the features. This is a table. These are the these are the features. Now these are the labels or classes, or there is another name for it. What is that name? Target. It can also be called as target as well. So I hope you understand now. Our next topic is splitting the data. What is it? We will talk about it in next lecture. I hope you are getting my point and you're understanding it. If you're not understanding it, you're ambiguous at any point, feel free to ask questions. I will answer your questions and I will try to make my things clear to you. Until then, bye. Okay, guys, today we are going to learn splitting the data. We know what is data. Data corresponds to data set. And what is splitting the data in machine learning? We split our data into two categories: training data and testing data. Why do we do that? Let's think about a student that is in, let's say, first or second standard. We teach our students the addition questions. We tell our kids that 2 plus 2 is 4, and so on. We tell them a lot of examples like this. It's sort of a training of student that goes on for the whole semester or for the whole session. But how can we evaluate the student if student is getting or not? If student is, how many of the students have learned the way how to add up the things, how to add up the numbers actually? How can we evaluate them? It's called training. Let me say TR, denoted by TR. It's training. Kid is right now. He's training. He trains for, let's say kid trains for 4 months, and now we have to examine that kid has learned addition or not. We may not give our kid the same set of, the same set of questions. We may give our kid a different set of question with the same logic. We will say, okay, you have learned enough. Now tell me, what is 2 plus 3? And if kid is able to answer the question correctly, then we can say, yes, kid is working fine. So what is this? This was training. And what is it? It's testing. Let's denote it by TS. So in order to evaluate our student, how it's performing, how it has been learning, we evaluate our student on certain criteria. First, we train the student, then we test the student. Same thing happens with machine as well. What happens with machines? Let's talk about the training of machine. A machine learns from data. It finds relationships and patterns from data. So how machine learns from data will be discussed later, but for now assume that machine learns from data and it finds relationships and patterns. The data provided to machine to learn and train itself is called training data. Just in our previous example, what was the training data? 2 plus 2 equals to 4 was the training data. We can say these are the features. No, we cannot say that. Actually, it's a mathematical thing. So we can tell our kid, if something like this happens, that's how you have to respond. Kid will learn, student will learn. So this is sort of the training that is happening for student. This is sort of the training data that is working on student. And what about the testing data? Let's talk about that. Once the machine is trained, so machine has to be trained before we test it by using training data, of course. In order to test the machine, if it is working fine or not, we have to test the performance of machine as well. We use another set of data, which should not be the same data on which the model was trained. Because if we will train our kid on 2 plus 2 question, and training has been done on 2 plus 2, and while testing we again tell our kid, okay, tell me the answer of this. The student may be able to easily tell us the answer of that question, but it will not be fair. It's like of remembering by heart rather than learning the mathematics. So testing has to be done on a different set, on a different data set. If we talk about our example that we were talking about, let's say we can say this much of data will be used as training data, and that much of data will be used as testing data. Let's say TS, let's say TR. Perfect. So first of all, we will train our machine on this data, and then we will evaluate our machine on this data. We will feed this data set, this record or data point, that much record and data point to our machine. We already know its answer, and we will expect our machine to return, to output an answer, to output a label, to output a target. If that output matches this, if output says play, then we can say that, okay, machine is performing well. And we cannot, of course, we cannot get the accuracy of our machine by just testing our machine on one record. We have to test it on several records, so that we can assume, we can get an idea how better our machine is working or how worse our machine is performing. So here is a question. What should be the, for example, I have 100 records. I have a data set of 100 records. How many of these records should be used as training data, and how many of them should be used as testing data? The answer is, the convention that we follow usually is, for training data, we use 80% of data or 80 records if we have 100 records. For testing purpose, we use remaining 20 records. So first of all, our machine learns on 80 records, and then we evaluate the performance of machine on 20 records. If the out of 20 or out of 20 testing set, machine has returned, let's say, 10 satisfactory answers, 10 correct answers that are correct answers, let's say they are 10, and 10 answers are wrong, we can say that machine is performing 50% right and 50% wrong. That can be an evaluation criteria. We may have different evaluation criteria as well, but it's an idea how training and testing data sets works, and why we split data into training and testing data. So whenever we train our model, we feed our model with the training data. Whenever the model has been trained, we want to test the performance of our data, we feed it with a new data, that is testing data. So guys, that's all about training and testing data. In next lecture, we will try to know what are the outliers. Until then, bye. Guys, this is our last lecture where we will be discussing about data again. And from next lecture to onwards, we will be discussing about model. The model that, how actually machine predicts something, how we train our machine. Model is about that. And so far we were discussing about the data set, features, labels, training data set, testing data set, and now finally we are going to discuss outliers. So in the data set, it may contains a few points that are very different from the normal points. For example, if we say this is the data, let's say we are talking about the data that contains the ages of people. And we know that the maximum age of a human being can be, let's say, 150 years, or at max it can go to 200 years. I'm talking about 21st century. So no one's age can be more than that under normal circumstances. And if my data contains an age that is like 1,000 years, so I will get to know that now this is an outlier. As you can see that all the data points are here, but I found one data point here. It says it can be an outlier. It will most probably be an outlier. And how outliers are produced? For example, if someone is typing the data of ages of people, that person mistakenly typed 1,000 instead of 100. He just typed 10 more than the actual ones. So if the actual age was 100, if that person typed one more zero, it becomes 1,000. So it most probably it can be done by human error. There can be other reasons as well. So how can another example can be, if we go back to our original data set, another example can be, we can see that temperature is normally 85, 80, 83, 70. It doesn't exceed 100 here. But what if I find something like temperature is 500? What will you do? Will say it must be a typo, or maybe the equipment that is measuring the temperature is it's not accurate, it's not fine. We should replace our hardware or something. So these kind of things are called outliers. And from our data set, we have to remove our outliers. How can we detect if the data set contains the outliers? Should we, if what we were doing here, should we examine the every field if it's that, if it's fine or not, it's fine or not? Should we do that? Obviously, no, we should not do that. What should we do? We should be using visualizations tool. Um, when we will start our algorithm that we will be implementing, in our case, it will be logistic regression or random forest or whatever the algorithm you implement. There, I will be telling you some data pre-processing techniques and I will tell you how to visualize the data. For example, here there is a data visualization. These are the x-axis, these are the y-axis, and here is the data. Let me say it's y. So here's the data and it's visualized. We will visualizing the data. We will do something in Python so that we can visualize the data. And you can easily see that there is a point that is very different from the ordinary ones. So you can say that this is an outlier and we can easily remove it. How can we remove it in Python? We will be doing it in upcoming videos. But for now, you need to know that outliers are not good. We have to remove them. So that's all about data, guys. From next lecture, we will be discussing about the model. The most anticipated thing that we waited for is model. How we can train our machine, how machine observes, how machine learn from observations. We need to give you the answer of this question in next video. Until then, bye. Hello guys and welcome back. Today we are going to learn what is model. So far we are done with the data and data set and data related terminologies of machine learning. From now to onwards, we will be discussing about model. In previous lectures, I kept telling you not to worry about how machine learns. And I told you that I'll explain it later. So it's time to explain how machine actually learns. So a machine learning model is a mathematical equation or expression that tries to fit the data and learn to predict the unseen data. So here are three things to be noted. So a model is a mathematical equation. It's nothing other than a mathematical equation that tries to fit the data and learn to predict. First of all, it tries to fit the data, that is training data, and then learn to predict the unseen data. For example, let's say this is the employee's happiness index, this on x-axis, and on y-axis, it's employee's productivity. The more employee will be happy, the more productivity will be increased. It looks like a directly proportional relationship here. So we already have, let's say, data of a company that says if employee is this much happy, then productivity will be that much. If we are talking about this point, and so on. So we somehow, let's say it's a black box, somehow we knew that it's going to be a straight line that fits into all the points. Now, if I want to know that if my employee is that much happy, what will be the productivity of my employee? I can easily know that by extending this line to this yellow line to this line on x-axis, and then we will extend this line to y-axis, and this will be the point of productivity of my employee who is that much happy. So as you know that our machine learning algorithm did not know what to predict at this point. It was a totally new point. We can say that it was a testing point for our machine. So, but it is successfully predicting the productivity of employee. Why? Because we already had a model. This line is our model. Let's denote it with M. Now, question is, how can we decide that, by visualizing this data, we can clearly see that this is going to be the line. How can we know that if it's going to be a line like this or a line like that, or this sort of line, or any sort of line? How do we know that? So this is a question, and that is where you try to train your model. So for the answer of this question, I will only say, how can you decide the model? How can you train the model? It totally depends on your algorithm. I'll denote it by AL. Now, what is an algorithm to train the model? There are a lot of algorithms available that allows us to train the model differently, that have their own, their own pros and their own cons. So, how do we know that which model is best for our data? I will explain it later. Which algorithm will be best to train the model? Obviously, that algorithm will be best, which will give you, the best accuracy, the better results, and the low error. Now, I just said accuracy and error. What are these terminologies? That will be told later in the slides, as you can see over here, accuracy and error. So let's leave it for now. Let's try to discuss the model a little bit more in depth. So let's say this is a line, and we know that equation of line is y equals to mx plus c. We know that. And let's say we want to predict, let's say, extend this line over here. We want to predict the happiness, the productivity of employee if happiness is this. Now we will extend this line a little bit. We'll draw one more line over here, then we'll go here. And this will be the happiness level of employee. Let's say this is 10 on x-axis. So we will say m multiply by 10 plus c. Now what is m and what is c? These are the hyperparameters that we will have to learn, that our model have to learn. For example, for the time being, we will say m is equal to 1 and c is equal to 0.5. So let's say 1 multiplied by 10 is 10 plus 0.5. So our answer will be 10.5. It's simple mathematics, which will be on y-axis. That's it. That's how you learn or you train a very basic sort of model. It's a very basic sort of model. We also call it a linear model mathematically. If you don't understand it, leave it. Do not worry about it. So that's how we train our model. It's as simple as it look like, but as we've seen that we've got sometimes we have got multi-dimensional data. Here we had only two-dimensional data, but sometimes we have three-dimensional data or four-dimensional data. So we do exactly the same thing, but in multiple dimensions. It is almost impossible to visualize the four dimension over here on the screen. That's why I chose a very simple example for you, so that you can learn how can we train our model. Now, training a model, let's discuss it a little bit. And the example that we are going to follow is spam email and not spam email. So we will say, let's say this is a spam email and this is a normal email. So the process of trying to fit the training data into a model through a machine learning algorithm to achieve a pattern in the data for predicting an unseen data. Our goal is to predict the unseen data. It's known as training the model. First of all, we train our model. That's the part where we are training the model. it's same model, this is same model. Training data is also same. When we will input such a mail that is normal, our model that has already been trained on training data will output that it's a clear email. Let's denote it with green. And if email is spam that has already been learned our model from the training data, our model will say, no, 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 no. It's not a good email. It's a spam email. So that's how we do it. And that's all about model and training the model. In next lecture, we will try to learn what is overfitting and what is underfitting. Until then, bye. Guys, today we have to discuss overfitting and underfitting. Before moving on toward the slides of overfitting and underfitting, we have to look upon this model. We can see that this is a very beautiful sort of uniform sort of data that can be, just a line can separate a line can be a good model for it. A straight line can be a very good model for it. But sometimes, or perhaps most of the times, it's not the case that one straight line can fit the data. Here you can see one straight line cannot fit all the points, cannot touch all the points. By fitting the model, we mean have such a line or a curve that touches all the point, or at least it passes most closely to most of the points. The difference between points and curve or points or line should be minimum. Ideally it should be zero, but it should be minimum. Now you can see we have two examples. One, this blue line, this blue actually curve, very hairy sort of curve, and a black line. Now let's read it out a little bit. What is overfitting? Overfitting is a modeling error, modeling error when we try to model our data, our training data. It's a modeling error when model performs very good on training set, but it does not perform well on testing set. Now question is why it happens. Overfitting occurs when the model is very flexible. This is the point to ponder. When model is very flexible. By flexible model, we mean it's a curve, it's a very flexible curve. You can see that it's really a flexible curve as compared to this straight line. It goes like this and that, and it's really flexible. Let me remove it because it will redirect us. So, and is forcefully fitted. It's been forcefully fitting to all the points, forcefully touching all the points to the most of data in training set. In overfitting, the model shows high variance but low bias. By variance, in short, by variance we mean this flexibility of the line. A very good example is cramming the syllabus just before the exam night. So if a student will not study whole year and student will be just learning by heart, try to learn by heart, try to cram the syllabus just before the night, and let's say student will cram that 2 plus 2 is 4, just like our old example, and in exam it comes 2 plus 3 is what? Student will say 4. Now student performed well on training data here, but student does not perform well on testing data because student was not understanding the concept. Student was just paying focus to the result, to the answer. So it's just an example. It may be a good or bad example, but that's how you can put overfitting to a real life example. So what should we do? If data is overfitting, what should we do? And there is another thing that we call underfitting. Let's remove it. Okay, so what is underfitting? Let's first of all study these both concepts and then I'll tell you the solution. In overfitting, we try to fit the very flexible model. Now the underfitting is exactly the opposite thing. Here, even if the data is, this sort of data can never be separated with a straight line. It doesn't matter how you will put the line into it, you cannot separate the complete data by a straight line. You have to have, sort of, let me try, sort of, you know this sort of line, not exactly the, it should be a little bit smoother here, this sort of line, that will separate the most of the points, not every point but most of the points. Straight line will never do it, this sort of straight line, it will never do it. So it's called underfitting. So underfitting is when model does not perform well on training set, neither on testing data. Obviously, if model is not performing well on training set, if it's not training well, how is it supposed to perform better on testing set? Underfitting occurs when the model is not flexible at all. Now here is the problem. When model is flexible, we have this overfitting problem. When model is not flexible at all, we have underfitting problem. So what's the solution? The only solution is you have to find a middle way. You have to avoid overfitting as well as underfitting. You have to you have to get a model that is not very flexible, and you have to get a model that is not flexible at all. You have to look upon your data. It totally depends on your data. For example, maybe this is a good model, this is maybe this is a good model for some sort of data, but it's certainly not a good model for this data that we are looking at. So overfitting and underfitting can be defined by looking upon the model. If model is very hairy and we have to get, very flexible sort of model for that data, then we have to get that flexible model. But if the model is here, you can see that the model can be fitted by, a straight line can be a very good model. So why we are going for that much flexible line, and the vice versa here? We need a flexible line over here, but why we are sticking up with this straight line? I hope you understand the pros and cons of both overfitting and underfitting, and I hope you understand the solution as well. How can we avoid them? We have to find a middle way. Guys, we are just studying the theory over here. The practical implementation will be in the next section. So do not worry. All these concepts will be covering programmatically as well in the next session. So far you just have to understand the theory. You just have to build some concepts over here. In next section we will programmatically implement it. Do not worry. It's really very easy to understand, to implement it in Python. But before that, you have to have the theoretical knowledge of these concepts. Otherwise, the programmatical knowledge of these concepts will not be very beneficial for you. In next lecture, we will try to study accuracy and error. So until then, bye. Today we will try to learn what is accuracy and what is error in our machine learning perspective. Accuracy and error is, it's self-explanatory sort of terminologies. The meaning of accuracy or error in machine learning and in our daily life is almost similar. But the question is, how do we measure the accuracy or the performance of our model? So accuracy is also known as classification accuracy or accuracy of a model, just a terminology. So you can read it out. It's simple. So let's say we have tested our model on 10 samples or on 10 records. Out of 10 records, our model predicted 8 records, 8 records in a good way, or it correctly predicts 8 records out of 10. It results in 0.8. Then we will multiply it with 100, and it will result in 80, which is, we take it in percentage. So our model will be performing 80%, our accuracy of model will be 80% if 8 out of 10 predictions are correct. And that's how you can, here the formula is also given, that's how you can predict or you can actually calculate the accuracy of your model. Now, error is just the opposite thing, but the formula is almost same. Instead of finding the correct ones, here you have to do something like this. Let's say total testing samples or testing records are 10, and out of 10 there were 30. Let's say there were 3 wrong predictions. Now in accuracy you write correct predictions here, but in error you write wrong predictions over here. So it results in 0.3. You multiply it with 100, it gives you 30%. So the error of model will be 30% if 3 out of 10 predictions will be wrong. And a model is known to be a good model if error rate is close to 0. Our goal to train a model is that our error rate should be close to 0. Ideally, it should be 0. How can we do that? Let's say initially we trained a model that had error rate 30%. Then we will do something. Let's say we will learn a new model. Let's say in the beginning it was a straight line. So let's say it's a graph. So in the beginning, our model, let's draw our model with a different line. Our model was a straight line, and it was giving us, let's say, 30% error. Then we learned that no, it's not a better model. Let's try to learn a new model that has this sort of line. And we let's say it gives us error of 10%. So we obviously know that 10 is better than 30. So we will take this model rather than the yellow one. And let's say if there is a model that gives us error rate even less than 10, we will take that model as well. So error and accuracy, they allows us, or they helps us to select the better model for our data. We can train a lot of models, we can have a lot of algorithms. That algorithm that will give us the lower error rate and higher accuracy rate will be the best model for our data. It's quite possible that this line will perform very good on a certain data but will not perform very good on another sort of data. So models are data dependent. Models depends on the behavior of data. So you have to have a different model, most probably a different model for every different data. And error and accuracy, these two are the things that helps us to pick up the best model for the certain data. So that's all about the terminologies of machine learning that we started. In next lecture, we will try to dive into more depth concepts of machine learning. We will study the formats of data. There are two types of data, that's structured data and unstructured data. We will be focusing on this structured data. Now, what is the difference between structured data and unstructured data? We will discuss it in next lecture. Until then, bye. Today we will discuss that how important the data is for machine learning and what are the formats of data and how can we choose the best data for the best format of data. So first of all, in previous lectures, I told you several times the most important thing in machine learning is data. If you have good data, what do I mean by good data? A good data is that have these properties, let's say these properties. We will discuss it in a bit, but for now, A good data is that is consistent, that is reduced, that is normalized and stuff. But a data has to be very good. If you've got a good training data, the machine learning will the prediction of machine learning model will be great. If you have got bad data, the predictions of machine learning model will be worse. So there are two types of data. One is labeled data. Labeled data is such type of data that we have discussed previously. If we go back a lot of slides over here, here you can see we have labeled data, a data that has labels. We already know what is label. I recorded a lecture on labels, and you knew that this is a label lecture. Now, a data that has features along with labels, it's called labeled data. And such a data that does not have these labels, it just have these features but no labels. It's called it's called unlabelized data, or the other name for this data is unlabeled data. So let me remove it from here. So there are two types of data. Basically, structured data. Structured data is such type of data which is in a tabular form that we have just seen in a column and rows format. That is called structured data. And a structured data will have it can have labels in the most probably in the last column, or it may not have the labels anywhere in the data. We will be dealing with both types of data, labeled and unlabeled data in machine learning. We can do that. And as far as we are talking about unstructured data, we cannot deal with unstructured data in machine learning. We have to convert the unstructured data into structured data before dealing it in machine learning. Unstructured data is a data that cannot be represented in this tabular form, in a table form, in rows and column format. So now the question is, how can we choose the best format of data? We have to train a machine learning model. What will be the hierarchy of getting the data? First of all, we have to articulate the problem. We should know that what type of data do we need. If we want to recognize human faces, we should not be getting the data of their salaries. We should be getting the data of their faces. If we want to discriminate between the spam and not spam emails, we should not be getting the data of WhatsApp messages. We should be getting the relevant data. Then establishing the data collection mechanisms. That mechanism can be data mining, that's a separate field. That can be a manually entering of data, and so on. Then we format data to make it consistent. Data should be consistent. By consistency, we mean that one column should contain only data of one variable, and one row should contain the record of one sample only. Then reduce the data. You should not be keeping the outliers in it. You should not be keeping the irrelevant data in it. Then decompose the data. Decomposition of data and formatting the data is almost the same terminologies. Then normalize the data. By normalizing, we mean that if we have a column of, let's say, age and a column of salaries, okay, we know that maximum age can be, let's say, 100 years, obviously, but salaries can be, let's say, 50,000 as well, or much more than that. Now, there is no comparison between both of them. It should be scaled, it should be normalized. And how can we scale it? There are mechanisms available for normalizations of data. When we will study the logistic regression or random forest in next section, I'll be telling you how to normalize the data. the normalization techniques will be discussed there, but you have to normalize the data before you put it into the machine learning model. And finally, discretize the data. What do we mean by that? For example, if our label is, let's say, age, salary, mm, let's say our model is, uh, our label is sex, and it says male, then it says female, then it says female, male, and so on. Now, again, as I told you before, computer does not understand this language. This is English. Computer does not understand it. We have to convert it into numbers. We have to discretize it. What do we mean by that? We have to say, let's say, male equals to 0 or 1, female is equal to 1, and so on, or vice versa. So that's how you choose the best format of data for your machine learning algorithm. That's all about data, guys. In next lecture, we will study the types of machine learning. There are two types of machine learning: supervised learning and unsupervised learning. So we will discuss it in next lecture. Now, what are the types of learning? One is supervised learning and the other is unsupervised learning. Keep in mind, we have already studied the difference between labeled and unlabeled data. By keeping those terminologies in mind, we can easily learn what is supervised learning and what is unsupervised learning. A supervised learning is such type of machine learning in which the data is labeled. We know that what is labeled data. If we do not know that, you have to listen to probably the second last lecture again. So if the data is labeled, then we will apply there are some set of algorithms that we can apply on them. The algorithm of supervised machine learnings have totally different mechanism. So think of these supervised machine learning algorithms as a teacher. Just like a teacher teaches you that 2 plus 2 is 4. A teacher teaches you this so that you can perform an exam. 2 plus 3 is 5. So a teacher teaches you, a teacher supervises you to do so that you can perform well in testing or in exam. Supervised machine learning takes data that is labeled, so that it knows that, okay, this is apple, something looks like this apple, something looks like this is banana, and so on. On the other hand, unsupervised machine learning is a type of machine learning where data is not labelized, data is unlabeled. For this category of machine learning, for this type of machine learning, how we can separate things. That's how we can, in this scenario, task of machine is to group unlabeled data. This is the important thing. For example, we are given with a basket of fruits where we have to separate each and every fruit. For example, basket contains these much fruits. We can see and we do not know that it's called banana and it's called orange and it's called strawberry. We do not know that. So we may be able to classify them. We will be able to group them or separate them on the basis of their shapes, maybe, or on the basis of their colors, maybe, or basis of their size, maybe. So this the base on which we will be separating them, it totally depends on the feature, what features we are being fed to. But the main thing, the main difference between both of the types is the data that will be available. If data is labelized, then it's supervised learning. If data is not labelized, then it is unsupervised learning. Now the question is, if data is not labelized, how can we train our machine for predictions? That is a valid question. We cannot tell our machine that, okay, this is apple, this is how it looks like, this is strawberry, this is how it looks like. So far we have just seen that we tell our machine, we tell our algorithm we tell our machine by using the algorithm that anything looks like this is banana, anything looks like this is strawberry. But right now we cannot do that. We cannot tell our machine that it's banana or it's strawberry. So how do we do that? Guys, I'm not going to answer this question right here. We can answer this question wherever we will implement any unsupervised machine learning, because it's a totally separate topic that can be discussed, where we will study any algorithm like clustering or k or any k-mean algorithm or something like that. So that's all about the types of machine learning. In next lecture, we will be studying the modes of machine learning. We have got three modes of machine learning: classification, regression, and clustering. Until then, bye. There are three modes of machine learning: classification, regression, and clustering. So far, we have studied the types of machine learning. These two modes belong to supervised machine learning, and this mode belongs to unsupervised machine learning. So let's start from classification. Classification is a branch of supervised learning, where we already know that supervised learning requires labelized data. A classifier predicts the class of features given to the model, such as 0, 1, or spam or not spam. In other words, classification is a problem where we can clearly classify, or where our model is able to tell something categorical about the result. For example, our model can tell us if you can play or not. I'm referring toward the previous example that we were following. If day is sunny, temperature is that, humidity is this, then we can play. Our model will be telling us, okay, you can play now. Our model can tell us if an email is spam or not spam. So this is classification. Here you can see that we will draw a line, and then we will ask our model, okay, tell me about this point. If it is on the right side of line or left side of line. Let's say this is the spam email. Let's say this is the not spam email. If we are talking about this point, our classification algorithm will tell us it is spam. And if the point will be something like this, our model will be telling us it is not spam. Let's discuss the second mode of machine learning, that is regression. On the other hand, regression outputs a real number or a continuous value rather than a categorical value. For example, if we have to know that, let's say this is a graph, here are ages, here is salary, and let's say this is the line, and we can say that, okay, tell me the salary of person who has this much of age. We can say, okay, this will be the salary of person who has that much. So salary will be a continuous value. It will be, let's say it will be 50,000, 50K or so. So you feel the difference between regression and classification. Classification outputs a categorical output, a categorical value. It will say yes or no, or it will say, if we talk about in the perspective of face recognition application, it will tell us it is person A, or it's person B, or it's person XYZ. But regression algorithms, they tell us for example, the salary of a person, that is continuous value. For example, if we draw a graph for estimated price of a house, and let's say the line is something like this, okay, and here on x-axis the area, here is the area, on y-axis it's the price. Now price is a continuous value. If I'll ask I'll say, okay, let's say this is 5. Okay, no, it doesn't look like 5. So let's say now it looks like 5. So if the area is 5, the price of house is somewhere over here. This. If price is, let's say, 10, the if the area is 10, the price will be that much. Let's say this was let's say 20, and let's say this is 60. So the output is continuous value. It's not a categorical, it's not a yes no value, it's not a category, it's a continuous value. So it's the difference between regression and classification. For regression, the famous algorithms that we follow is linear regression and polynomial regression. On the other hand, the algorithms that are available in classification problems, that are logistic regression, that are nearest neighbor, that are support vector machines, decision trees, and random forest. But let me tell you, there are a few algorithms that can be used in both ways. What do I mean by that? For example, there is, let's talk about this random forest. Random forest algorithm can be used in both ways. It can be used as classification algorithm as well as regression algorithm as well. And how can we use one algorithm in both ways? We will discuss it in later in probably the next section, where we will discuss the details of certain algorithm. So far we are done with classification and regression. In next lecture we will talk about the third and last branch of clustering. Last mode of machine learning, that is clustering, that belongs to unsupervised machine learning, and we will discuss about it. Just for the sake of revision, unsupervised machine learning is a type of machine learning where data is not labelized. So this clustering is a technique that we use to classify the data. Until then, bye. Okay guys, now we are trying to learn what is clustering. So far we are done with regression and classification, but on the side note, let me tell you, it's very important to know the difference between regression and classification, because most of the machine learning interviews starts from this question, that what is the difference between classification and regression. So I hope you understand the difference by now. If you do not understand the difference by now, please again listen the last video. If still you have confusions, post the question. Now, clustering. What is clustering? As I told you, clustering is an unsupervised machine learning mechanism. In clustering, we have unlabeled data, and we try to group the data on the basis of features. For example, if we are trying to, we are trying to classify the lines like this with, we have to classify lines and dots. Okay. Now, there are different features in it, and we'll see that, okay, these lines looks like same. For now, we do not know what these things are called, and we do not know that what these things are called, but we can see that these things looks like same. So okay, these things belongs to one category, and these things looks like same, so they belong to another category. Now a dot and a line, they have different features, so we cannot say that they belong to the same category. So that's how we group data together, and grouping data together is called clustering. We have different algorithms that allows us clustering with different techniques. A few of them are k-mean algorithm, c-mean algorithm, excuse me, EM algorithm, and hierarchical clustering algorithms. We'll be discussing the details of algorithms in next section, where for now we'll be discussing logistic regression, but where our course will be depending upon k-mean algorithm. We'll discuss k-mean algorithm there and so on. But for now, just for the sake of introduction of clustering, that's all. That's all about clustering. The basic difference between clustering and classification or regression is, in clustering, we group things together, just like these circles. Just like you can see that these yellow lines are grouped, differently. These red points are grouped differently. These blue points are grouped differently. While in classification or in regression, we do not group the data, we output something. In regression, we output a continuous value. In classification, we output a categorical value, for example, spam or not spam, 0 or 1, and so on. So guys, that's all about clustering. In next and final video, we will discuss a general flow of typical machine learning project. That will be sort of a recap of this whole section that we have covered under the umbrella of Introduction to Machine Learning. Until then, bye. Okay guys, we are going to learn today that what we have studied in whole this section of Introduction to Machine Learning. So what will be a flow of machine learning project? For example, we are going to start a machine learning project. And for the time being, we are taking example of face recognition. We are going to build a machine learning algorithm that can recognize the faces of people. So in the beginning, first step is to collect data. We have to collect a lot of faces of people that are supposed to be recognized by our algorithm or our machine learning model. Then feature extraction will be applied. And sorry, before that, data collection should be good enough that we can train our model. And then feature extraction will be applied. By feature extraction, we have already discussed it. In face recognition algorithm, maybe there are different features that can be extracted. One of them can be the color of face. Now it's a separate debate if the color of face is a good feature or a bad feature. It's a debate. But color of a face can be a feature. Maybe the distance between the eyes of human being, let's say this is a face, the difference between the eyes of human being can be a feature. The difference between nose and lips can also be a feature, and so on. Let's remove it and let's draw it again. Now this is going to be an angry man. The distance between these eyes are different from the previous one. Then data pre-processing, and of course these values will be the numerical values. The distance between the eyes or the color of face will also be converted into a numerical value. Then data pre-processing, it's a separate field. It consists of several steps. It contains removal of outliers, it contains data normalization, and so on. After data pre-processing, our data will be ready for our model. Then we will train our model. We will apply the best algorithm. Actually, let's say we will apply each and every algorithm, and then we will test if which algorithm is performing better, which algorithm is performing best. How can we know that which algorithm is performing best? By validating. By validating, I mean we will be finding the accuracy and error of each and every algorithm. Now the question is, which algorithm will be best? And the answer is such an algorithm that has low error and high accuracy. That will be the best, obviously. And if we will train a model, we will test and validate a model. If model will be having the greater error and less accuracy, then we will repeat it with a different model training and then again test it again validate it. If error is again high, then we will repeat again and again and again. And finally, if the error is low, accuracy is high, then here is the thing. Then our man will not be angry anymore. Man will be smiling. So that will be the happy ending. Then we will be deploying the model. So guys, that's all about this section. And I hope you enjoyed this section. I hope you've got the idea of machine learning. And the following are the things that I expect you to have in your toolbox after taking this section. I'm not expecting a lot because this was just a bird eye view of machine learning. We have not implemented anything. We have just theoretically studied, almost everything of machine learning. But since we have not applied anything, so you're not getting the result of things. You may be a little bit confused. So that was actually my goal. I want to make you curious enough so that in next section, when we will be applying everything, you will be enjoying the things. In this section, I just had to introduce you the terminologies. If you already knew the terminologies, then you may skip this section. Otherwise, you have to take this section so that whenever you read a blog online, whenever you take any other course, or whenever you read a book, you knew what they are talking about, because now you already know what is testing, what is validation, what is model training, and what is a model actually, and what is supervised machine learning, what are the modes of machine learning, classification, regression, etc. So guys, that's the ending of this section. In next section, we will be getting started with logistic regression. That is our goal. We will be implementing logistic regression in Python. Before that, we will be doing data pre-processing in Python, and then we will actually be applying logistic regression from scratch initially, and then we will apply this logistic regression, the built-in model of sklearn. So I hope you're excited for next section. I am also excited. Until then, bye. Hello guys, welcome back to our course. So far, we are done with the introduction of our course and the overview of the course. From now to onwards, we will be talking about our programming language, that is Python. So far, we have just introduced you the importance and a little bit of motivation of Python. From now to onwards, we will be doing the hands-on practice of Python. So let's start from the importance of Python for machine learning. So far, we have just studied the importance of Python. But how about Python for machine learning? Is it really important? Is it any alternative that we can use instead of Python? Let's discuss it. Let me take you to the article that is written in Towards Data Science, and they showed a graph over here. At above, you can see the years 2018, 2010, 12, 14, 16, 18. I am interested in the years from 2014 to 2018. You can see the rise in the graph of Python. Here it is at number 3. Obviously, it is not at the top because JavaScript is at the top, and there are certain reasons why JavaScript is at the top. Let's not discuss that here. But one thing is for sure, we do not use, or anyone do not use, JavaScript or Java in machine learning. But we do use Python in machine learning, or R. R is another language that we use for machine learning or big data. So you can see the rise in the graph of Python. And in previous lectures, we have discussed that the rise of machine learning started in 2014. And the rise of Python is also started in 2014. So now you can relate them. The Python is best language for machine learning because exactly when machine learning was introduced, Python, the boom of Python just started, and from then to now it is going upwards just like an exponential curve, sort of exponential curve. And in a years or so, in like like 5 years or so, it may beat JavaScript or other languages as well, because it's going to be an era of machine learning. And if it is going to be an era of machine learning, it's surely going to be an era of Python as well. Interestingly, if you look at the heading of the title of this article, it says we are living in the era of Python. So it's an interesting article. You can read it by yourself. Let's go back. And our second thing is I have to introduce you our IDE, that is the coding environment where we will be implementing Python. So there is a coding environment. It's called Jupyter Notebook. Let's open it up and see how it works. I just open my terminal and I'll write Jupyter Notebook. Oops. So I'll just have to hit enter by writing Jupyter Notebook, and it will open a coding environment for me. But wait for a minute. It may not open the coding environment for you, because you must not be having the Jupyter Notebook installed in your computers. So I'll be putting a link in the description that how you can install the Jupyter Notebook, the official documentation, so that you can install it on your machines as well. Once it's installed, that's how you open the Jupyter Notebook. Let's go back here. Let's make a new folder, and here it is, Untitled folder, and let's open it up. Let's make a new Python 3 file. Here you can see I got two options, Python 2 and Python 3. As we have discussed, we will be coding in Python 3. So here is my notebook. This is called a notebook, and this one sort of horizontal space is called one cell. This plus button can add more cells. Now, why these cells are here? What is the working of these cells? You can write code over here. Let's say code and code and more and more code. And this Jupyter, why we are using this Jupyter Notebook? Because these cellular environment is so good for interaction and teaching purposes that no other environment provides such flexibility. I'm not saying that it's the best environment for development, but it is certainly the best environment for teaching. So this is the introduction of IDE, that is Jupyter, that we will be using. And now let's move on toward the hello world. It's a tradition that whenever we introduce a new programming language, the first thing we do is we print a hello world program. And it's our goal for today's video that we have to print out the hello world program. Let's do it. It's a little bit difficult in Python, so let's see if we can do it or not. Let's type these quotation marks, and let's say hello world. Now, please watch it carefully. It is very difficult. And let's hit this run button. If I will click this run button, it will execute whatever written in this cell. So let me click the button, and here you go. Your hello world is just printed. You see how difficult it is? Yeah, it's really difficult. So that's how you print out your hello world, and congratulations, you are just getting started with Python. It's the tradition that we have just followed, and from next lecture to onwards, we will be doing the actual implementation, the hardcore sort of implementation of Python. And by the end of this section of our course, you will be able to implement each and every concept in Python programming language. In next lecture, we are going to introduce you the data types of Python. Until then, bye. So we are going to discuss Python's data types now. We have got 6 data types in Python: numbers, strings, lists, dictionaries, tuples, and sets. Let's discuss them one by one. But before that, um, basically Python divides these data types into two categories. One category is mutable data type, and the other category is immutable data type. There are 3 data types that belongs to mutable family: list, dictionary, sets. And there are exactly 3 data types that belong to immutable data type family: number, strings, and tuples. Now, what is mutable data type and what is immutable data type, and what is difference between them? Let's discuss it. Here, you can see that it's written mutable can be changed after it is created, which means once we have created a data type, its value can be changed, just like these building blocks. If I want to replace this red block, I can just put it out and I can replace it. If I want to replace this green block, I will just pull out all the blocks. I'll replace it and then I'll pull back all the blocks in the same order, or in whatever order I want. I mean, I can make any change into this building block. It's the perfect example for mutable data type, that we can change any value in the mutable data type at any time. Versus we have immutable data type. Immutable cannot be changed after it is created. So it's like a wall of brick. If I want to replace this brick, I just cannot. I have to, the destroy whole wall, and I'll have to build up the wall from scratch, from the beginning. One brick cannot be replaced. So immutable data types are those data types that are once created cannot be their value cannot be changed. But in mutable data type, once created, their value can be changed. Now, what are the use cases? Where should we use immutable data type? Where should we use mutable data type? The answer is where we want our data to be static. We do not want our data to be changed. That's the place where we should use immutable data types. For example, the list of companies, if companies are not going to be changed. For example, the list of vehicles, if vehicles are not going to be changed. And where we should use mutable data types. Mutable data type can be used where there is a chance that data will be updated or replaced after its creation. For example, the age of person, age changes with the passage of time, and so on. We can introduce a lot of example, and you can think of a lot of examples now. So we have, coming back, we have these data types. Numbers are immutable. If you want to change the value of number, you cannot. If you want to change the value of string, you cannot. If you want to change the value of tuple, you cannot. On the other hand, value of list, value of dictionary, and value of sets can be changed. That's all from today. Maybe a few of you haven't got the idea of mutable and immutable data type, what it is, how it works. So hold on, because we have not practiced it yet in this lecture. In next lecture, we will start practicing our first data type, that is numbers. We will practice it in Jupyter Notebook with the examples so that you will get enough idea of it. Until then, bye. We are going to start numbers, that is our first data type in Python. So Python supports integers and floating point numbers. Numbers are used for arithmetic operations, storing information, etc. So we've got two of numbers, integers, and floats. Floats are number with floating point, this decimal point, and integers are number that are without decimal point. If we will write 5, it will be an integer, but if we will write 5.0 or 5 point something, 5.9 or 5 point, whatever, there will be a floating point number. These both of the numbers can be positive or negative as well. And without wasting our time, let's go to the coding environment that we just started. We wrote hello world program in our coding environment just a few videos back. Let's continue and let's introduce you with numbers. 1 is a number. Let's say 1 plus 2 and compile it. It says 3. Okay, now the question is, I did not hit the run button. How it has compiled? Because I have pressed Control plus Enter from my keyboard. It's an alternative for hitting the run button. So that's how you can add two numbers. And if you want to do something like num1 is equal to 1, num2 is equal to 2, and let's compile it, and let's say num1 plus num2, execute it. It says 3 because num1 contains 1 and num2 contains 2. And if we want to see num1, what is num1? It says num1 has the value 1. Python is actually intelligent enough that it actually defines for itself whether the number is it's integer or it is a float, because we have not written anything like decimal here, so it is treating the number as an integer. If we will say float, let's say float num equals to 1.5. okay, and I'll compile it and I'll say num1 plus float num. Let me run it. It says 2.5 because num1 contains 1, here it is, and float num contains 1.5. So 1.5 plus 1 is 2.5. So Python is intelligent enough that it differentiates what is the value of the number, or what is the basic data type of the number. Let's move on. We can also do something like 5 minus 2. It says 3. That's how you subtract two numbers. We can also do something like 8 divided by 4. Let's run it. It says 2.0. Okay. If I'll say 7 divided by 3, it says 2.33335. Now question is, what if I want to ignore these floating point values and I just want to take this value, the integer value out of it? So I'll just say 7 divided by 3, but I'll have to write this divide sign 2 times. It will give me the value without the floating point. So here it is. It gives me 2. And if I'll say that we have just done over here, if I'll do the similar thing over here with double division sign, I'll get 2. Here we got 2.0. So that's how you can do the division with Python. Moving on, how can we get the exponential value, the power of any number? It's also called power. So 2 multiply by 4, it gives me 8, but we want to calculate its power, its exponential value. So we will write the multiplication sign twice. It will give us 16, because if we will multiply 2 4 times, 2 multiplied by 2 4, 4 multiplied by 2 8, and 8 multiplied by 2 is 16. That's how you get the power of a number. Further, how can we get the modulus value in Python? So let's see how can we do it. It's very simple. We just have to write, let's say 7. This is the symbol of modulus. 3, hit enter, it says 1. What is the modulus? Modulus is the value that comes in the remainder term if we divide 7 on 3. Okay, guys. One more thing, you can also use brackets in the Python. So if I'll say 8 divided by 2 plus, again bracket, let's say 4 divided by 2, and it answers in 6, because 8 divided by 2 is 4 and 4 divided by 2 is 2. So 4 plus 2 is 6, and it is giving us answer in floating point. How we can convert it in integer or non-floating point number, you can do it now. I've just told you, or here, like here, you can just implement it over here as well. So guys, that's all about the numbers of Python that we use in Python. And let me do something over here that we will follow in our course. Now what is this? I'm going to write number followed by this hash sign. Guys, this is called comments. Whenever Python code compiles, it will not compile any line that will start from hash sign. A compiler will know that, okay, this is the line that coder has written for himself. I mean, compiler do not have to do anything with this line. It is just for the sake of clarity of the coder. So these are the numbers that we have done up till now. And from next video, we will be talking about strings, which is another data type in Python. But before that, wait, I'll have to give you an assignment. So what you will have to do is, you will have to evaluate this expression and you should know what is the answer of it. 8 divided by 2 plus, let's say 6 multiply by 3 plus 10 minus 2. So you will have to evaluate this expression. What will be the answer of this expression? In the beginning of next video, I will be telling you the answer of this expression, and that will conclude the numbers portion, and then we will start the strings. So string is going to be next. Bye. Let's start strings. That is our second data type. But before that, you were asked to evaluate this expression. So let's see how can we do it. And a hint to do it is DMAS. It's DMAS rule that you may have studied in mathematics class. It follows the DMAS rule, which is it will first solve the division, then multiplication, then addition, and finally, at last, it will solve the subtraction. So it will first solve this expression, then it will solve this expression, then it will solve the plus expressions, and finally the minus expression. So let's evaluate it. It says 30 because 8 divided by 2, let's do it over here. 8 divided by 2 is 4, then plus sign, then 6 multiplied by 3 is 18, then minus sign, then 2. Now it will first solve these two values, which will become, sorry, we have not written plus 10 over here. So now it will add these two values, that will become 22, plus 10 will be 32, and minus 2 will become 30. That's how it will evaluate the expression. Let me remove it over from here. And let's start our brand new topic, that is strings. Okay, so what is string? String is a sequence of characters. It is used to represent text instead of numbers. String in Python can be easily concatenated, sliced, etc. Okay, now what is character? Uh, Anything on your keyboard that is typeable is character. Okay, and now what is concatenated and sliced? Let's ignore it for a while. I will tell you when we will start coding in our coding environment. So that's how you can declare a string. This is str is just a variable name. This is, str is equal to hello world in quotation marks. This quotation marks shows it's a string, and that's how you can just print a string, and that's how you can just concatenate a string. You can just add a string. A string contain str contains hello world plus empty space plus again hello world, and it will output hello world space hello world. Let's practice it a little bit in our coding environment. Let me add a few cells. How do we add the cells? By clicking this plus button. Okay, so let's say str equals to hello, sorry, word, and let's compile it. Let's see, str contains hello world. Perfect, perfect. And let's add them up. Str. Okay, now question is, you may ask, how can we add a string in a string? It's not a number. So addition of string means we are going to concatenate these strings with each other. As, actually, let's write str1 here. That will distinguish the thing. Hello world. I'll say live long. Okay, compile it, and I will say str plus str1. Now you can see hello world, live long. We have concatenated these two variables that contains the strings. Now another thing, we have to put space between them. How can we do that? We will say string plus this is another string that that contains the space. Then we will again add str1, and it will say hello world, live long. Perfect. And what if let's store this beautiful string in another variable. We will call it let's say variable. Okay, var. Let's call it var. Let's compile it. Let's print the var. Perfect. So now it's actually concatenation that we have just studied over here. Now let's study what is slicing. That's how we do the slicing. If I want to get, I do not want to get the whole string, I just want to get a part, a chunk of a string. That's how we do that. We just, we just define the index of the string and we get it. Let's do it over here. What if I want to get just hello out of it? I will say variable or var from 0, because hello is at zeroth place. Counting in, indexing counting starts from 0. So 0th place, and O is at 0, 1, 2, 3, 4. Actually, it's at 4th place. So I'll say, so first of all, let's do var 0. It says H. And if I'll say var 4, it says O. So if I say 0 colon 4, it will say hell. Where is O? Because it does not, this slicing does not count this this number over here. It takes the values before that number. So let's write 5 over here, and now you can get the complete hello. And what if I just want to get this word, not the hello? So I'm going to start from W, which is at sixth place. So I'll say from 6 to I guess it's, let's write 10 over here, and then we'll see. Okay, WORL, because it's at 10th place, so we have to write 11 over here. Here we go. So word is over here. That's how you can work with strings. Um, what if I want to replace H, this capital H, with small h? Um, mm, can I do this? Equals to, sorry, not minus, equals to small h. Can I do that? No, I cannot do that, because what is h? It says I don't know what is h. So I have to write it in a character. Then let's see. Again, it says no. Any idea? Any idea? Let's go back to presentation. Let's go back to this introduction. I told you string is an immutable data type. You cannot change the values of immutable data type after its creation. So we cannot change this capital H with this small h. How can we do that? How can I replace this brick in this wall? I have to destroy whole wall and then I'll have to build a new one. Exactly same thing I'll have to do over here. I'll have to, um, there are two things that you can do. Number one, you can do something like variable. You can define a new variable, and then you can do you can create a new string, okay, and then you can say variable new, print it, and here we go. Hello with small h and hello with capital H is still there. It's one way to do it, but it's not a good way to do it. Now it's your assignment to find a good way to do this thing. Otherwise, I will do for you in the beginning of. One more thing that will help you out in probably the whole your life, which is this help. What is help? Whatever you will type over here, if I'll type these quotation marks that are the symbol of string, and I'll say control enter, it opens up the documentation for that data type. And in the documentation, you can see there are a lot of functions available for the strings. You can see this capitalize function. You can see the case fold function, the count function. Let's implement the count function. It seems interesting. Var dot count. That's how you do it. Enter. Oops. Okay, so it's not a function. It's an attribute. So that's how. Sorry. COUNT count. That's how we write it. Again, I'm wrong. Oops. So what we are doing wrong is we are not reading the documentation and we are just applying it. Let's read it. Returns the number of non-overlapping occurrences of substring. What is it? Which means we can find how many substrings are, how many particular substrings are there in var. Var contains hello world, live long. So if I want to count, let's say, count how many O's are there in it, I'll say var count O for me. So let's count it. 1, 2, 3. There are 3 O's. Let's run it, and it says I have 3 O's. And what if I'll say count double L for me? It will say I have only one double L. Why? Because only hello contains double L. Live contains one L. Long contains one L. Word contains one L. So that's how you can work with it, and you can read the whole documentation. It's really interesting. And here is an assignment for you. You have to find what is the starting index of any substring. So starting index of substring. It's just a function over here. You just have to read the documentation and you will find it easily. Secondly, you have to convert the string to uppercase. That's it. These two things are to be done by you. If you will not, you should give it a try. If you will not be able to do it, I'll do for you. Do not worry. In the beginning of next video. That's all about strings. In next video, we will start our next data type. Okay, guys. So our next topic is tuples. But before tuples, we have to do this little thing. First of all, we have to get the starting index of any substring. So let's say in var, we have to find the substring, the starting index of this word. So how can we do that? Var dot find. Here we will say, okay, find the starting index of word for me. Here we go. It says word starts from 6th index, and you can count. W is at 6th index. Number one. Number second thing is you were asked to convert the string into uppercase letters. So it's really simple. If you have studied this documentation, it's really simple. So how can we do that? Var dot uppercase. Sorry, it's not uppercase, it's upper. Okay, so you can see var contains a few uppercase letters and a few smaller case letters or lowercase letters. It has converted all of them to the uppercase letters. So that's all about strings. And now we are going to start tuples. I spelled it wrong. Yes, now it's fine. So let's read its theory first. A tuple is an immutable Python object. Now you have to be aware of immutable Python object, okay, that we have just discussed in last video, which means it cannot be changed once it's created, just like strings. Then tuples are like an array, but each element in a tuple can be of different data types. Now, array, what is array? Array is nothing. It's just a data type that stores multiple values, because numbers store only one value, string stores only one string, but array can store more than one numbers. Array can store more than one strings. And here, it's a special type of array that stores more than one strings, and it can store different data types as well. It can store more than one strings and numbers, and even it can store tuple in it, another tuple in it as well. Its declaration symbol is these parentheses, and that's how you can define a tuple. My tuple is equal to these parentheses, then a number, integer, then a floating point number, and then a string, and that's it. Let's go to our coding environment and practice tuples a little bit. Let's add a few cells just like before. Let's say my tuple is, how can we define it? Just like this. First value is 30. Second value, let's say hello world. Third value is, let's say 60.5. Okay, let's run it and let's see what is inside my tuple. Here we go. And let's say I want to get this element of my tuple. Can I get it? Let's see. How can I get it? It's at second index 0, 1. So it's at 1th index. Here we go. It is a string. Now this is a string. Guys, you have to note this point. My tuple, this is a very important point. My tuple, this is what? It's a tuple. But if I'll say my tuple 1, now it is a string. It's a string now. And you can operate any operation that you can do on a string now. For example, you can slice the string, which is you can, we have studied slicing in last lecture. You can do something like this. Here we go. You can concatenate it. I'll say plus another string. another string. Here it is, hello world, another string. So that's how you operate with tuples. What if I want to store, 40 instead of 30 over here? What can I do? Sorry, I'll say my tuple 30 is at 0th index, so I'll say 0 is equal to 40. Any idea what will happen? It will not let me do that. It's the same error that we have seen in the case of strings. What is the error? It says I cannot let you assign any value to the any index of tuple because tuple is an immutable data type. So now it's how can we do that? How can we do that? How can we assign a value or change a value of any element over here? You'll have to wait till next lecture because I will be introducing a new data type in next lecture that will allow you to do that. But in tuples, you cannot do that. So that's all about tuples. Now your assignment is to implement. You'll have to write help. Sorry, help over here, and then you'll have to pass it the tuples declaration sign. It will give you the documentation of tuple, and you'll have to read the documentation, and out of this documentation you will just have to implement any one function, any one method uh, before next lecture. So or in next lecture I will be implementing my favorite method. I don't know which one it is out of it. So until then, bye. Our next data type is lists. But before that, let's complete what we have left. I requested you to implement any one function for tuple. So let's implement which one? Let's implement this length function. It is len underscore underscore len. So let's implement it. I'll say my tuple. You can read the documentation, what it do. Underscore underscore len underscore underscore. This is the method symbol. Let's do it. It returns me 3. 3 what? What is 3? Let's go back to our tuple. Where is our tuple? Here it is. So our tuple contains 3 elements. 1, 2, 3. So length tells us that your tuple contains that much elements. And length works for strings as well, because we had a string named var, and we can say underscore underscore len underscore underscore this. It says it contains 21 characters, or its length is 21. Let's remove it, and let me say list, which is our new topic. Let's start from its theory. So it says, unlike tuples, lists are mutable, which means that list can be changed after creation. Otherwise, their behavior is same as tuple. So the only difference between lists and tuple is tuples are immutable and lists are mutable. Now, what's the benefit of list? We can change the elements of lists after its creation. I will show you when we will go to the coding environment. Its declaration symbol is these square brackets, and that's how my list equals to square brackets and comma separated things will be the elements of our list. And we can also update the values of list. Let's go back to our coding environment, and let's define our first brand new list, which is, I think it should be the same, 30. Let's do something like this. Let's not write a string. Let's write var over here. What is var? I don't know. You tell me what is var, and then 50.5 over here. Let's compile it and let's see what is in our list, my list. Oops, it says 30, fine. It says 50.5, okay. But it does not say var. It says hello world, live long. Why? Because var is a variable that contains a string that says hello world, live long. Just as we studied in our last lecture, in our last few lectures. Let me add a few cells over here so that we can play with our list. So let's move on. And as I told you, it is a mutable data type. So we can update any value over here. Let's say I want to write 40 over here. I'll just have to do my list 0th element. Oops, it has converted into the string. I'll have to write it over here. So I'll say my list, its 0th element, that is 30. Okay. And if you remember, same is the syntax that we did with tuples in last lecture. So I'll say my list 0th element, please replace it with 40. Can you do that? It says okay, and let's see if it has done or not. My list, here we go, list is updated. Perfect. Now can I write any string instead of number? Can I do that? Let's see if Python allows us or not. What is your take? Python will allow us or not? Think about it. Let's say replaced string. Run it. Fingers crossed. Let's see. Oh, here we go. The number is replaced with a string. So we can do this. We can do this. Yes, we can do this. Now, what if I'll say my list get its 0th element, which will be this replaced string. Okay. Now the question is, can I replace this R with any other letter? Can I do that? Let me do it over here. So I'll say my list, its 0th element, which is a string. Okay, this string's 0 element is R. Okay, now can I replace it? Can I do this? Replace it with, let's say, P. It is not allowing me to do this. Why it is so? Because I told you in last lecture, if I will do something like this, now it is not a list anymore. It has become string. Because it is not representing a list, it is representing an element of list, and the element of list is a string. So this is the point, because string is mutable data type. String is immutable data type. So it will not allow us to do so. So it is wrong. It returns us the error. Now, what if I want to add, there are 3 elements in it. I want to add a new element to this list. What can I do? I can do something like list. My list dot append. Let's say append another list. It's interesting. Let's say this list will contain 2, 5, let's say 8.4. Let's run it. And what is updated list? Here we go. So it contains replaced string, hello world, 50.5, just like before, and the newcomer list. So here is an example, that list containing another list. So what if I want to get this element of the list? It is at 0, 1, 2, 3, third place. So how can I do that? How can I get it? I will just say 3. Here it is. But it's very pathetic that I have to get the last element and I'll have to count all the elements 0, 1, 2, 3. How can I just get the last element without counting? So the answer is, you can say -1. Negative indexing starts counting from the other end, the end from right end. Here we go. The result is same. Now it is returning me the last element. What is the last element? It is another list, and I can perform all the operations on this list as well. So I will say again -1. What will it do? Any guess? Will it return the last element? Really? Yes, it returns me the last element. So guys, that's all about the lists, and here is the time to give you a task. You have to delete this replaced string out of it. So delete an element from list. That's it. You have to do it. Otherwise, as usual, I will be doing it for you in the beginning of next lecture. Until then, bye. Welcome back, guys. So we are going to start dictionaries. Before that, I'm not letting you go. So I hope you are done with deleting the elements from list. But if you have not done it yet, so how can we delete this replaced string element out of it? How can we do that? Let's see. So I'll say my list dot del item, and I'll pass 0 to it. Why 0? Because replaced string is at 0th index. I'll run it. It says list has no attribute as del item. Why? Because we have not written underscore around it. Here we go. And let's see my list. And here we go. You can see that replaced string is removed from here. And it's not a rocket science. This underscore del item method is already available in help. If you will just type help and find and write the square brackets here, you will get the whole documentation for the lists, and you can easily find this method over there. So you should build this habit of reading the documentation. It's really good. So from now to onwards, we are going to start dictionary. What is dictionary? Let's start from theory. So it says dictionary is a collection which is unordered, changeable, and indexed. So what is unordered and what is indexed? But we already know what is changeable. It is a mutable data type, so its value can be changed. But what is indexed and what is unordered, I will tell you when we will be coding in Jupyter Notebook. Let's move on. In Python, dictionaries are written with curly brackets, and they have keys and values. Now, what is keys? What is value? And it also says dictionary holds key value pair. This is the phrase that you will listen quite a lot who code in Python. They say key value pair. What is it? So in dictionary, that's how we define it with curly braces. My dict equals to curly braces. And then you will say this is a key. There's a colon. Before colon, there's a key. And after colon, there is a value. So the main advantage of dictionaries is it it makes indexing very efficient. You will not have to remember, okay, which element is at what index, because we are not human are not good with remembering the numbers, but we are good with remembering the names. So if I'll say, okay, get me the name out of my dictionary, it will get the name, the key name. Key has to be a string, but the value can be any data type. it may be a little bit confusing for you, but let's practice it a little bit and then it will become very easy for you. So let's say sorry, my dict equals to, so I'll say id is 1, comma, name is, what's the name? Let's say Sam, and age is 20. Let's run it and it will give me the error. Why? Because it says age is not defined. As I told you, key has to be a string value. Okay, now the value thing can be anything. It's a number over here, it's string over here, it's again number over here. So it can be anything, it can be list as well, but the key has to be string. Let's compile it now. Here we go, it's fine. And let's add another thing over here. Let's say marks, and marks will be a list. Let's say 20, let's say 30, and let's say 25. These are, let's say these are the marks of quizzes. Quizzes marks. Perfect. Let's run it. Okay, and let's see what my dictionary says. It says here I am. Now if I want to get the name, what will I have to do? My dict. Let's say if it was a list, I'll have to remember, okay, name will be at second index 0, 1. But in dict, I do not have to remember the index. I'll just say, okay, bring me the name. It says Sam. If I say, let's say my dict, okay, Sam, oh sorry, Python, bring me the, let's say, quizzes marks. Sorry, I may have, yes, there is a spelling mistake. Quizzes. Okay, it says 20, 30, 25. And again, it returns me a list. So now it has the whole, it has become a list. And I can, manipulate it just like a list. I can say, okay, uh, send me this, the last element. Sorry, dot should not be here. So it says 25 because 25 is the last element. And that's how we get the last element. So these are the dictionaries. It makes indexing so easy and so efficient, so effective that whenever we have to store a lot of data uh, and we have to extract the data by indexing, we use dictionaries over there. Just a note, just a little bit of note, those who are already coding in any language, probably the web, they're doing the web development, they must be they must be familiar with JSON. uh, so dictionaries are exactly what JSON is. Those who do not know JSON, do not worry at all, but those who know JSON, so dictionaries are just the synonym of JSON in Python. It gives you the same functionality in Python. So that's it about dictionaries. And again, my advice to you is you'll have to read its documentation. It's really a good habit. Get used to it. And uh, what will you do? What should be your assignment? So your assignment is, okay, this is the whole dictionary. Okay, now your assignment is to find a method from its documentation that gives me all keys of this dictionary. This id is a key, name is a key, this quizzes marks is a key, age is a key, that returns me all the keys of this dictionaries. Number one, let me write it for you. Find all keys. Secondly, find all values. The values that corresponds to keys. This 1 is a value, Sam is a value, 20 is a value, and this list of 20, 30, 25, these are the values. So this is your assignment that you will have to do by yourself. Otherwise, I'm here for you at your service. And in next lecture, we will study the last data type, that is sets. Until then, bye. So guys, our next and last data type is sets. But before that, let's complete our work that we left in our last video. So we had to find all the keys in our dictionary. So how can I do that? My dict dot keys. That's it. It's as simple as you see. My dict dot values. That was the second thing that had to be done by you. Here you can see that. Now, one bonus thing that I want to teach you is, what if I want to get its first value? It looks like a list, and let's get its first value. No, it's giving me an error. Why it is giving me an error? Let's remove it from here and see. So actually we can see it is not a list. It is an object. An object that tells me that it is a dict keys. So if I want to treat it as a list, I have to convert it into a list, and it's not difficult at all. What you will have to do is, so let me save it in a variable. I'll say keys. Okay, and here I'll say list parenthesis keys. Let's run it. Here we go. It's converted into a list. And now I can say 0. That's it. I can say -1. Here we go. So this thing that we have just done, it's called, it's a concept. It's a proper concept. It's called typecasting. Okay. Now let's move on to our final data type, which is sets. Let's start from theory. It says set is an unordered collection of data types that is iteratable and mutable. Let's leave this iteratable word for now. We will discuss about it at probably 5 to 6 lectures after now. So what is mutable? You know that. I do not have to tell you. And it is unordered. Why it is unordered? Why it is not in the order? The answer is the following. Set in Python are similar to sets in mathematics. What what does it mean? In mathematics, what is set? If you don't know, let me tell you. In mathematics, set is the collection of figures that are unique. For example, if I'll say my set equals to 1, 2, 3, 4, 5, 5, 6, 6. 5 and 6 are repeating. But if its data type is set, it will be 1, 2, 3, 4, 5, 6. Unique numbers. It will not take the repeating numbers. You can perform all the operations on it. You can add a number to it. You can remove a number from it. You can do the union thing just like mathematics. You can do the intersection thing just like mathematics. Let's implement it in our Jupyter. So I'll say my set equals to brackets. Now the question is, let's go back to our slides. Now question is, its symbol is also curly brackets and the symbol of dictionary is also curly brackets. So how Python differentiates dictionaries versus sets? The answer is dictionaries contains key value pair, but sets does not contain the key value pair. These are just values. So if it contains a key value pair separated by colon, it will be dictionary. If it does not contain key value pair that is separated by colon, it's a set. So let's create a set 1, 2, 3, let's say 4, 4, 4, and 5, 5. Let's create it and let me output, and we will be able to see what is stored in the set. You can see it's unique. It's unique. 4 is not repeated. 5 is not repeated. Now you know what does this unordered mean? It does not maintain the order because it has to delete certain values, because the number of the index of 6 is not the same here that is here, because we had to delete 5 from it. So I hope you understand the unordered thing. Now let's perform these 4 operators on it: add, remove, union, intersection, and uh, let's add a few more cells before that. My set dot add, it will just add a new value to it. So I'll say 8. Okay, now my set is 1 3 4 5 8. One new thing is, not new, but a common sense thing is, if I'll try to add 5 to it, what will happen? It says no, 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 no. You cannot do it because 5 is all, sorry, I'll have to do add 5. So let's see our new set. It's the same. It does not add uh, 5 in it because 5 was already there. So it did not add 5 into it. Let's create a few more cells, and let's create new set, which is, let's say 5 6, let's say 10 11 and 15. This is another set. Let me output this set. Here it is. Now we have 2 sets, 1 2 3 4 5 8, and this new one. Let's take its union. I'll say my set dot union. Union with what? Union with our new set. Here it is. We can see in mathematics, this is how we take union. We take all the unique numbers from both of the sets. As you can see, 5 and 6 were repeating. Actually, only 5 was repeating in both of the sets, but 5 only once. And the same the thing you can do with intersection. How can we do it? Intersection. Let's run it. It says only 5. Intersection returns you the value that is common in both of the sets. So 5 was common in both of the sets. So 5 was returned. So guys, that's all about the data types of Python. I hope you understand everything, and you have to practice it a lot. Data types are done. Now from now to onwards, there are few conceptual things that I will be trying to explaining you, and but you should take a break. You should take a break now. You should practice each and everything a lot. If you do not understand anything, please post the question and I will try to answer and explain your question, and I will try to clarify wherever you will be confused. So until then, bye, and from next lecture we will start operators. Hello and welcome back to our new topic, which is operators. So far, we are done with the Python data types, and I requested you actually to take a break and practice the data types. And let's start operators now. We have 2 types of operators: comparison operators and logical operators. What are comparison operators? What do you infer by its name? Comparison. It does the comparison. It compares the 2 things or more than 2 things as well. Let's see how many comparison operators do we have in Python. We have actually 6 types of operators: equal, not equal, greater than, less than, greater than or equal to, less than or equal to. And here you can see the symbols as well. Equal has double equal to, this is equal to sign, and if we will write it twice, it will become the equal operator. And if I want to compare, let's say value is a variable that contains any value. Value is equal to 5 or not. I want to, compare them. It will be written just like this. It's as simple as you can see. If I'll say, okay, tell me value is not equal to 5, it will be written like this. Tell me value is greater than 5, it's written like this, and so on. Now, one thing should be noted: if you ask someone any question that contains the comparison thing, if you ask someone, you are taller or your friend is taller, he will say, that friend is taller. But if you will make an operation like this, if you will say, okay, person A is taller than person B, it will be answered in yes or no. Person A is taller or person A is not taller. There is no any third answer. There cannot be any third answer. So comparison operators tells us things in yes or no. And in programming language, yes or no is translated into true or false. Let's go over here and let me just annotate that we are going to study comparison operators. Perfect. Let's add a few more cells. Just like before, we'll be needing a lot of cells. So let's say value equals to 5. Okay, so value has 5. Value is 5. So if I'll say value is equal to 5, please tell me it says true. Yes, value is equal to 5. And if I'll say value is equal to 6, it will say false. No, value is not equal to 6. One thing should be noted: if you want to compare two values, you will have to use this double equal to sign, not equal to sign. Equal to sign is used as assignment operator in programming. In general math, you can use this operator as equal to operator. But in programming, this equal to sign used as assignment operator, that 5 is being assigned to this value variable. And if you want to compare two values, you have to write double equal to operator. And similarly, if you will say value is not equal to 6, it will say true. Yes, you're right. Value is not equal to 6 because value is actually equal to 5. Moving on, if you will say value is less than 6, it will say true. Yes, value is less than 6 because value is actually 5 and 5 is less than 6. If you will say value is greater than 6, it will say no, false. You're wrong. Value is not greater than 6 because value is actually 5 and 5 is not greater than 6. Okay, tell me value is less than or equal to 6. It will say true because 5 is less than 6. And if I'll say value is less than or equal to 5, it will again say true because value is not less than 5, but value is equal to 5. So this is, it says, okay, either of these operators are true, I will return true. Okay. And finally, value is greater than or equal to 5. It will again say true because value is not greater than 5, but it is equal to 5. And if I'll say value is greater than equal to 6, it will say no. 5 is neither greater than 6 nor equal to 6. So both cases are failed. So it is false. I'm sorry. So that's how you use comparison operators. And uh, so far, there is no as such use case of comparison operator that we can discuss. But for just the sake of practice, you can compare the arithmetic equations. You can do something like 5 plus 6 is equal to 9? It will say no, because 5 plus 6 is 11. Now, in next lecture, we will be discussing the logical operators. But before that, your assignment. Now, this is a tricky one. You will have to get input from user. Now, it's a little bit tricky one, not difficult, but something new that you have not tried yet. You'll have to sort it out. How can we get input from user? And yet, if you will be able to do it, second thing, you will have to do something like, you know, you will have to compare input number with a hidden number. So it will be sort of a game. So you will be doing something like value is equal to, let's say, 10, compile it, and then just remove it. Now take an input from user, from your friend, and let him guess what is the value of the value variable that you've just written. How can we do that? It's a little bit tricky one. In next lecture, I will try to teach you how to do it, but I'm expecting you to do it. Until then, bye. Hello guys and welcome back. Today we are going to study logical operators. We have three types of logical operators: and, or, and not. There are three types of logical operators. But before that, we have to do something new, something interesting today. We have to get input from user and compare that input with a hidden number. It will be sort of guess the number game. So how can we get the input? Let's say input, let me say user input. Okay, now that's how you get the input from user input. And here you will be prompting, you will be writing a text that will prompt the user. You have to enter a number. So I will say enter a number, just formatting it. So whatever the number user will enter, it will be stored in user input, and then I will print the number. That's it. Let's compile this cell. Here we go. It is asking me to enter a number. So let's say I will enter number 10 and I will hit the enter button. So it prints, it executes this statement that is printing 10. That was our first goal. And second goal is to compare the input number with a hidden number. So what is the hidden number? Let's define a hidden number. So I'll say hidden number is equal to, let me define it, let's say 10. Let's run it and then remove it. Now you know that hidden number is 10, but you have just removed, and now you call your friend to guess this number. And let's do the same thing over here again, and let's just prompt your friend like guess the number. Okay, and let's run it. Guess the number. Your friend says, okay, 15. Hit enter. It's doing nothing. It's not telling me if it's the original number or not. So we have to update it. We do not have to print it. We have to say hidden number is equal to the user input. Okay, now let's try to run it. Now I will enter 15. Enter. It says false. No, you're wrong. You lost. Okay, your friend says, give me another turn, please. And you'll say, okay, go for it. And your friend says 10. Enter. Again, it says false. Why? This is point to be noted that your friend has entered the same number, that is hidden number, but it says false. The reason is input number, whatever you input, it returns the number in string format. And you have to convert this number into the number format, the integer format. So it's doing something like 10 equals to 10 in the string. And if you will compare it, it will say no. 10 is equal to 10, but their data type is not the same. So what do we need to do? So if I need to convert it, I will say int, and I'll wrap this string in int. And then it will say true. The same thing you will have to do it over here. You will have to say num int, and that's it. Now again, run it. Your friend types enter, 10, hit enter, and bingo, your friend wins. So this is our sort of a game, a little bit our very first beginner level game that you can introduce with your friend. You can play around, you can maneuver this game. You can say, okay, your friend that, okay, guess a number that is, at least greater than my number, and you can implement it just by changing these signs like this or like this. You can do it. Now, guys, our next goal is to study logical operators. First logical operator is AND. Up till now, we know what is true and we know what is false. Yes is true, no is false. If we want to combine these operators, the results of comparison operators, that's what we can do using the logical operators. Now, if we will be using AND operator, it will return in the following way. It actually, in other words, we say AND is a product of it. So true and true is true. True and false is false. False true is false, and false false is also false. How it works like a product, because true corresponds to 1 and false corresponds to 0. So 1 multiplied by 1, it's 1. 1 multiplied by 0 is 0, 0 multiplied by 1 is 0, and 0 multiplied by 0 is 0. In OR operator, we say it's like sum, it's like plus. So 1 plus 1, it's 1. In binary, it's 1. So 1 plus 0 is 1, 0 plus 1 is 1, 0 plus 0 is 0. And finally, we have NOT operator that says, okay, whatever the value is, I will not accept it. I will say the opposite thing. If you will say true and you will, add a NOT operator, it will say false. If you will say false, it will say true. Okay, so let's practice it a little bit. And their use cases will be discussed when we will be implementing our projects in Python or machine learning. So I'll say logical operators. So if I'll say 10 is equal to 10 and 5 is equal to 4. Now this statement is true, we know that, but this statement is false, so it will return false. Here we go. And let me just copy it for the sake of efficiency. And if I'll say 5 is equal to 5 and 10 is equal to 10, so it will say true. Okay, fine, both are true, so okay, it's true. And rest of the thing is as same as we have seen in our presentation. How AND works, how OR works, and let me do something like 10 equal to 10. Before that, I have to print this NOT operator. It will say not found because it is saying not 10. Not 10 is nothing because we have not written parentheses in it. Sorry, we have to do something like this because it is not taking not operator like this, it takes English word not. False. Because 10 is equal to 10, it says yes, true, but not inverts the answer of 10 equals to 10. And if I'll say something like not 5 equal to 4, now we can easily see that it's false, but it will say true because it inverts the output. So that's all about logical operators. And that mistake that I did here, I wrote this not sign here because in C++ or other languages, I just got confused. In other languages, in a few languages, we write not operator like this exclamation mark. But in Python, as I told you, it is a very human friendly language. So we can write English letters over here, or otherwise, and can be written like this as well in C++ or other languages. That is really horrible. So guys, that's all about today. And next important topic is decision making. That is the most important topic in any programming language. It's the power of programming that Ada Lovelace introduced. Ada Lovelace is the mother of programming, who introduced programming. So uh, you should be excited about next lecture. And in next lecture, we will be starting decision making, how our program can make a decision. We human makes decision, but how my program can make a decision, I'll be telling you in next lecture. Until then, bye. Hello guys, and welcome back. Today we are going to discuss another fundamental thing of Python, that is decision making. Actually, it's the fundamental thing of any programming language. How do we make decision by using a programming language? Actually, it's odd because decision making is an ability of human being. We make decision at every step of our life. For example, if it's raining, then I will not go out. If it's sunny, then I will go out. So I make decision at each and every step of my life. For example, if that certain thing will happen, then I will speak. Otherwise, I will not speak. I am making a decision, and unconsciously, sometimes we human are programmed so beautifully that we make decisions sometimes unconsciously. For example, we are driving and something comes in front of our car, and we apply brakes so fast that we make decision so fastly. uh, so the point to tell you is, we make decision at each and every point of our life, and we want to introduce this decision making thing in programming as well, so that my program can know how to deal with any situation. And if I will code my program in a way that if something will happen, you will have to do this, otherwise you will have to do that. It's as simple as I just narrated it. So let's see, how can we make a decision in a program. So actually we've got two types of decision making: if else. And second is nested decision making. These are not the types. It will be wrong if I'll say these are the types. These are not the types, but that's how we make a decision. These nested decision making is a little bit advanced sort of decision making. So, how can I make a decision? I will say if weather is sunny, then I will play. And how can I compare weather with sunny? It's a question. And the answer is, I just taught you the comparison operators that answers in yes or no. So if weather is sunny, weather is equal to sunny, then I will play outside. So let's code it. Let's, you know, do its implementation. Let's add a few more cells over here. And let's tell ourselves we are going to study decision making. Here we go. So I'll say weather equals to, let's say, what, sunny. So sunny. Okay, let's compile it. So that's what I have stored in a variable weather. Okay, so here I will say if weather is equal to, let's say, sunny, then this is, in English we type then, in programming we write this colon. Okay, then do what? Let's say print uh, play outside. Let's run it. Here we go. It says play outside. It has made a decision. Okay, if weather is sunny, play outside. And let's say if weather is rainy, then do nothing. It says weather, because I decided to play outside if weather is sunny, but weather is actually not sunny. Weather is not equal to sunny. Weather equal to rainy results in false. If if I will just copy this and paste it over here, you will see it results in false because weather contains sunny. And if the answer of this comparison operator is false, then this part will not be executed. So our program is actually making sort of a decision. And one more thing is, here we go. One more thing is, we have studied if, and there is another thing. It says elif, or in other words, it says else if. Elif is just a short form of elif, else if, sorry. So if weather is sunny, then I'll play outside. Else if weather is rainy, then I will play video games, obviously inside the home. So if it's raining, I'll obviously not be playing video games outside the house. So let's code it. Let's code it. So if weather is sunny, let's play outside. And elif weather is rainy, yeah, rainy with single n, colon, then actually you have to note something. If we are writing then part, this is if part, okay, and this is then part. You'll have to indent it. You'll have to press tab before it. Otherwise there will be an error. If I will do something like this, and I'll just remove it, I'll do something like this, it will give me an error. It says expected and indented block. So you will have to write indentations like this. Perfect. So let's get our code back. If weather is sunny, play outside. If weather is rainy, do what? I'll play, let's say, play inside. Okay, let's run it. And actually weather is sunny, so it will say play outside, weather is sunny. So it's a good news, play outside. And if weather is rainy, I will just say weather is rainy, then do what? Then play inside. Do not go outside because it's raining over there. So here we've just written a simple program that makes its own decisions. And there is another thing we have studied if, elif. There is another thing else. If weather is sunny, then play outside. If weather is rainy, then play inside. What if weather is not neither sunny, neither rainy? It's it's something else. It's just not sunny, neither rainy. What will I do? So I will else whatever it is. If it's not sunny, if it's not rainy, do what? Print Let's say I am confused. Okay, so let's run it. It says play inside. Why? Because weather is sunny. If weather will be sunny, it will say play outside. Let's say weather is um cloudy. Okay. Now weather is neither sunny nor rainy. It's something else. So it will say, I am confused. Should I go outside? Should I play inside? What should I do? I do not know. So your program actually is making sort of a decision how you can move on. So that's all about decision making. No, no, it's not all. You have a nested if as well that will be studied in next lecture. But before next lecture, you will have to update a game that you just made in a few lectures back. The that guess the number game. That in a game where you made your friend to guess a number, and you were just telling true or false. But now your assignment is take an input and you will have to tell your friend if that number is actually that hidden number. If it's actually the hidden number, you will have to tell your friend you win. If it's not the hidden number, then you will have to tell your friend you lost. So I hope you will be done with this little assignment before next lecture. Until then, bye. So far, we have discussed decision making, and in decision making, we have discussed if, else. Today, we will discuss nested if statement. But before that, we have to complete something that we left in last lecture. We have to update our guess the number game. So let's say um, user. Actually, let me be a little bit lazy and copy my old code from here, paste it over here, and let's remove this line. And let me do something like int. I hope you understand what I'm doing. If you're not understanding, I'll repeat. This input statement returns me answer in string. I'm just converting that string into integer. And let me see. Oh, let me define our hidden variable. Hidden number equals to, let's say again, 10. Let's run it and let's remove it. Now our goal is to tell our friend if he's winning or not. So I'll say if hidden number is equal to user input, then print hey, you won. And else if, else if or elif hidden number is not equal to user input, then do what? Print you lost, try next time. Okay, now let's dry run our code. Dry run means before giving this code to the compiler, you will have to act like a compiler, that what your code is doing actually. So you are getting input in user input from from your friend or someone. Then you're comparing that user input with a hidden number that you have already defined and removed. And if the user input is equal to that hidden number, you're saying, hey, you win. If it's not equal to that user input, you're saying, no, 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 you lost. You have to try next time. So let's try to play this sort of a game. So if your friend says 5, hits enter, you say, you lost. Try next time. And if play again, he says 10, you says, hey, you won, man. You won. So that's just a simple game. We will extend this game up to a better level in upcoming lectures. But for now, our topic is nested if. It's a little topic. So how do we do that? We say if weather is sunny, okay, then call friends. And if friends are available, then I will play soccer. So we are making a decision, the dependent decisions. This decision uh, depends on the decision before it. I will call my friends if weather is sunny, and if friends are available, then I will play soccer. We will implement it here. Let's say if weather is let's say sunny, then print sorry call friends. And if friends are available, then do what? Then we will play soccer. Yahoo! So let's run it, but it will give me an error because it's not giving me an error. We have not defined friends yet. It's annoying. So let's define friends. That's why it is doing nothing. Oh, yes. So it's another important thing, interesting thing. I'm trying to run it. You can see it's not printing the output. Neither it's giving the error. It should give an error because friends is not a variable that we have already defined. Why it's not giving the error? The answer is weather is not sunny because we have said that weather is cloudy. So it is not executing all these statements. It's saying if weather is not, weather is sunny, it's false. If it is false, I will not look whatever comes inside me. Whatever comes in then block, I will not look into it. So if I'll say weather is sunny, then let's execute it. So here we go. As I expected, it is giving me an error that friends is not defined. So I'll define friends variable here. I'll say, let's say not available. Let's run it now. So it says call friends, but just call friends. You cannot play soccer because friends are not available. And if friends are available, let's see. It says, okay, call friends, play soccer. Perfect. So that's how you can use nested if statements. You can use these nested if statements in else block as well, elif block as well. And exactly, this is going to be your next assignment, where you will have to extend our game, guess the number game, so that if your friend inputs exactly the same number, then you will say, hey, you won. And if the input number is wrong, then you will not have to say you lost. You will have to tell him how you lost. Your entered number was less than the actual number or greater than the actual number. You will have to direct him so that next time when he plays, your friend knows, okay, last time my number was less than the actual numbers, so now I have to enter that sort of number. I hope you understand what I am expecting you to do in next lecture. And in next lecture, there will be no new concept. We will just be completing our this game because our fundamental concept, that is decision making, is done. And in next lecture, we will just be completing our game. Up till then, bye. Okay, guys, so we just have to complete our incomplete game in this lecture that we left over here. So I'll just copy and paste it over here, and we will try to complete it. So if hidden number is equal to user input, then we will say, hey, you won. And if hidden number is not equal to the user input, then we cannot say just you lost. Friend can ask how I lost. Tell me. So we have to tell him that your entered number was less than the actual number, or your entered number was greater than the actual number. So how can we do that? So, let's remove it, and we will say, okay, if input is equal to hidden number, then say you won. If input is not equal to hidden number, then do what? Then we will say hidden number. If hidden number is less than user input, then we will say print. What should we say? We should say your entered number is greater than the actual number. Perfect. And here we will say elif hidden number is greater than user input, then we just have to say is smaller. Perfect. So let's run it. We know that our hidden number is 10. So if our friend will say 10, we'll say, oh, you won. And if our friend says 20, then we'll say your entered number is greater than the actual number. See, this block is executed. And if our friend will say 5, then our program will say your entered number is smaller than the actual number. It's not the actual number. Okay, so that's how you can do it. It's one way to do it. It's sort of a hairy code. And let me give you a piece of advice over here. You should avoid nested if as much as possible. You should not be writing code in nested if unless it is necessary, unless there is no other way to code. In our case, there are a lot of ways to avoid this nested if statement. For example, let's again copy this cell, paste it over here. We are just going to improve our code, the readability of our code, and we will say else if number is not equal to user input, rather than this we can say number is if number is less than this, then do something like this. We'll say entered number is greater than that, and here we'll say else, just else. We do not have to say anything else. Why? Think why. Small. Because if number is equal to if input number is equal to hidden number, then we'll say you win. If entered number is greater than the actual number, then we'll say the number is greater. Else, why we are not writing something like this over here? Because there can only be one possible situation that our program will come over here. If number is equal to this, it will come here. If number is greater than that, it will come here. And else, if number is smaller than that, it can only come over here. Other than that,
it will execute one of these blocks. It's just a better way to do it. Let's test our program. Let's say 10, it says you win. Okay, let's say 20, it says entered number is greater. If I say 5, it says entered number is smaller than the actual number. You see, now this code is a little bit more readable. It can be made more readable, but it's one way to make our code readable. Guys, that's all about decision making. And from next lecture, we will try to start our next topic, another very important topic, that is loops. We have two types of loops, for loops and while loops. Uh, we will start this topic in next lecture, and this game will be made more better in next when we will study this new topic. We will be continuing this game up till the last lecture, but this game will be made more interesting and interesting. As you can see, we started this game from nothing, and now it is a little bit interesting. So until then, bye.
Welcome back, guys. So today our topic is loops. We will be discussing about loops. There are two types of loops available in Python: for loops and while loops. Now, what is a loop and when do we use the loop? Guys, when we want to repeat something for a finite or infinite number of times. By infinite, I mean we don't know when it's going to end, but it ends sometime. So whenever we want to repeat something, we use loop. Please listen carefully. When we want to repeat something, as this symbol shows that when we want to repeat anything, we do not write it again and again. We just write a loop for it. How do we do that? Let's start it by looking at for loops. For loop is used for iterating over a sequence that is either a list, a tuple, a dictionary, a set, or a string. What does it mean? What does iterating mean? Iterating means repeating over a sequence. Let's discuss its syntax, and when we will go to Jupyter Notebook, you will be having complete idea what I'm talking about. So for, we type for as a keyword, for index in range of any sequence. Now it might be a little bit confusing for you. Let's go to the notebook and let's say for, actually, first of all, we'll say we are studying loops, and inside the loop we are going to study for loop first. So I'll say for index in. This for and in are the keywords. Index is just a variable. I'll tell you what it is. For index in range is also a keyword. I'll just say 10 colon. Next line, again indented line, and here I'll say print index. Let's run it. Here we go. You see, counting from 0 to 9 is printed because range was from range is 10. By default, it starts from 0 and it ends just before the letter we write here. And if I want to print counting from 5 to 9, I will say 5 comma 10, so that range will produce numbers from 5 to 10. Let's see. Here we go. Now you can see the numbers are produced from 5 to 9. And if I want to print 5 to 10, I'll have to write 11 over here. Perfect. I hope you understand. Now what's happening over here? For loop executes this statement, whatever written in the body of this statement, this loop, it executes this statement for that much number of time that is written over here. Now, in the first iteration or in the first repetition, the value of index is 5. In next repetition, the value of index is 6, and so on. Now, we can repeat this thing, this range thing, with any sequence. When I was teaching you list, or I was teaching you dictionaries, or I was teaching you tuples, it was written over there. They are the sequence. We can iterate over them. How can we iterate over them? Let me show you. We had a list, my list. Yeah, let's see. Here we go. Hello world, live long, 50.5, and another list. So this list contains 3 elements, right? If I write this, my list over here, I'll just replace it. Here we go. And let me print it. Now you can see it has printed each and every index of the element of list. In first iteration, this index contains the first element. In next iteration, this index contains the second element, and so on. Let's verify it. Let me show you a new thing. If I'll say type, and in arguments I'll pass my list, it will tell me what is the data type of my variable. So I'll do the same thing over here. Now, as we can see that this list, my list contains 3 types of data: string, float, and a list. So I'll say do not print the list, but print the type of index for me. So here we go. Now you can see the first data type was string. Let's see in parallel. First data type is string, then float, and finally list. So I hope you've got an idea how can we iterate over a list, and same is the thing, you can iterate over the tuple, you can iterate over the dictionary, and so on. Exactly, almost the same thing. Now let's come back to the range thing. Let's say range from let's say from 1 to 11, and it will print just index. Oh, here's a syntax error because we should write comma over here. Okay, so it's printing counting from 1 to 10. What if I just want to print the number which are even in this range? What will I do? First of all, I'll have to decide which one is even and which one is not even. So I'll say if index is actually index modulus 2 is equal to 0. It's just mathematical definition of the even number. You can read it out later. And then this then sign, and we are indenting this print statement with this if statement, so that if index is even, only then the number will be printed. Let's run it again, and now you can see it's printing 2, 4, 6, 8, 10. It is not printing 1, 3, 5, and so on, because we have written a check over here. Now you can see it's so much powerful thing to have in your toolkit. We are just printing from 1 to 11. If you'll have to print from 1 to let's say 10,000, yeah. So what will you do? You will just do this thing, and from 1 to 10,000, all even numbers are printed. That's it. So it's that much simple, that much useful for you. So that's all about for loops. And in next lecture, we will be studying the while loop as well. But before that, here's an assignment. We have developed a game, that guess the number game, in last lecture. Now you will have to append the game. You will have to make that game a bit more interesting. How? Here's the case. In past, we were just giving our friend one chance to guess the number. If the number is right, friend wins. If the number is wrong, friend uh, loses, or friend is directed that your number is greater or your number is smaller. Now, what you have to do is you have to give your friend five chances, at least five chances. If friend will be able to find the number in five chances, friend wins. Otherwise, friend loses. And in every term, if friend does not able to find the right number, you will have to redirect our friend by using these statements that your number was greater or smaller and so on. That's all from today. I hope you understand your assignment for the next lecture, and we will be implementing this assignment in next lecture. Until then, bye. Okay guys, so far we have studied for loops. And now we will proceed toward the second type of loops, which is while loop. Before that, let's complete our game that we left in last video. So we have to give our friend at least five chances so that he may win and may lose. So let's make this game a little bit interesting. So I'll just say for I in range 5, this will iterate 5 times, and then I'll have to paste it over here. Actually, indentation issues. Now it's perfect. So it will iterate 5 times, and each time we will take input, guess the number, we will compare it, and then we will tell. Rest of the code is just the old code that we wrote in previous videos. We have just wrapped it in a for loop, as you've seen that. And one more thing that we will do is we'll say print it is, I'll say turn, turn 1. So it will print the number of turn that our friend will be having every time, like this. Let's run it, and it says turn 0. It looks a little bit odd because it should be turn 1 over here, but we will improve it. Let's try to play the game now. We know that original number is 10, so let's take a wild guess, and I say 80. It says your entered number is greater than actual number, so I'll say okay, it's greater, so I'll enter 60. It's also a greater number, and it's my turn 2, which means the third turn. So I will say, okay, let's try 15. Again, it's greater number. Okay, I'll try 5, but it's smaller number, and now it's probably my last turn. I'll say, okay, a number is greater than 5. Number is, greater than 5 and smaller than 15. So let me try 10. It says, yay, you won. Now, game looked a little bit odd because turn was starting from 0. So there are two ways to do it. Number one, I can do I plus 1. This can also be done. And the second way is I can say from 1 to 6. Let's run it again. Now it says turn 1, and rest of the thing will go as it is. So let's just play this game in a hurry. 8, 10. Oh, let's not guess the number. 90, 80, and finally I'll say 50. It says no. And we can improve this game by saying at the end print Let's not do it right here. Let's do it in our next project. So guys, that's all from for loop, and let's talk about while loop now. While loop is also just a loop like for loop, but in this loop we cannot iterate over a list or something. We can just iterate. How? While loop is a conditional loop, which means it will run until the given condition is fulfilled. These last three words are very important. Until the given condition is fulfilled. For example, value is equal to 5, and I will iterate over it until this value is less than 5. The moment this value is not less than 5, I will not iterate. That's the theory. And this is the body of loop. You can do anything over here. Literally, what's happening over here, value is 0. So I'm saying value is less than 5. It says yes. Okay, print the value and increment the value. Now value becomes 1. 1 is less than 5. Yes, 1 is less than 5. It's true. Okay, print it again and again increment it and so on. The moment value becomes 5, I'll say 5 is less than 5. It says no, it's false. I'll say, okay, come out of the loop and do not execute its body. That's it. That's all about while loop. Let's implement it in our environment, and let's say value is equal to 0, and while sorry while value is less than 5, print value and also value plus equals to 1. Let's run it. It says 0 from 0 to 4. The moment value becomes 5, it comes outside the loop. And let's say print value over here as well, but print as well outside the loop. Okay, let's see. Now you can see it is printing 0, 1, 2, 4, 1, 2, 3, 4 inside the loop, and when value becomes 5, it compares 5 is less than 5. No, it's false. It comes outside the loop, and now value has, this value contains 5. That's why it is printing outside the loop 5. So whenever you do not know when loop will terminate, and just you have a condition that whenever this condition will fulfill, terminate the loop, you use while loop over there. Otherwise, if you want to iterate over a list, if you want to iterate over a dictionary tuple or anything, then you use for loop over there. So now it's your decision, and it's your sort of assignment, that you have to decide whether while loop is better for this game, or for loop is better for this game. Whatever you feel right, try to implement this game in that perspective. In the beginning of next video, I will not implement this game from scratch again, but I will just direct you which loop is better for this game and why. Why I'm saying that, which loop is better. I'll give you the reason as well. Until then, bye. Hello guys, I am back with a brand new topic, which is functions. Now what is function? Let's read it. In programming, a function is a block of code which only runs when it is called. You can pass data known as parameters into a function. By reading this definition, I got nothing. Now let me introduce you what is a function. Try to imagine you are going to build a house and you do not hire anyone. You say, okay, I'm good enough. I can do anything. I can do everything. So I will build the whole house by myself. You start from the basis of your house. You build it up. You do all wooden work by yourself. You do all electrical stuff by yourself. You do all paint stuff by yourself. You do all kitchen stuff by yourself. Is it literally possible? No, it's not. Even if it's possible, it's not efficient. So in real, what do we do when we build our house? We call few specialist people who are renowned for a specific job. For example, we call builders to build the house, to construct the house. We call separate person who has expertise in wood for wooden work. We call electrician for electrical work, and so on. And we call, of course, painter for the paint stuff. This is called single responsibility principle. So everyone has its single responsibility. Exactly the similar thing we do in programming. When we want to, wherever the house will be built, the same electrician will be called, same or at least electrician will be called, and electrician will do the job, exactly the same job. So in programming, when we want to do the same thing over and over again, we do not repeat that thing in the code. Repetition in programming, in coding, it's really bad practice. So we make it a function and we call it whenever we want to use it. I know you're not getting exact idea, but think of functions just like a house building example that I gave it to you. So you will get the whole idea when we will implement it in Python. We have three types of functions: simple functions, Boolean functions, and value returning functions. Now, what are simple functions? A simple function is a block of code that performs a specific operation. What does it mean? What is a block of code? So this is a syntax: def, that means define my first function. This can be any name, just it has to be def and then any name, and then colon. Then we have to write the body of function. It's just printing this is my first function. And let's do it. Let's try to do it. Here we go. We are saying that simple function. Perfect. So I'm saying define, my function name will be print hello, sorry, hello world, colon. I'll say print hello world. Let's execute it. Oh, we have an error. It says it's not good. So what's wrong here? Because we have not written parenthesis here. This parenthesis tells you that it's a function, not a variable. So let's run it. It has compiled. Now let's see how can we call it. We have to print it. Print hello world, and here we go. It's printing hello world. And the beauty is I can do something like this, and it will print hello world as many times as I'll say print hello world. Now it's just a basic function. What if I want to print my name? It will always print hello world. Now what if I want to print a function that prints anyone's name? So I'll say define print name. It's another function. I'll say print. Here I'll pass an argument. I will say name. There's a variable. I'll explain it in a bit. So I'll say my name is name. Okay, so this is a variable that I will pass from its calling position.
What do I mean? I mean, when I'll say print name, I'll tell my function what name to print. Print Sam. Okay, so this Sam will be stored in this variable. When Python will be compiler will be compiling the code, it will store this variable, the value this in this variable, and finally name will be printed over here. Let's try to do it. Here we go. My name is Sam, and if I'll call the same function with different name, my name is, let's say, Jack. Let's run it. You can see initially it says my name is Sam, then it says my name is Jack, and then you can do it how many times you want. You can do it. So that's all about the simple functions. Your assignment is to print the name of 5 people using a loop. And hint is you can store the name of 5 people in a list. That's just a hint. In the beginning of next lecture, we will try to solve it. Until then, bye. Okay guys, let's complete our task. Let's say names list equals to, we have to write 5 names: Sam, Jack. Who are you? What's your name? Type your name over here. Whoever are you? You are. I am Sajjad, so I'm typing my name. Let's say Chaddad. I guess with single D. And let's say last name. Let's write it like this. Now we can do something like for I, for name in names list, and print name. Here we will say name, we'll pass name, and that's it. We will just run it. And you've seen the magic of for loop and our method. We have done everything in just 2 lines of code, and that's it. So that's the solution of what we started in last lecture. And one more thing, I promised you in second last lecture that I will tell you while loop is better or for loop is better for our guess the number game. I forgot to tell you in last video, so I'm telling it right now. Actually, in my view, while loop is better because you are going to iterate 5 times and you can do something like this. You're not going to iterate over a list. You're not going to iterate over a tuple or something. So, in my views, while loop is better. You can differ. You can have your own point of view. That's very good. Programming is all about point of views. You can come up with a better logic, with a better readable logic. So that's my point of view. You can, disagree in the question answer session, and we can have a little bit of debate. So guys, that's all about simple functions. Let's move on toward our next topic, that is Boolean functions. So far, we have written functions that are just following our orders, that are just performing some job, and that are not giving us a feedback in terms of values. Now, what do I mean by this? So, what is a Boolean function? A function is a block of code which only returns true or false. Important thing is which returns. This return is very important. That returns something. What thing? True or false? What does it mean? How does it work? So it says define my Boolean function, return true. It will always return true. And there is another function that says define is less xy, return
x is less than y, question mark, true, colon, false. I know you doesn't understand anything out of it because this is a new thing for you that I have introduced for you. So let's implement it so that you get an idea. Here we will say Boolean functions, and we will say define, let's say is, what should be the name of my function? Is even. Okay, so my function will tell me if the number is even or not. So I'll say if number modulus 2 equal to 0, then return true, else return false. And here is an error because we haven't wrote colon over here. So I'll call it, I'll say is even, and I'll pass 5. It should return me false, but it is giving me an error. It says name, sorry, in Python we write true with capital T and we write false with capital F. So let's recompile it, let's run it. Here we go. It says false because number modulus 2 is not equal to 0. So it is this block is not running, else block is running, and that is returning me false. Okay, so the same thing I can do in if statement over here. If is even, then print number is even. Let's run it. Since 5 is not even number, so it's not saying number is even. So let's write an even number. 8 is an even number and it is saying number is even. It's calling the function, and as we know that if statement takes true or false over here. If true, then body is executed. If false, then body is not executed. So guys, these sort of functions are Boolean functions. And now let's try to read this statement. It's called tertiary statement, and how it works. It says that x is less than y, question mark. We can write if else statement in just one line by using this sort of code. So if this is true, if x is less than y, then true will be returned, otherwise false will be returned. Let's try to do it over here. Let's remove this code and let's say return num modulus 2 equal to 0, question mark. If it's true, then return this, otherwise return false. Perfect. Let's compile it, and it's giving me the error, maybe because of this space. No, it's the error is something else. Let's try to find it out. Oops, I've just realized I wrote code in Ruby language. So just for your information, that's how you write tertiary operator in Ruby language, but we are coding in Python. We have to follow the Python coding language. So we will say return true if num modulus 2 equal to 0, else return what? Else false. So the code that we wrote in a few lines, now it's written in just one line, and it will be executed in the same manner. Now you can say 8 is even, 5 is not even, so it is not executing. Let's revise what we have done. It's a new thing for you. It returns true if number modulus 2 is equal to 0, otherwise it will return false. Exactly the same thing that we just wrote before. So it's the Boolean function. The next thing is value returning function. Now what is it? A value returning function is a block of code which returns one or more values. What does it mean? Actually, Boolean functions are also value returning function because these functions returns true or false. But the limitation of Boolean functions are they only return true or false. But value returning function can return any sort of value. They can return an array, they can return a list, tuple, number, string, true, false, whatever. It's a bigger sort of thing. So let's try to implement it in our code. And let's first say value returning functions. So syntax is almost similar. Define. So we are going to write a function that appends, that takes name and joins our name, first and last name. So name of the function will be join name, and it will take first name, and then it will take second name. And what it does is it says str equals to first name plus space plus second name, and then it returns str. That's it. Let's compile it. Now let's try to call it. Join name, first name is Sajjad and second name will be Mustafa. And let's try to run it. Here we go. We have, we sent our name Sajjad and Mustafa. It has returned the complete name with a space in it. Since it is a string, so I can store it in any variable. Let's say full name. Here we go. And then we can print our full name like this. Perfect. And just to write better code, we do not have to store it in any variable. We can directly return it. And we can get rid of this line. Let's run it again. And is it producing the same output? Yes, exactly same output. Now, one point for you to notice in every sort of function, whenever return statement comes, it ignores anything that is written after the return statement. For example, if I write print statement, print blah, blah, blah over here, and I'll call the function again, you can see blah, blah, blah is not printed. Why? Because return statement comes before blah, blah. If return statement comes after blah, 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 then it will be printed. Let me show you. Here you can see blah, blah, blah is printed and then it returns first name. But in previous scenario, it ignored blah, blah, blah because when return statement comes, compiler ignores anything that comes after blah, blah, blah. I hope you find it funny, blah, blah, blah. So that's all, guys. That's all about functions. And that's all about Python course as well. We have covered the most important topics of Python so that you can follow me along when we will be implementing machine learning, because it's really important to have the tools in your hand so that we can implement machine learning. For now, guys, it's end. And finally, I will make another lecture where we will implement functions, and that will be our final project where we will make a sort of basic calculator in which I will try to use most of the concepts that we have used in this course. Until then, bye. Welcome back, guys. This is our final video, our final lecture regarding Introduction to Python. In this lecture, we will be trying to make a calculator, a very basic calculator that will cover most of the topics that we have uh, discussed in our course yet. Not every topic, but most of the topics. So let's do it. So we want to make a calculator. Let's define a function that is calculator like this. Sorry, I accidentally compiled this, and here you can say this. Pass is actually, if you do not want to define a function, you just type pass here. But we want to define a function. Why won't we? So these are a few lines that we have that I have already written. So what it just prints a few statements. It says, let me call this function for you in a cell over here, and then you will be able to clearly see that what's happening over here. So let's compile it, and then let's compile it. So it's just printing a few statements that for addition press 1, for subtraction press 2, and so on. For exit press 0. So first of all, we have to say choice. What's the spelling of choice? I don't know. Let's say this is the spelling of choice. I am initiating it with, let's say, any value, any negative value. Here I'll say while choice is not equal to 0. Okay, just indent it. Sorry, we do not use parentheses. And while choice is not equal to 0, keep doing it. And here we will say choice equals to input. We'll take input and enter the choice. That's it. And one more thing, we have to wrap it in integer. We have to typecast it. So let's compile it and let's run it. So I'll say 4, it will again compile. If I'll say 0, it will stop. So our choice is ready. Now, based on choice, we will have to do certain decisions. So here we will say, let's say calculate. We'll call another function that will calculate, and we will pass our choice in that function. And where is that function? That function is nowhere. We have to define this function. So let's define it over here by saying define choice, calculate choice. So here we will say if choice is equal to 1, then do something. Let's say do something. Similarly, elif choice is equal to 2, again do something. Elif choice is equal to 3, again do something. And finally, elif choice equal to 4, again do something. So we will decide what we have to do. And finally, else whatever other than 1, 2, 3, 4, whatever it is, just say wrong choice. Perfect. So
what we are going to do is, if choice is equal to 1 in the menu, if we can see that it is saying for addition press 1. So we have to do addition over here. So I'll say addition, that's it. And what else? I'll say subtraction. Here I'll say multiplication. Here I'll say division. That's it. And now what is addition, what is subtraction, and what is division, what is everything? We have to define it. But before that, but okay, let's define it first. Copy. So we'll say define addition. Addition takes two numbers, so num1 and num2. It will return num1 plus num2. One thing to be noted is we are passing the two numbers to it, but we are not passing, we are receiving two numbers in it, but we are not passing any number to it. So we have to pass two numbers over here. We have to pass two numbers over here as well, two numbers over here as well, and two numbers over here as well. Now, what are these two numbers? We have to do something like num1 equals to integer input. We'll say enter num1 colon, and then we'll have to do something like enter num2, and then we'll have to do the same thing over and over again. But it's a bad practice. We are repeating our code. So what's the hint over here? We have to make a function of it as well. How can we do it? So that's how we are going to actually define a new function that is, let's call it take input. Okay, and we'll have to do something like this. We'll have to cut and paste it over here. Indentation has become pathetic. Now it's indented. And we will return num1 comma num2 on return. That's it. And here we will just call this function. Here we go. We are going to just so we'll say num1 comma num2 equals to this function. That's it. And we are going to do it over here as well, over here and over here as well. Perfect. And we are passing, yes, everything is fine. Now, one more thing that you have to take care is you are calling calculate over here, but it's defining over here. You have to define a function before it's called. So ethically, this cell should be before this cell. So I'm calling it up. Here you can see, and you're calling addition over here, but defining addition over here. So addition should be at the top like this, and take on input is being called over here. So it should also be shifting above. Perfect. Now we have to define our other functions as well, and we can. It's really easy. For now, I'm just defining two functions. Subtraction. Rest of the functions are supposed to be defined by you people. So let's again view it. So if choice will be okay. So now let's try to run our program, but I find a little bit mistake in it. Let's correct it. And that is, if choice will be 0, we are not saying goodbye to our user. It is a good practice to say goodbye to your user at the end. So I'll say if choice is equal to 0, then print goodbye like this. And that's it. I think we're good to go. Let's compile these cells and let's call our calculator. Here it is. It says press 1 for addition, press 2 for subtraction, and so on. But another important thing is we are not printing our output anywhere. We are just calling addition that will return a value and so on. We are not printing the values. So we have to print our values as well. So we will just say print, and over here we'll do something like this, and again, sorry, print. That's it. Rest of the you know rest of the thing can be done by you. So here we go, and let's start our calculator. So I'll say it says enter your choice, and for addition press 1, for subtraction press 2, and so on. So I'll say I want to add. It says enter number 1, I'll say 5. It says enter number 2, I'll say 20, and it prints the result of addition, which is 25, and then again it is prompting me for addition, subtraction, and so on. So again, let's try. I want to subtract values. It says enter number 1, I'll say that's it 50. It says enter number 2, I'll say 20, and here is actually it is not printing it because we have not written the print statement over here. It has to be corrected. Okay, so other than that, it's working fine. And again, it's asking us for addition, subtraction, multiplication, division, or exit. If I'll say 0, it says, okay, goodbye. Okay, guys, that's all about our calculator project. It's little bit very basic sort of calculator that we have just created. And let's go back to presentation. So guys, that's all about Python. And the concluding remarks are, if you want to get better grip on Python, you have to do two things. One, you have to practice. Number two, you have to practice. That's it. You have to practice a lot if you want to get better grip on any programming language. And since we are going to study machine learning from next video, Python is the best language for machine learning. I'm again telling you. So you have to practice it a lot. And from next video, we will be doing some, interesting stuff that will lead you toward the machine learning and stuff. Until then, bye.
Hello, guys. Welcome back to this brand new session of Logistic Regression. So far, we are done with the introduction of course, introduction to Python, and a general introduction to machine learning. In this section, we will specifically try to learn one algorithm, and that is logistic regression. Now, what is logistic regression and when should we use it? what are the benefits of using logistic regression? Everything from scratch to the advanced level of logistic regression will be discussed in this course. One interesting fact from where I will take the start of this section is the following. As you can see, the name says logistic regression. And interestingly, let me tell you, it is not a regression algorithm. Now, question is, if name says it's logistic regression, then why it's not a regression algorithm? And if it's not a regression algorithm, what is it actually? So the I'm going to give you half answer right now, and the other half answer will be given at the end of this section. So why do we use logistic regression? We use logistic regression for classification. Uh, Classification and so on. But name says regression. And if name says regression, why do we use it for classification? And let me tell you, it can only be used for classification. It can never be used for regression. And now, what is the difference between regression and classification? We have already discussed about it in previous section, in introduction to machine learning section. I believe you already know what is the difference between regression and classification. So this model, logistic regression, is actually a purely classification model. Its name just says regression. And why its name says regression, I'm not going to tell you right now. You'll have to wait for it until the end of session. So let's get started officially. So we'll start from a little bit of motivation. Why should we use logistic regression and everything? And then pros and cons. Of course, everything has a pro and cons. Then when should we use logistic regression? The point is, machine learning has got like dozens of algorithms available. And what will be the time when we should use logistic regression? What will be the situations we'll be discussing in this section? And then we'll be discussing every topic in the aspect of a final project. We will be having a final project in this section that will be completed by the end of this section, and we'll discuss every section and every topic in the aspect of that final project. And our final project is actually to classify the Titanic data. Now, what is a Titanic data? We'll discuss about it later. And that's about the course. That's about the section right now. That's what we will be doing in our whole section. So let's get started with motivation. So first point says it is regression analysis. The logistic regression is a predictive analysis, which means it is used for predictions. If you want to predict something, if you want to predict that a certain email is spam or not, if you want to predict that if a certain cancer patient is going to die or live, if you want to predict that if a certain uh, passenger on Titanic is going to die or being rescued, what are what can be the scene? So that can be that can be discussed under the umbrella of logistic regression. And then logistic regression is the appropriate regression analysis to conduct when the dependent variable is binary. Guys, this is the most important thing. When the dependent variable is binary, we have already discussed what is the dependent variable. Let me discuss it again. If we are talking about in the aspect of email spam or not, then the final result that is concluded, the output is actually the dependent variable. If we are talking about Titanic dataset, then the final variable that says if a passenger is going to die or passenger is going to be rescued, that is the dependent variable. So if we are going to use logistic regression, our dependent variable has to be binary. It has to be 0 or 1. It has to be spam or not spam. Of course, spam and not spam are not binary, but we can easily convert them into binary. So this is very important thing, guys. You have to note it down. Our dependent variable has to be binary. Now question is, if our dependent variable has, let's say, three classes, let's say 1, 2, and 3. Okay. Now if our, let's say if this is the scene, if following is the scene, our we are going to do predictive analysis on email spam or not. One for email spam, two for email dot spam, and three for email outstanding or something, So now you can see that this is not binary dependent variables at all. There are three dependent variables. So now question is, can we use logistic regression in such case? I mean, can we only use logistic regression where there are only two dependent variables? And what if there are three dependent variables? This is a question. And my answer is yes. We can use logistic regression in both cases, especially when dependent variable is binary, and when dependent variable is not binary, it's more than two, it contains more than two classes. We can even use logistic regression, but we'll have to classify our final output into binary classes. Now what do I mean by that? You just have to, I just wanted to tell you that if you don't get it, do not worry about it. We will discuss about it later in detail. There is a complete session on it. And then finally, logistic regression is used to describe data and to explain the relationship between one dependent binary variable and one or more independent variables. I hope you guys understand what is independent variable and what is dependent variable. So our logistic regression actually tries to find out the relationship between dependent and independent variable. For example, if we say uh, this is the x-axis contains the amount of investment, I'll say I, and y-axis contains the amount of let's say survival or not, business is going to survive or not survive. So now if your x-axis contains the features, the independent variables, and y-axis contains the dependent variables, your logistic regression is going to find a sort of relation. You know what is a relation or model in machine learning? It's going to find a relation in machine learning that will tell you if on certain amount of investment, your business is going to be survived or not. So in whole, like all other regression and classification algorithms, logistic regression is also going to be a predictive analysis tools. The crux of this course, this video is the following. It's a predictive analysis tool. It is very useful when the dependent variable is binary, and it is going to tell you the relationship between dependent and one or more independent variable. Guys, that's all from today's lecture. Until next lecture, bye. Discuss the pros and cons of logistic regression that will allow you to pick and choose when should you use logistic regression and when you should not. So the first pro or benefit of using logistic regression is logistic regression performs very well when data is linearly separatable. What do I mean by linearly separatable? So let's say this is the graph and we have the following data, some blue points over here and some yellow points over here. You can see that this data can easily be separatable by this green line. So we can say that this is linearly separatable. It's not actually a linear line. A linear line can be very straight line. Okay, so logistic regression performs very well when data can be separated by a linear line. What if data cannot be separated by a linear line? We'll discuss about this scenario as well. Then logistic regression is less prone to overfitting. So we've discussed what is overfitting, and the chances of overfitting in logistic regression are very low. But if data is very high dimensional, then it can be overfitted. What do we mean by dimension of data? Uh, in very simplest way, we can portray it like if our data set contains a lot of features, one feature can be referred as one dimension. For example, if investment is here, this is one feature. You can see that investment is one feature, so it has one dimension. If there is another feature, let's say profit, this is P, so it has another dimension. And if we are talking about another feature, let's say this is Z dimension, and then that other feature will be uh, portrayable over here. So the more features of data, there will be more dimensions. So if dimensions are very high, then there are chances of overfitting. But generally, it is logistic regression doesn't overfit. Then logistic regression is easier to implement. You will see it's really easy to implement, and it's very efficient to train. Its training time is very less than the other algorithms. And then let's talk about the negatives of logistic regression. Before that, let me tell you, if you're told that we have a data that has where we have only binary output variables, binary dependent variables, and it is a less dimensional data, and I need a very quick solution. I need a very quick predictive analysis tool. So you should be just thinking about logistic regression, because logistic regression contains all these features. Now let's talk about the negatives. So if the number of observations are lesser than the number of features, logistic regression should not be used because it will overfit, as we have just discussed. So how many number of features should be there? Number of features should be lesser than the number of observation. What are the number of observations? The number of rows in our data, right? Okay, the limitation of logistic regression is the assumption of linearity between the dependent and independent variable. So we assume that our data is linearly separatable, as I have discussed. So if data is not linearly separatable, logistic regression is not going to perform very well. Again, I tell you, if data is not linearly separatable, there are some other ways to implement logistic regression over there as well. But uh, in other ways, we portray and we assume that our data is now linearly separable. We in other words, we throw our features into a high dimensional space, let's say an infinite dimension space. Some mathematical terms are there, so that it becomes linearly separatable. We do not fit a line there, we fit a space rather than a line. So it ultimately becomes linearly separatable. And finally, logistic regression can only be used to predict discrete functions. What do we mean by discrete functions? Uh, Logistic regression can only tell you the value of yes or no, or it can tell you the classification functions, as we've discussed in last section. It is a classification algorithm, so it can only classify things. It cannot tell you, okay, if certain amount of investment is there, okay, then you're going to get that much profit. It is not going to give you a continuous value, it is not going to give you a continuous function. It will only give you a discrete function or a classification function. So that's about pros and cons, and let's discuss quickly about when should we use it. We have already discussed it. Let's discuss it again in a bit. When data set is linearly separatable, okay, we have discussed it. When need to predict discrete functions, okay, for example, email is spam or not. For example, someone on Titanic is going to live or rescue, is going to die or rescued, and etc. When need to classify data into two or more categories, Okay, we've discussed it. And finally, can we use logistic regression if data is not linearly separatable? Yes, we can use it. But again, for example, let me give you an example. If data is something like this and like this, these yellow lines. Okay, now you can see that no linear line can separate them. No linear line, like never. There will be a little bit chance of, you know, uh, deceive, our model can deceive us. So what should we do if data is not linearly separatable? So we throw our features into infinite dimensions. You do not have to understand it completely, but let me just tell you. You throw your feature into infinite dimension space so that it becomes a linear separate. Right now we want to try a line into it, and no line can be fixed into it. No line can separate them. But if we throw this data into a higher dimension space, then we can use a space, a complete space, rather than a line that will ultimately, a very good predictive model for them. So yes, the answer of this question is yes, a big yes. Okay, so guys, that's all um, about pros and cons and when should we use logistic regression. And in next lecture, we will discuss about the final project that will be our goal of this section. What will be the output of this section after this section? What you will be capable of. So we'll discuss about the data set, the goals, and roadmap to achieve the goal. Until then, bye. Welcome back, guys. In this video, we are just going to discuss our final project. So what is our final project? Our final project is to classify the Titanic dataset by using logistic regression. So first of all, let's see the dataset we have available. So this is the dataset that I will be posting its link or maybe the complete dataset below. So what is it? It contains some features, and finally a class a class column in green color. All these white columns are independent variables, and this green colored column is dependent variable. All these white colored columns are called features, and this green colored column is called output or class or target. It has several names. So as you can see, it says 0, 1, 1, 1, 1, then 0, 0, 0, 0. What does it mean? 0 means this person has not survived. And 1 means the following person is survived. Now, this is passenger ID of person. This is the uh, you know its class. It has this Titanic had three classes: first class, second class, and third class. So this column contains passenger class, passenger name, passenger gender, age, how many siblings or spouses that passenger had on that on Titanic, how many parents and children that particular passenger had on that on Titanic, and then the ticket number, and then the fare, finally the cabin and embarked station. It had a few embarked stations, S, C, and Q. So provided all these features, it tells us that the study tells us that that particular person survived or not. 0 says it doesn't survive, and 1 says yes, it survived. Now, as a human, by reading out this data, so let's imagine Titanic is sinking. We all know that Titanic was that giant ship that sank into the oceans, and a very few people were rescued, a few people were died. So what if there is a news that a huge cruise or a huge ship is sinking? The rescue teams will go over there and they will try to rescue kids or the old age peoples before anyone else. And once they will be done with that, priority will be the kids and children and old age people, and then they will come toward the younger age people with younger ages. So maybe the people with lesser ages have greater probability for survival. Maybe it's not sure, but maybe. And we can portray some hypothesis like this. But our logistic regression model will exactly tell you if age of a person is this, if class of a person is that, if cabin is that, and embarrassed station is this, then a person is going to survive or not. Because it may be possible that the survival of first people in first class is easier than the people in third class. Maybe third class is way below than the first class, and something like that. I haven't visited Titanic personally, so I cannot tell you exactly. So this is our final our data set. And what will be our goals? Our goal will be to train a model first, and then try to predict if a person is going to survive or not. And our roadmap will be, obviously, first of all, we will learn how can we pre-process the data, how can we remove the outliers, how can we normalize the data, how can we do certain things. And then we will try to train the model. And when training will be done, then we will try to validate the model. And that will be it. If we are going to if we will be able to successfully implement the logistic regression in this model, in this data set, that is Titanic data set, a very famous data set, then we can conclude that yes, we're good to go. We can implement logistic regression on any data set. uh, just interestingly, I'm telling you that there are a few data sets available on open source. These sets are easily available, and these data sets are considered as benchmarks. Whenever you go for a data science job or machine learning or deep learning job, you can tell them that I have worked on Titanic data set, I have worked on a police data set, or etc. These are the famous data sets. People consider it as benchmarks. So you should be getting familiar with at least this Titanic data set. I will also mention the other data sets that are famous and important in real world. So that's all about our final project. In next lecture, we will be doing some real hardcore stuff, and we'll be discussing about pandas and numpy, and then how can we read and manipulate the data. Until then, bye. Today we are going to discuss about pandas and numpy. These two are the packages of Python that are available, and we will try to discuss what are the advantages of these packages. So let's start from numpy. So NumPy is the fundamental package for specific computing with Python. We can play around with arrays, and this NumPy package is very efficient if we are dealing with arrays. Uh, doesn't matter if these are multi-dimensional arrays. Array contains a lot of data, and NumPy is very useful, very efficient if we are dealing with arrays. How NumPy is efficient, how we can use NumPy, let's discuss it in the field. So first of all, how can we import NumPy? How can we take the first step to use NumPy? So that's how we can import any package in Python. So first of all, there is a keyword NumPy, and then the name of that package. In our case, it's NumPy, and we are going to import it as NP. You can write anything over here. And what is the advantage of importing package as something? We'll discuss about it later. So here we go. So we have successfully imported this package. In your case, this step, importing a package and then running that cell, might give you an error, because in my system NumPy is already installed. In your system, there are chances that maybe you have not installed NumPy yet. So how can you install the NumPy? I will provide the instructions below. So we have NumPy installed in our system so far, and we have imported NumPy in our program. Let me add a few more cells over here, just like before. And here we go. So first of all, very basic thing, let's say we want to generate an array of zeros, an array of 10 elements, and every element will be 0, let's say. So I will say np, this np. If you're writing np over here, you will be also writing np over here. So np dot, I'll say zeros, and here I'll say give me an array of 10 zeros. It will give us an array of 10 zeros. Now np is just a convention. If we are using numpy, we import it as np. You can write it anything over here. You can write it Michael Jackson or whatever. If you're writing, let's say, Michael Jackson over here, then you will have to say Michael Jackson dot zeros, and so on. And similar with the case, if we want to make an array of let's say ones, let's say 5 ones. Here we go. It's as simple as it looks. So what else can we do? Let's say we want to generate an array of numbers from 10 to 50, and we can do it. We have done it in Python section by using a loop, but here we can do it without using a loop as well. There is a method called arrange, and we'll say okay, arrange from 10 to 51. So it will start from 10 and it will stop before 51. So that's why we have written 51 rather than 50, and it gives us an error because we have probably written the wrong spellings. Yes, it's with single r. So here we go. You can see it's an array with elements from 10 to 50. And let's say if we want to print an array from 10 to 50 with a jump of 2, let's say we want to print only even elements in the array. So again, same method, we can just pass a third parameter from 10 to 51, and third parameter will be the jump. The jump will be 2. Here we go. You can see that 10, there is no 11 but 12, there is no 13 but 14. And if we will say take the jump of, let's say, 5, and here we go, you can see that it's as simple as it looks. It's as efficient as you can see. And then what else can we do? We can do something like numpy dot arrange. This will give us an array. Let's say we will get an array from 0 to 9. Okay, and this code will give us an array. Let's see, here we go, from 0 to 8. And then we will say okay, reshape. Fine, reshape. And in reshape we will say 3 comma 3. And here is the magic. It gives us, it reshapes the single dimensional array into these dimensions. We have said that write it in 3 into 3 dimensions. An array, a multi-dimensional array that has 3 columns and 3 rows. And what else can we do with it? Another very important concept of NumPy is random numbers. We can generate random numbers by using NumPy. So numpy dot random dot rand, and here we can pass it any value, and it will generate that much random numbers from 0 to 1. So if we will pass 5, it will generate array of 5 random numbers. And next we can do something like numpy dot random dot rand n. Now this is a little bit different from traditional random. So we'll say 5 comma 5. So it will give us an array with normal distribution. A normal distribution is a distribution in which the curve is normal, like this. Not exactly, but something like this, the bell-shaped curve. So it gives us that sort of array. And this 5 comma 5 shows that array should be 5 dimensional. 0, 1, 2, 3, 4. So 4 rows and 5 rows and 5 columns starting from 0. Okay, okay, guys. And next thing is another very efficient thing is calculations. We can perform very efficient calculations. So let's say uh, I'll store it in mat variable. Let's call it matrix or mat. Let's print it and let's add a few more cells. Okay, now let's say I want to add all these elements up. How can I do it? It looks maybe difficult. Maybe we have to use two loops for it. But if you're using NumPy, then here we go. That's it. The sum of all these elements is minus 0.057 and so on. And it's that much simple. And if we want to take its standard deviation, we can just do something like std. That's it. And finally, if we want to, let's say, we want to get the sum of this column, not whole matrix, but this column, we can say mat dot sum, and here in sum we will say x is equals to 0. X is 0 defines the column, right? So if I hit enter, sorry, if I hit control enter, you will get 5 elements. What do we mean by these 5 elements? This element corresponds to the sum of this row, sorry, this column, and this element corresponds to the sum of this column, and so on. And same the case with row addition as well. We just have to change the axis. For column we use x is equal to 0, x is equal to 0, and for rows we use x is equals to 1. Here we go. Now these elements are giving you the sum of rows. uh, Sum of this row is 2.0502 and so on. Okay, and let's do one more thing. Let's say mm, and same the case, you can add two arrays as well. You can easily add two arrays. Let's say uh, let's duplicate it, and let's call it mat1. Okay, and here I'll say mat1, sorry, here we go. Now you can see that this matrix is different from the previous one. The first element of this matrix is, you can see this one, and here is this one. So it's different. So if I'll simply say mat plus mat1, here we go. It has added two metrics. It's so easy and so handy to do it. And same the case with multiplication as well. Mat multiply by mat1. That's it. That's it. And that's the beauty of NumPy that is already available in Python. And you can implement mathematics and arrays and metrics so efficiently and so easily in Python using NumPy. In next lecture, we will try to implement pandas, which is even interesting, which is which allows you to deal with data structures. What do we mean by data structures? We'll discuss about it in next lecture. Until then, bye. Hello guys and welcome back. So today we are going to discuss one of the most important feature, or not a feature, but it's one of the most important libraries of Python that provides us a very fast and efficient access to our data. It's called pandas. So pandas contains data structures. Oh, now what is a data structure? So any data that is structured into columns and rows, just as we have discussed in previous section, it's called data structure. Now data structure can have different types that will take us into more depth. We will not discuss that here, but if we have a data structure which is rows and columns, then pandas provides us very efficient and very intuitive and above all easy way to handle them. Now, what am I talking about? Let me show you over here. So this is a file where we studied NumPy in last lecture. In this lecture, we are going to study pandas. So I'll say pandas. Okay. So first of all, first thing first, we will import pandas just as we imported NumPy. So we'll say import pandas as PD. PD is just a naming convention to import pandas. You can name it however you want. After that, let's do something new. Let's say import numpy. Now question is, numpy has already been imported, but why are we going to import it again? Because we just need numpy's one function over here, that is import numpy dot random. Sorry, we should say from numpy dot random import rand n. So we just needed one function from the whole library. So we are not going to import whole library. We are just going to import one function, one method out of this library. Let's run this cell. Now this cell again, last time I told you this, by running this cell, you might be getting an error that pandas is undefined or something, which means you have not installed pandas in your machine. How to install pandas? The link is given below, or you can read the documentation for that. Now we have pandas. What can we do? Let's say first of all, let's define a data frame. I'll say df. Df stands for data frame. You can, it's just a variable. You can name it anything you want. Then pd dot, this pd is that pd. Okay, pd dot data frame. Now data frame is a method of pd. So I'll say data frame, and first of all I will generate some random data. So I'll say rand n, just like we have done in numpy's lecture. And I need, let's say, a matrix of 5 rows and 4 columns. And then I'll say index equals to, here I'll say a b c with a space, d and e. Now what is it? I'll tell you later. Dot split. Now this index, this whole thing is going to name the rows. Index is the name of rows, and here we have to name the columns as well, and that's how you name the columns. Equals to, again, let's say whatever you want, w x y z dot split. Okay guys, now an important thing to note is, actually we have to provide the name of rows and name of columns in a list, in a form of list. So we are going to give it in a form of string, and then we will split it. We have studied the split function in our Python course. What it does is it converts the string into a list. If we don't pass any parameter, it takes empty space as a separator. So this is what is going to replace this line over here. So we have done a lot of things in one line. That's called high level programming. Okay, these are the perks of high level programming. Okay, so our data frame is ready. Let's view our data frame. We'll just say data frame and compile it. Here we go. We have 5 rows and 4 columns. Now each column shows its value, its own value, the values of feature with respect to our machine learning thing, and each row shows one record. Now what if we want to see only w's column? We'll just say df w, and that's it. You can see, you can view only, you are viewing only one column and respective number names of rows as well. And if you want to view, let's say, 2 columns, it's very simple. You just have to provide a list let's say W and Y. You will say, and that's it. You can view two columns. You can see that exactly Y is over here and W over here. Now, next thing is, what if we want to add a new column? So what if I'll say new, let's name our new column new, and I'll say a new column will be, what should be the values of new column? So let's say dfw, we'll have to guess what I'm doing, and then df uh, z. Okay, so what's going to happen? And df again, let's view. It has added a new column over here with the title new, and values of this column are the sum of w and z. Sum of this value and that value will be here, and so on. Respectively values, sum is over here, resultant sum is over here. And how can we have added a new column? How can we remove any column? So let's remove this newly added column. How can we do that? Df. Again, what is df? Df is our variable that has stored this whole data frame. Now, this is just for the sake of understanding, just for the sake of learning. In upcoming tutorials, we will be loading our exact data set that we will be using for our project. This is just for the sake of learning. So df dot, so I want to drop a column, and what's the name of column? I'll say new. And one more thing, we have to specify its axis. So axis equals to 1. We want to tell that we are going to drop a column, not a row. So 1 stands for column. So here it is. It has dropped the column, but it has temporarily dropped the column. The original data frame is still the same. It has not permanently dropped this new column. How can we permanently drop it? Just one more thing, we will copy exact lines, and we will have to pass only one more parameter, that is in place equals to true. Now it will drop this new column permanently from our data frame. So that's how you can add or remove a column. Now, how can we drop a row? How can we remove a row? So let's say we want to remove this last row whose name is E. So we'll say data frame dot drop, exactly same thing. Here the name of row, comma, and we will tell that it's a row. So axis should be equal to 0, as axes were equal to 1 for the column. For row, axis should be equal to 0. So we will run it, and you can see that last row is not showing over here. But again, the same thing, it is not permanently deleted. It's still here. So you can again use in place equals to true if you want to permanently drop it. I do not want to drop it, so I'm not going to do that. So let's move on. Let's say we have seen that how can we show a specific column. What if we want to see a specific row? Uh, we have There's a function, it's called loc or location. It's a short form of location. So it gives us a row. These are the column names, WXYZ, as you can see over here, and A is the name of row. So it is showing us a complete row. That's how you can locate a column, and you can also locate a column by its index number. So the function is iloc. I stands for index and loc stands for location, and here you can say 2. So it gives you 0, 1, 2. Tooth row over here, second row over here. Actually, the third row, since programmers counting starts from 0, so that's why it's giving you the third row. And that's all from this lecture. In next lecture, we will continue our pandas. It's really important thing to know. So there's a very important concept in pandas that is called conditional, conditional conditionals. So we will doing conditional selections. In next section there will be a very short video. So far we have seen that how can we manipulate a pandas data frame, and in next lecture we will see that how can we conditionally select our data frame, some specific values from our data frame. Until then, bye. Okay, so continuing our last lecture, and just quickly, let me show you how can we conditionally select our values from data frames. So this was our data frame, right? And what if I want to select only those rows where value of W is, let's say, greater than 0, or in other words, value of W is positive. So I'll just say data frame, and from that data frame give me those data frame values where value of W is greater than 0. So we'll run it. You can see that there is only one row, that is row number D, where value of W is -2. Uh, Other than that, all values of W are greater than 0 or positive. So here we go. You can see that D is excluded from our new data frame. That's how you can conditionally select any value. And if you do not want to select the whole data frame, you just want to, select W, you want to get the values of column of W where W is positive, you can just do the same thing that we have done before. Here we go. So it gives you 4 values, not 5 values, because one value was negative. So that's how you can conditionally select the values from your data set. And now this part is your whole data frame, and you can apply further operations on this data frame as well. One more thing, what if I just want to select these many values, not like 1, 2, 3, and 4, only these values, not whole data frame. I just want to get this chunk. So what can I do is data frame dot location, and here I'll pass 2 arrays. So one array will show the rows A and B, and second array or list will show the columns. I'll say W and let's say X. So now you can see that row A, B are these 2 rows, and W and X are these 2 columns. You can easily get that before we compile this column. It is going to give us this, it will crop this data frame for us. So let's see what it will do. Here we go. You can see this data frame is sort of in a cropped form for us. Now you can play around with data frame and its functions. It's really a fun to play with the pandas and data frames, and apart from fun, it's important as well. Now assignment for you is you have to crop these values, only these two and these two values, right from the middle of this data frame. So it's up to you. How can you do that? There are a lot of ways to do this. So that's all from pandas, guys. In next lecture, we will be proceeding toward our final project, that is manipulating and implementing logistic regression or on Titanic dataset. First of all, we will do some data pre-processing on Titanic dataset. So before that, we will be loading our Titanic dataset into pandas framework, just like we have done over here. You can see that we have just randomly populated this framework with some values, but from now to onwards we will populate this framework with some meaningful values. Those values will be the original values from our data set. So how can we do that? How can we play around our data set, and what are the further more functions and important functions of pandas, we will be learning in upcoming lectures. Until then, bye. Okay, guys, so from now to onwards, we will be studying our data set, which is, you can see over here, we have already discussed it in one of the previous lectures. So we'll not be discussing the features of this data set. We will just be importing this data set in our code. So we have already studied what are data frames and how can we convert this whole Excel file, this CSV file, into a data frame. How can we do that? So it's very difficult. So we'll say Titanic is equal to PD. Now PD is, we have already imported PD as pandas as PD over somewhere here. You can see that, import pandas as PD just for the sake of revision. And here I'll say Titanic equals to PD dot read CSV, and name of that CSV is Titanic dot CSV. So I'll hit Control Enter, and then I'll say Titanic. Show me what is Titanic. So here we go. Our most difficult work has been done in just one line. In just one line, this whole CSV file has been imported and converted into a data frame. And as we have discussed, how can we play around with our data frame over here? Exactly same things we can do with our this data set. So let's try a few things over here. So first of all, let's say Titanic. This will be a new thing for you. Dot head. This method shows you the first five records by default of your data frame, and there is another method tail that shows you the last five records. And here you can also pass the parameter if you want. If you want to see uh, more than five or less than five records, you have to specify over here. So here you can see that now it is showing 10 records from 0 to 9. So that's how you can use head method. And there's another method that is Titanic dot describe. Here we go. It describes statistically, what is the value uh, of each column. So here is a column that is passenger ID. It tells you there are 891 records of passenger IDs. Count is 891. Mean value is this. Standard deviation is that. Minimum value is 1. You can see that passenger ID starts from 1, and maximum ID is 891. That shows the count as well, and so on. You can see everything. Now the question is, there is a column name, but there is no description of name over here, because since name is not a numeric column, so it cannot be described statistically over here. There are some other methods to describe statistically things. So we will be discussing how can we convert this sort of data that is written is in English, but we want its statistical description over here. How can we do that? We will be discussing in upcoming lectures. But for now, that's how you can describe your data set. And there are several other functions as well. So let's say Titanic. Now we will do what we have already done on our dummy data set that we created with random numbers. We will do something like that, Titanic age. So it shows all the ages, right? And if I'll say, show me all the ages Titanic, all the records Titanic, where age is greater than 70. So it shows me total like five records. There are five records where age is greater than 70. So, and show me all records where age is greater than 60. Here we go. These all are the records where age is greater than 60. You can confirm it over here. Every record has age greater than 60. So what if I want to get a record where age is greater than 60, and I want all the people who have survived and their age is greater than, let's say, 50 years. So let's see how can we do that. We have to put and condition over here. So it's really simple. This is and over here Titanic, we will again do something like survived. We have to copy paste this column name over here, and we'll say survived equal to 1. So 1 means passenger has survived, 0 means passenger hasn't survived. So I'm going to fetch all the records where ages are greater than 50 and survival is equal to 1, which means survival is yes. So let's run it. Here we go. So these are the records where you can see that survived is 111 and ages are at least greater than 50. So these people uh, had survived in Titanic, whose ages were greater than 50, and you can also get its count by doing something. Fetch any column name. If you can do something like len, so this is a short way to get its length. So there are 22 records, total 22 records. So what if I want to do something like I want to get the average or mean of the ages of people who survived, uh, and their ages were greater than 50. So I'll fetch all the age columns. Right now, in this query, I have all the ages, I have all the people, all the records whose ages are greater than 50 and they survived. And then I will fetch their ages, but I should be doing this in a separate cell. So I'll say age. So fetch all the ages and then uh, give me its sum. So it is 1264. The sum is 1264. And what if I want to fetch its average? So I'll say mean. So the mean is 57.45. And what if I just want to know how many people have survived and what is overall average age. So I'll say Titanic, and that's how I can fetch all the records where survival is equal to 1. It's an easy way. And then I'll fetch its age column, and finally I'll say mean. Here we go. So the overall average is 28, and who survived actually, and the average for over 50 people who survived is 57. Now, what if I want to know what is average fare? There's a column for fare as well. Here we go. This is the column for fare. Now, what if I want to know what is the average fare of people who had class P? So P class, passenger class, is 1. And what was the average fare for people who had who had P class is equal to 2? But how can I do that? Actually, I cannot do that. This is up for you people to try and do. How can you do that? It's totally up to you. There's another very uh, important method is, we'll say Titanic dot um, is null. Oh, sorry. Here I'll have to pass a column name. So I'll say age dot is null. Again, it's giving me subject has no attribute is null. So let's see how can we do that. So yes, there is a typo. We should do it something like that. So what it does is it tells you where are the values. The value for age is null. What do I mean by that? If we display our set over somewhere over here. So let's add a cell over here, and I'll say Titanic dot head show me first 7 records, And here you can see the value for age is NaN, which means not a number, which means a value for age is not available at record number row number 5, which is actually the row number 6, uh, if we start from index 0. So here you can see that the value for row number 5 is true when we have run is null. It tells you that the there are these many values where value for age is not available. So how can we replace these value, and what can we do with that? This will be discussed in upcoming lectures, from where we will be starting the data pre-processing part. And our next part is to study some data visualization tools, then data cleaning tools, data cleaning that involves removing outliers, filling or removing missing values, and finally categorical to numeric conversion. So in upcoming lectures, we will be studying this whole thing is called data pre-processing, and we will be studying it. Until then, bye. So we are going to start data visualization right now, which will be followed by data cleaning. There are a lot of tools available in Python that allows us data visualization. For example, one of them is matplotlib. Other than that, we have Seaborn, we have Plotly, and the number of libraries. For the sake of introduction, we will just be studying matplotlib. So what is a matplotlib? Matplotlib is actually a data visualization library that allows us 2D data plotting. We can use it in Python scripts and Jupyter Notebook and IPython shells and etc. It makes data visualization very easy. It allows us to generate and you visualize the data by using plots or histograms and power separate spectra and bar charts and etc etc. Scatter plot is also a very important and a very common data visualization example. And we can do it by just writing a few lines of code that I will show you right now. So first of all, first thing first, which is import mat sorry matplotlib dot pyplot as plt, and then let's compile it. And here now for plotting something, we have to have something on y-axis and the other thing on x-axis. So first of all, let's say y equals to we already have this Titanic dataset that we have been playing with in last lecture as well. So I'll say Titanic. So I'll just be writing the code and you will have to guess what it will return us. Titanic, and from here I'll say survived is equal to 1. So what it will return us, any idea? It will return all the records where survived equals to 1, or in other words, record of all people who survived. So there is a new thing that is group by, and here I'll say sex. It will group by group the whole data on the attribute of sex, and here we'll just have to pass any column name so that we can fetch the record of one column. For the sake of simplicity, we will say name, and then we will say count, and let's see what it does. And let's see what is y. So we have to pass, we have to do something like this, and here we go. It is telling us, though there are 233 females who survived and there are 109 male who survived. So this is a statistical description. What if we want it in a plot? So I'll say something like x equals to First of all, we have females, so I'll say females, comma, males. And finally, I'll say PLT. What is PLT? PLT is just the alias of matplotlib. So I'll say PLT dot bar. I want to produce a bar graph, and I have to pass X and Y to it. So I'll run it, and here we go. You can see the females were 233 and it is approaching almost 233, and males were 109, and you can see that it is very close to 100. And these are labels over here. Now this is a proper data visualization, but we should be adding a title to it as well. So there's a plot functionality that says title, and we will say, what should we say? We'll say survival with respect to gender. Okay, let's run it again, and here we go. You can see that there's a beautiful title for this graph, survival with respect to gender, and it shows a graph. So that's how it's really just like 3 lines of code, and a beautiful graph is over here that is, visualizing the data for us. And visualization is always better than the statistical description. So sometimes you need to visualize the data, and where we'll have to omit the outliers out of the data, probably 2 or 3 lectures after this lecture. Data visualization will be playing a vital role there. How it will be playing its role, we will discuss there. So let's play a little bit more with it, and let's just copy and paste it over here so that we can work fastly. Now we are not discriminating it with respect to sex. We will be saying, okay, group it by P class, and here, since it has 3 P classes, so I'll say class 1, and here I'll say class 2, and here I'll say class 3, and X and Y will be same, and it is with respect to class. So let's run it and let's see. So it has drawn three graphs for us. As you can see in our data, there were P classes, which is passenger class. Some passengers were in class 1, some were in class 2, and others were in class 3. So as you know that even in planes, we have classes, business class and economy class and etc. So these are exactly that. So there are those people who survived. There are almost 130 or something people, one who survived, and they belong to class 1, and there are almost 80 or something people who survived, and they belong to class 2. Now we can infer that it can be wrong, but one of the hypotheses can be uh, people from class 2 survived less than the other 2 classes. Maybe the reason is class 2 was at somewhere in Titanic where survival was difficult or something. It may be a stupid theory, but by visualizing the data, you can draw hypothesis as well. So that's how you discriminate your data, or you visually visualize your data. Let's play a little bit more with our data, and just one more example, and then I will give you an assignment for you to be done, and if you will be able to done it, fine, otherwise I'll do it for you just like before. So one more example. So now we want to categorize that how many children who survived and how many elders who survived, or adults who survived. So let's say, how should we do that? So here I'll say we have to copy and paste this code just for the sake of speed. So survival equals to this, and group it by, we should not group it. We should do something like where survival equals to 1, and let's get rid of this. Here we'll say survival equals to 1, and here is and Titanic. I think we should be doing it from scratch for the sake of cleanliness. So let's say child's, I'll define child as Titanic, where Titanic um, survived is equal to 1, and I should be writing it in parentheses so that I can write and condition over here, and Titanic age is less than equal to 12. This should also be in parentheses. Let's run it and let's see what child's gives us. So it gives us this record. So if I'll do something like count, it gives us the whole value. And for the sake of consistency, I'll say name just like before, and then I'll count it. And let's see what is in child's. See a child's right now. So it says there were 40 childs, and if I'll copy and paste it over here, I'll say now I have to count adults, and adults were those where ages were greater than 12. Okay, and let's run it and let's see what do we have in adults. So we have total 250 adults who actually survived. So we have to do something like, so our y-axis, y is equal to, first of all, childs, then adults, and rest of the thing is exactly similar. We just have to copy and paste the code over here. We do not have classes right now. We have adults and childs, so I'll say adults, and here I'll say childs, and it is plotting a bar graph, and it is survival with respect to, let's say, age. Let's run it, and here we go. You can see that total almost 40 childs who survived, and almost 250 adults who survived. So you can visualize this data. But we had the new thing was we had to define what is child and what is adult. So we just took a hypothesis where we said child is the one who has age equal to or less than 12, and adult is the one who has age greater than 12. This number is arguable, but that's how we do it. Now the assignment for you is, you have to plot a graph where you have to tell me, or you have to visualize that how many people were died with respect to the singles and families. I mean, how many people on the Titanic were single who died, and how many people had families on the Titanic who died. For the sake of help, let me tell you, we have this column where it tells you that the sibling or spouse number, and this tells you parent or child number. These two columns can be helpful for you in order to complete the assignment. So in next lecture, that will be a very short video. I will just be completing this assignment, but I am really expecting you to complete this little assignment for me. Until then, bye. So we have to complete our assignment that we have discussed in last lecture. So we are going to display the number of singles who died and the number of people who were with families on the with the families on the Titanic who died. So I'll say singles equals to, first of all, we have to fetch the number of singles out of our data set. So I'll say Titanic. Let me copy this line for me, not for you. So I'll say something like this. And okay, so where survival equals to 0, because we want to we have to get the number of we have to get the people who actually died. So that's how we do that. And here we'll say sibling or spouse is equal to 0. So who doesn't have any sibling or spouse on the Titanic. And then we will just copy and paste it over here, and we will say we have to check parent and child as well. So we'll say PARCH, and we are done. Let's run it. It is giving us error. It says okay, it says it's a wrong column name. So where's the column names? So yes, it's PAR. I'll copy and I will paste it over here. Okay, let's run it. It's running fine. Let's see how many singles. Okay, so there were 374 people who were I mean who don't have had families on the Titanic. They might be having families who were not on the Titanic, but they doesn't had anyone on Titanic at that moment. So it means that. So let me again explain what I'm doing. I'm getting all the people who couldn't survive, unfortunately, and who had zero sibling or spouse on the Titanic, and who had zero parent or child on the Titanic. And then I'll say, okay, give me people who were with families. So let's not fetch the whole record. Let's do something new. So I'll say Titanic, the name dot count minus singles. Right now, we already have a single count, so I will minus that single count out of the whole population. That will obviously return me the people with families as well. So let's run it and let's see how many people. So there were total 517 people who were with families on the Titanic. Now now rest of the thing is exactly what we have already done, and let's do it again. Nothing different. So let's not define y. Let's exactly uh, write single and fam. Let's not write x. Let's hard code it with. First of all, we are displaying singles, and then we will display fami families. Perfect. So we have to say died with respect to, what should I say? Let's say families. Let's run it, and here we go. You can see that people who were single and died, the amount of people is this much, and the people who were single and were with families is that much. So this was the solution of our assignment. And with that, we are done with data visualization. You can play around with it. We have just done the bar plots. You can play around with scatter plots and something like that. By the way, scatter plots will be discussed in later on in upcoming lectures as well. So for now, we are done with it. And after that, we will be discussing the outliers removal and filling or removing the missing values and the conversion of categorical values to numeric values. All of these terminologies comes under the umbrella of data cleaning. So, in short, we will be doing data cleaning from next lecture. Bye. Okay, guys. So, in order to study data cleaning, that consists of three parts, as we discussed in last lecture. Our first step in order to clean our data is to remove or eliminate the missing values. We can eliminate the missing values by we have two options in order to eliminate the missing values. One is we can delete the complete row where some of the data is missing, or we can manually fill in or impute the missing values. There are some uh, intuitive methods, uh, some good and better methods that allows us to fill the data into the missing values. Both of the options have its own pros and cons. For example, if we will delete all the records where data is missing, our ultimately data set will be very reduced. And if we will manually fill in the data, so there are chances we will fill in the incorrect or inconsistent data into our data set. So we have to choose very carefully whether we should remove, we should delete the row, or we should manually fill in the data. Let's go to our Jupyter notebook, the brand new notebook, where we will just be doing data cleaning. Let me write over here data cleaning. And first of all, we will be dealing with missing values. And first thing first, which is import a few libraries. So I'll say numpy as np and pandas as pd. Let me zoom in this screen for you so that you can read it out easily. Let me compile it and add a few more cells over here. So first of all, let's read our data set, and Titanic equals to pd dot read underscore csv, and here we'll say Titanic dot csv, but it should be in string format. So it says pf is nothing. It's right, it's pd. So we have our Titanic data set. Let's see, Titanic dot head. We have used this method, so let's use this one, tail. That gives us the last few records. So let's see. We can see that the age is nan, which is not a number, which means age is not available over here for record number 8888. So there might be a lot of records where age will be missing. Let's see our original data set. This is the age column, and there might be a lot of uh, places where age is missing. Let's see how many rows are there where age is missing. So let's say Titanic, and we are talking about age. There's a method, it's called is null. We have already used it in one of the previous lectures. So if we will run it, it will return true wherever it will not find it, or it will find null, I mean not a number, in place of this age column. You can see that there is 27 over here, so it will say false. There is 19 over here, so it will say false. There is nan over here, so it will say true. So we will say, okay, give me some, that how many rows are there where age is NN. So it says there are 177 rows over here where the value is not available, and there are total 891 records in our data set. So what should we do over here? If we will remove 177 records out of it, our data set will become very brief or short. So we would not like to remove these rows. Otherwise we will just remove this whole row. because the information is missing over here. So this is one of the methods. The other method is we can impute a value over here. Now the question is, what value should be imputed over here, or what value should be replaced by nn? By nn should be replaced by what value over here? The answer is we can replace it with a few values. Let's see how can we do that. So I will say Titanic, and here I'll say age dot fill na. It's a built-in method for pandas, and it will allow us filling the na values. Na means not available values. And how can we fill it? I'll say Titanic, Titanic of age. Let me do this thing separately so that it will become easier for you to read. So I'll do something like this. So I'll say mean. Okay, so here I'm taking the mean of the whole column, or I can also do something like median. Okay, and there's other thing we call it mode. So these are a few things that can that can help us replacing this value. So I think mean value that has floating points, and the age is normally not in the floating points. So I think median is fine. Median is actually, if we will sort our all the available numbers, then it will pick the middle one. So 28 is that number, and 28 is not far away from 29. So I think median will be a better option. So I'm going to pick it up, and I'm going to remove all these cells. Okay, so I'm going to fill na with median, and I'm going to say in place equals to true. I hope you know that. What does it mean? It means that we are permanently changing our data set. So let's run it, and let's see how our data set looks like now. Titanic dot tail. Here we go. You can see that there was a record number 888, and the value for age is nn. So record number 28, sorry, 888 is now the value for age is 28 over here. So it's been replaced by the median of this column. So that's how you can replace the values. And there is another method. If you want to remove the values, so you can say Titanic for age. We have used fill na method, right? You can use drop na method if you want to delete the records rather than imputing or replacing the records with other values. So that's how you can do that. You can use it for your homework, but I'm not going to do that over here. So let's just make a litmus test over here. So let's see how many null values are available right now. So it says 0. There is no null value available in our data set. So let's write this data set. This is another new thing for you. Up till now, we have just been reading the data set, and our data set is in Titanic variable right now, in the form of data frame. So how can we write this updated data frame? In this data frame, the age column is updated. So how can we write it in a CSV format? So let's do this difficult task. So I'll say Titanic dot to CSV, and here I'll provide its name. Let's say missing values replaced. Okay, and dot CSV. And one more thing, we should be saying index equals to false. The reason is, uh, it is already containing indexing, and at least in my operating system, uh, the CSV file you can see over here, it has its own indexing conventions. So if I'll be writing these indexes as well, so there will be two columns for indexing, and I do not want that. You can by default it's true, it writes its own indexing on CSV file, but I do not want that. That's why I've set it equal to false. So let me run it for you, and now my this file has been written on my drive, and in next lecture we will be reading this file again, and we will start working on exactly this file. So until next lecture, and by the way, in next lecture we will be what we will be doing, let's see what we have to do. We will be removing the outliers. So we are done with the filling or removing the missing values, and in next lecture we will be uh, you know dealing with the outliers. Until then, bye. Okay, guys. So let's start the second part of data cleaning, which is removal of outliers. Now, what is an outlier? We have already discussed in previous lectures that what is an outlier. Outlier can be a measurement error or a data entry error or anything. For example, if we talk about our data, we know that age of human being cannot exceed 100 years nowadays, or at max it can go to 200 years or something. So I have manually imputed some outliers into it, where age is 512, 546, 1020, and so on. So I have manually added a few outliers into our data, so that we can know how to remove, and first of all how to detect the outlier, and then how to remove an outlier. So um, uh, first of all, we can do it by manually correct the outlier if possible. We can look for the outlier into our whole data, and okay, if this is an outlier I can remove it, replace it. Okay, and if this is an outlier I can replace it. It's a donkey work. We have only 8 or 900 records over here. uh, some of the data sets consist of millions of records, so it is really pathetic, or sort of donkey work to manually look for the outlier and then remove it. So let's find a better, easy, and fast way to detect and remove the outlier. So we are doing what? We are removing outliers. Okay. So first of all, let's read the data set that we uh, wrote last time, and let's say read it in again. Titanic equals to pd dot read csv, and here I'll copy and paste the name of file and say .csv. Let's run it, and let's say Titanic dot tail. Here we go. The ages are uh, way above than the normal ages of normal people. So how can we remove it? The answer is data visualization tool can play a very important role over here. So first of all, we have to import the library. Library should be imported at very first cell. So I'll say import matplotlib dot pyplot as plt. Run it, and here we will be visualizing the data, and we'll say plt dot show me a histogram graph, and here I'll say Titanic dot age. with a capital, and let's see, here we go. So it is showing us that most of the records are from let's say 0, a little bit before 0, after 0 to almost 100. We can see all the records are there, but very little, if you can see that, very little, very few records are over here, here, and here. Now these are the outliers. We do not need that in our data set. We can do again two things with that. We can remove them or we can replace them, just like we have done in last lecture. We have replaced in the last lecture. So what can we do over here? We have already done the replacement of data. In this lecture we will be doing the removal of data. So first of all, how can we do something that we will only get these records, these tall bar records, and we should neglect these outliers from our data. How can we do that? It's really easy, very easy peasy squeezy. And how can we do that? So let's say after um, removal, and I'll say simple, we have done it before, Titanic, and in Titanic give me all the records where age is less than 100. Okay, so here I can see that these are less than 100, so I'll run it. By the way, we should do something like Titanic dot. So we have 900 records over here, including the outliers. So we have fetched only those records where age is less than 100. Let's run this cell, and then let's see how many records we are left with after the removal of outliers. Okay, so we have got 891 records. So all the outliers that we imputed into our data set manually are removed now. You can see that. So by date, now where this 100 comes from, by visualizing the data, I can easily see that, okay, all the records are sort of less than 100. I can even put 200 over here. Because I can see that the 200 is the limit. If there might be the case, if 400 is the normal value, you can write 400 over here as well. But 100 is normally the maximum age for a human being on the planet nowadays. So we've got data after removal, and let's see its head. Okay, and let's see its tail as well. So it's fine, neat and clean now. So what should we do now? The only thing left is we should plot its histogram and see if it's fine or not. So plot dot histogram, and what is the data distribution right now? Okay, there's an error which says, okay, we should do something like this, plot its age graph. Here we go. You can see that it starts from a little bit after than 0, and then it rises at almost 20 to 30 or 20 to 40. Most of the people were between 20 to 40, and then all the maximum age was almost 80. So outliers have been removed now. What should we do? After removal of outliers, we should again save our data set. So how do we save it? After removal dot to CSV, and what should be the name? Let's name it after removal dot CSV. Let's compile it, and this file has been saved. Let me show you over here. Sorry, where it is. Let's find it. So it is saved over here. Yeah, here we go. So this is the file after removal that has been saved. So we are done with removing outliers as well. The final thing left is conversion of categorical data into numeric data. The final thing in data cleaning, the only step is left. So we will be getting done with this step in next lecture. I hope you have understood the concept of removing the outliers and removing or filling out the missing values. The final thing is uh, conversion of categorical variables. So until then, bye. So the final step is going to be taken, which is conversion of categorical variables to numerical values. As we know that machine cannot understand English or French or any other language. So we have to convert those values that are in English to numeric values. So how can we do that? Let's see if in our data set there is any such value. So if we go on the top, we can see that sex contains male or female and so on. So our machine wouldn't understand what is male and what is female. So we can do, but our machine can understand what is 22, 38, 26, and so on. Our model, which is a mathematical formula actually, it can easily understand what is this, but it cannot understand what is that. So we can do something like, let's replace male with 1 and female with 0. We can do something like this. And this is what we call conversion of categorical values to numeric values. And this is exactly what we are going to do. As you can see that we have to do that over here and over here and over a few more columns as well. So let's go back to the coding environment. Let's see. So what we are going to do is conversion from categorical to numeric values. By the way, this will be the last step of data cleaning. After that, we will exactly be doing logistic regression. And let me tell you, we will be implementing complete logistic regression in just a few minutes. Let's say maybe less than 10 minutes. We will do that. It's that much easy. But this data pre-processing and data cleaning step was very important, and it's really time-taking step. By the way, we have this name. I don't like this name. Let's replace it. It's not expressing enough. So let's write it like after removal, uh, after removal outliers. Okay. And here, first thing first, let's read our data set. Titanic equals to, which is exactly this data set, but just for the sake of learning, I'm going to read it again. pd dot read underscore CSV, and here we are going to paste this file's name dot CSV. Run it, and Titanic dot head. Let's see. Here we go. Oh, by the way, since I haven't written index equal to false over here, so you can see that the indexing, the serial number is duplicating. So please let me do it over here. I'll say index equals to false. Run it. Run this again, and tan, it's gone. Let me add a few more cells over here, and let's begin the war. So first of all, uh, there is a method available in pandas that says get dummies. So I'll say pd. I hope you know what is pd. pd is an alias for pandas. pd dot get dummies, and in this get dummies I'll pass Titanic, and we had to remove this column that says sex. So I'll write sex over here. And here we go. You can see that it has generated two columns, one for female and the other one for male. And what is it doing actually? It says 0 where female, where the value for the column is not female. It says 1 where the value for the column is female, and same the thing is with male. If you can compare this with our original data set. The first column says male, sorry, the first row says male, and the male is 1, the female is 0. Second and third and fourth row says female, so you can see that female is 1 and male is 0 over here. So that's how we replace our categorical values to numeric values. And it's really that much easy. But we are not done yet. We have to replace these values in our data set, and we have to remove this column, this sex column, from here, and this sex column should be replaced by these sort of numeric values. So how can we do that? Let's do that over here. And let's write one one statement first that says pd dot get dummies, and here Titanic, I'll say sex, get dummies of sex. And one more thing is that I should be telling you, there is another another parameter available for this, which is prefix. Now what it does, I'll tell you. You can see that it has added a prefix to the name of columns. And why we are doing that? If we are creating a lot of dummies in our data set or in our data frame, so prefix should be there that tells you that it is dummy of that variable or it is dummy of that column. So that's why we are adding we usually add prefix when we are dummyifying the data or we are converting the categorical values to numeric values. So prefix equals to, I'll say, sex. And in next line, let me copy this line, paste it over here. And the next value that I want to replace is embarrassed. Okay, I hope spelling the right, but even then, I'm going to copy this. As you can see that these are also English values, the English letters, so we are going to replace them. I'll write embarrassed over here and embarrassed over here as well. The next thing is, sorry, copy, paste. The next thing is P class. So I'll say P class over here and P class, and over here also P class. Same thing we have done over and over again. So the dummies for sex will be stored in this variable, dummies for embarrassed will be stored in this variable, and dummies for P class will be stored in this variable. Now we let's run this cell and let's see what does this variable contain. Here we go. You can see that P class underscore 1, P class underscore 2, and P class underscore 3, and so on. And now we have to concatenate all these newly born variables into our original data frame. So how can we do that? Let's say new Titanic is equals to pd, again pandas, dot concat. Concat is a short form of concatenation. So it will concatenate what? It will concatenate, first of all, Titanic. We have to pass the complete list of elements. So the second element is sex, this element. And then long spellings, I'm not going to take risk. I'm just going to copy and paste it over here. And finally, p class. So it will concatenate them. And I also have to mention that I am talking about columns. X is equals to 1. So let's run it and let's see how our new Titanic looks like. It must be horrible because we have not deleted the old variables. Here we go. You can see um, the newly added elements are over here. Sex female, sex male, embedded C, embedded Q, S, and P class 1, P class 2, P class 3. And that's how we do it. Now, what should we do? As we can see that um, passenger ID, excuse me, passenger ID is useless for us because it will not be helpful for us. You know, IDs are just numbers for passengers. It will not. It is usually not helpful in order to fetch the information if passenger is survived or not. So we will delete this column. We will keep this column. The most important column is this one. We will delete this p class as well because we already have its dummies over here. You can see that. So we will delete that. Otherwise, data will be duplicating. Name is not also very important, and sex will also be deleted because we have its dummies over here. So let's get rid of the the extra data. So I'll say new Titanic dot drop. Here we will pass the list of columns that we have to drop. So I'll say passenger ID, and then we have to drop p class, then name, then sex, and what else? Embedded is also been replaced. So let me copy this and paste it over here. And ticket is also not required. Ticket. So what else? Cabin. Cabin should also not be there. Okay, so we are dropping these columns and these are the columns. So I'll say x is equals to 1. And one more thing, let's take care of indentation. One more thing is in place equals to what? True, because we want them to be deleted permanently. By the way, guys, those who are not understanding that why we are deleting only these columns and why we are keeping the other columns, for those who are thinking like this, the answer is it's a proper engineering sort of thing, that which features we should keep and which features we should not keep. It's a proper separate topic that will take a lot of time. So we are not going to discuss that over here, but we can easily observe that by using our common sense that a name will not be playing any role in order to predict the survival of uh, any passenger, or passenger ID will not be playing any important role. But maybe the gender or age will be playing important role, because maybe rescue teams will be rescuing children and old age people first and then the younger ones. So that's how usually the features affect the data. So we are going to remove them, and then let's see how our data looks like. Dot head. Here we go. Now you can see that this is nice, beautiful, clean data. Maybe it's not looking beautiful because it is not containing the English letters. You know, we human understand English letters, but this is, let me tell you, believe me, this is beautiful data for our machine learning algorithm. This is beautiful data for our machine. So there is no English letter over here. There is no categorical variable over here, a categorical value over here. So guys, we are done with the um, conversion of categorical values to numeric values, and this is our final data set. So I want to write it so that we can use it in next lecture, uh, where we will be implementing a logistic regression. in very few minutes, in a hurry, I'll say. So I'll say new Titanic dot to CSV. What should I say? I'm saying final data set dot CSV, and one thing is index equals to false. Okay, guys, that's all about data cleaning. I'm going to write it over here, over my screen. Oh, sorry, my drive, and we will be using this data set in next lecture. So that's all about data cleaning. We have studied the three important steps of data cleaning. There might be more steps as well, but these are very basic and integral data. The steps to clean the data: removal of outliers, filling or removing the missing values, and finally the conversion of categorical values to numeric values. After these steps, our data will probably be ready for machine learning algorithm. In next lecture, we will be doing a very quick implementation of logistic regression, and then we will be done with logistic regression. So hold on up till next lecture, where we will be doing the actual implementation. Until then, bye. Welcome back, guys. So today we will be very quickly implementing the logistic regression, and you'll see how easy and how handy its implementation is. So let's go back to our coding environment and let's say quick implementation of logistic regression. Okay, so first thing first, which is let's import a few libraries. Let's say pandas as pd as usual, and a new thing is sklearn. So from sklearn dot model selection import train test split, and then from sklearn dot linear model import logistic regression, and finally we are going to import from matrices. We need something that will get us the accuracy score. So let's import all of these, and these are imported. Then let's add a few cells. Now let me tell you what we are doing with it. So train test split will split our data into training data set and testing data set, just like as we have discussed in previous section. Logistic regression will provide us the model that will train our logistic regression. And finally, accuracy score will tell us how accurate our model is. So first of all, let's say Titanic is equal to pd dot read underscore CSV. And if you remember, in last lecture, we saved our final data set with final underscore data set dot CSV. Let's run it and let's see how our Titanic looks like. Dot head. Oops. Oh, so I wrote 0 by mistake. So here it is. Survived is our class or our target column, and all these columns are the feature columns. So our data set is ready. There is no missing value over here. There is no outlier over here. We've made sure, and there is no categorical value over here. So what we are going to do right now is we are saying that x, usually in machine learning, x refers to the features. So we will say Titanic dot drop survived. Now the question is, why we are going to drop this main column, that is our target column, survived. Anyone has got an answer? And x is equals to 1. So it's going to drop this column, but it will not drop this column permanently from Titanic because in place is not true. So it will store all these feature and its values in x, that is what we want, and in y we want to store only Titanic. We just want to store survived. Perfect. So that's it. X is ready, Y is ready, and now we are going to apply the train test split. Here we go, that we have just imported over here. Now we are going to pass our X, our features, and then our target values, corresponding target values, and then there is a parameter. It's called test underscore size, which should be equal to 0.2 or 0.3. Now what is it? If we will, it will split our data such that the size of test data will be 30% and size of training data will be remaining 70%. If this will be 0.2, then the size of testing data will be 20% and the size of training data will be 80%. Now, there is no rule of thumb, but generally people follow a 20-80 test split. So we are going with that, and it will return us 4 values. The first value will be x, x train, the features of training set, and second value will be x test, the features of test set, and then it will return us y train, and then finally y test. Perfect. Let's run it. It has been compiled. Now we will feed our model this training features and its corresponding labels, x train and y train. Y corresponds to target class and x corresponds to features. So we will feed our model with these two sets, these two data frames, and then finally, when our model will be trained, then we will test our model by using these features, and we will hide these X tests, the labels of these test features. We will hide these labels, and these labels will be finally used for the validation, or we call it accuracy score. So I'll say logistic model is equal to logistic regression that we have just imported from sklearn. The whole implementation is available there in sklearn's .linear model, and that's how we do it. And finally, I'll say logistic model dot fit, and here I'll pass x train and y train. Let's run it, and it has run successfully. It gave us a few, it gave us a response. Let's not read it right now. It will not be very useful. And the final thing that we are very much interested into is predictions. But let me tell you what has happened up till now. It has trained the model over the features of trainings, provided that we gave the features of training to our model and the labels of training to our model. And now we are going to get the predictions. So I'll say logistic model that we have trained. You can see that, and I'll just pass the features of test set. Okay, now those guys who are a little bit confused that what is training set and what is test set and what is X and what is Y, let me again repeat. X are features, X corresponds to features, and Y corresponds to label or class or target. Now, what is training set and what is testing set? I have explained it in previous section where I gave you to the introduction of machine learning. We had a discussion in detail that what is the difference between train set and test set and why do we split our data set. So we're passing the features of test set to our model and it will return us some predictions. Then we will match these predictions with our labels, y test. So that because we have not shown our y test or the labels of test set to our model, we have not shown it to our model yet. So we are getting the predictions and it has given us an error. It says um, object is not callable. Okay, let's see what the error is. So the reason is I've made a blunder. I haven't called the prediction function. So I'll say predict. Okay, so now it will run and let's see what is in the predictions. Here we go. It has returned us the labels, the one for the survival true, zero for the survival false, one if the passenger is going to survive, zero for the if passenger is not going to survive. And let's see how accurate our model is. I'll say accuracy score that we have just imported, and we will pass we will pass y test that we got from this train test split. We'll pass this and predictions to our accuracy score, and accuracy score is 82%. So it gives us in points, so we that's how we can convert it in percentage. So accuracy score is 82%, which is quite good. We have just implemented our model in let's say in 10 minutes, and it's giving us an accuracy of 82%. And that's how you implement any logistic regression model, and that's how you get score. Now, one more thing that I want to do is let's say let's see what is an X test. Copy, let's paste it over here. Dot head. So it is a complete data frame, and I will just get its first record like this. Here we go. We've got one record, and I will pass this record to prediction model, and I'll say 0 to 1. Okay, now it will return me its label or its target value. So it says 1, so this person is going to survive. And what if I'll say from 2 to 3, it says 0, so this person where record is 2 to 3 is not going to survive. So that's how we get the predictions from our model, and that's how we validate or we find the accuracy of our model. uh, it says that if we will throw 100 if we will ask 100 questions to our model, it will be accurately able to answer 82 questions, and it will make error on 18 questions probably. So that's how, guys, that's how handy it is to implement the logistic regression by using sklearn. Now the question is that it, or is it over? The answer is no. We have not come so far just to implement a built-in sklearn's model that just does the binary classification. So what we are going to do next? So we are curious enough. If you're not curious enough, you just wanted to know how we can implement logistic regression, you're done over here. But if you're curious enough that what is going actually behind the scenes of this implementation, what is happening in sklearns when it run this dot fit method, where it is here we go. What happens actually when it runs this dot fit method? What happens when it runs dot predict method? How it works? If you're curious enough to know, then wait. We've got a complete series for upcoming that is available in upcoming lectures, where we will be implementing logistic regression from scratch, that will give you the proper idea what is happening behind the scenes, what is happening behind the implementation of sklearn's logistic regression model. So I hope you guys will follow me along. You'll not leave me over here. So from next lecture, some mathematical terminologies will be discussed that works behind the scenes of logistic regression model, and then we'll also be implementing in Jupyter Notebook as well. Up till then, bye. So far, we are done with the sklearn's implementation of logistic regression, and you are good to go. You can implement that sklearn's implementation on any data set, on any data set. Now you know how to pre-process the data, and you can implement logistic regression on any data set. But still, if you are here in this video and you want to know the details, that what is happening behind the scenes of logistic regression, believe me, I'm really honored and I welcome you with my open arms. So let's discuss what is happening actually behind the scenes of logistic regression. As we have discussed that logistic regression is used for binary classification. Even if we want to do multi-class classification rather than binary classification, the concept of binary classification will be used in multi-class classification as well. So we will just be focusing on binary class classification, and by the end of this section, there will be a video where I'll be explaining you how logistic regression implements multi-class classification using binary class classification. So let's start. And again, we are taking the example of binary classification. For example, spam or not spam. For example, tumor, malignant or not malignant. And the Titanic dataset that we have been using, that if specific person is going to survive or not. These are the examples that we are looking forward to. So for the sake of example, let's draw a graph, and somehow, let's say somehow, we have learned a boundary that is something like this. Okay, somehow. And how we have learned this boundary, we will discuss it. But for now, somehow we have learned this decision boundary after the sorry, not decision boundary. We have learned this model after the training. So and let's say this sort of this line has following properties. Um, Line has the following equation that says mx plus c. And for the time being, let's say value of m is -2, sorry, -2, and value for c is let's say 6. Value for x is the value that will come over here on x-axis. Okay, so now we have learned the boundary. We know how our line looks like. It has m equals to -2 and c equals to 6. Now, if any data point comes into our set for prediction, let's say a point come over here comes for prediction that x is equal to, let's say, 2. So now it's just basic mathematics, and it will give us some number that says it will become -4 plus 6. It will become 2. Okay. Now it has given us answer 2, and if the value for x is let's say 10, then answer will be 10 multiplied by -2 is -20 plus 6. This will become -14. Okay, so now we have predicted our output on the basis of two values, 2 and 10. For 10 we got answer -14. For 2 we got answer 2. Now how can we predict that if this belongs to label 1 or 0, and this belongs to label 1 or 0, because these are the continuous values, and we're really not able to predict that how can we specifically output some value that it belongs to label 1 or it belongs to label 2. These are the continuous values. So that's where the need of logistic regression comes. So there is a function that looks like, let me show you. Let's say this is the graph. So there is a function that looks like S, looks like S shape. No, it's it's really not nice. So it's something like that. Okay, so this is 0, and this is 1. This is 0. Okay, and let me draw this line over here. Okay, so there is a function, it's called sigmoid, that has a curve like S shape. So if we will feed a value to this curve, this function, let's not discuss the actual value of this function, the actual formula of this function, we will discuss it later. But right now, let's say we have a function, we will feed any value to this function, and let's say this is f of x, and if we will feed any value for x, it will output either 0 or 1. Now, how it does it do that? The formula for our sigmoid is 1 over 1 plus exponential of x. Now, if the value for x is too high, it will output 1, and if the value for x is too low or negative, it will output 0. So it ultimately maps the output, this continuous value, onto binary labels, either 1 or 0. This is not 10, by the way. Either 1 or 0. So the problem was we were getting the continuous values out of our model. So we didn't know that how to model them, how to impute them, how to convert them into our label, which was 1 or 0. So we that's how we do it. But we have to define some sort of value over here, that if the input will come into this function, this sigmoid function, we call it sigmoid function, then if input will be greater than 0.5, let's say this is 0.5, if input is greater than 0.5, then we will say, okay, our label is 1. If input is less than 0.5, then we will say, okay, our label is 0. Now, the question is where this 0.5 comes from. We will discuss it later. And this is a very important number. It's called decision boundary. And this is a hyperparameter. We have discussed what is a hyperparameter. Hyperparameter is a number that is to be decided by the programmer, the user according to the need. And we will see in upcoming lectures, we will set 0.5 decision boundary for one data set, and it will be working perfectly fine. And we will set 0.5 exactly same decision boundary for another data set, and it will not be working fine. Then we will be fine tuning the decision boundary. Now, question is, what is the decision boundary? Let me get rid of this stuff and let's move forward. And before decision boundary, let's discuss what is sigmoid function. As we have discussed it in a very short time, let's discuss it again. So a sigmoid function is a mathematical function. It's just a mathematical function, and its curve is like S shape, as I drew in the last lecture. And sigmoid function is also called logistic function. That's why actually this is something, this sigmoid function makes it logistic regression, because sigmoid function is also called logistic function as well. If we are using if we are using any function other than sigmoid function to convert our continuous output into the binary label, then it will not be logistic regression. It will be something else, but it will not be logistic regression. If we are using sigmoid function only, then it will be logistic regression. There are pros and cons for of sigmoid function of using sigmoid function and other functions as well, and we're not discussing that right now. So it has a curve like this. Okay, so this is 0.5. Usually people take 0.5 as a decision boundary. So that's how our sigmoid function looks like. Now let's discuss about the decision boundary, or should we discuss it in next lecture? I think we should discuss decision boundary next lecture. But before that, this is the formula that I wrote with my pen in a very poor form. Here you can see it in a neat form, that 1 over 1 plus exponential raised to power minus z. Now this z can be any value. It can be x, it can be a feature or something. So that's all about sigmoid, guys. I hope you have understood the concept of logistic function or sigmoid function and how it works and why do we use sigmoid function. So without sigmoid function, logistic regression will be regression. It will not be a classifier. It will be giving us continuous values. By using sigmoid function, it will become the classifier, as we've discussed in very first lecture, that we are going to develop a classifier. So in next video, we will try to learn what is decision boundary. Until then, bye. So let's discuss what is decision boundary and how we can choose the perfect value for our decision boundary. What are some rules to choose the decision boundary? Normally, people choose 0.5 as decision boundary. Sometimes it's fine, but sometimes we have to manipulate it. So let's discuss it. Let's say for the sake of example, we are classifying the crosses and circles, and we have sort of this line that is a classifier that tells us that uh, if it's a cross or if it's a circle. In order to classify the cross or circle, we have to have two x's because it's a 2D plane. So we have to have x1 and x2. So we have x1 over here and x2 over here. Theta 0, theta 1, and theta 2 comes out of the model. Now, how can we learn these thetas? Actually, learning these thetas is actually what we call machine learning. And how do we learn thetas in logistic regression? I'll tell you later when we will be discussing the gradient descent. For now, let's say we already know value for theta 0 is let's say 1. Value for theta 1 is, let's say, -5, and value for theta 2 is let's say 10. Okay, so here we go. Now let's say there is another point comes, and that point has the axis x1 equals to 2, that is x-axis, and x2 equals to again 2. Now, so its x-axis and y-axis are 2 and 2 respectively. So if we will calculate this equation, it will become 20 minus 10 plus 1, it will become probably 11. So now we don't know if 11 belongs to this class, or if 11 belongs to these circle class or this cross class. So how do we know that? So we will put this 11, we will throw this 11 into our sigmoid function 1 plus e of minus x. Now this sigmoid function will output any value from 0 to 1. And for now, we are taking 0.5 as decision boundary. So let's say our model will, our sigmoid function, this sigmoid function will output a value like 0.2 as a result. We will put 11 as x into this function and it will output 0.2. So we can compare if 0.2 is greater than 0.5, then it belongs to class 1, but it's certainly wrong. And if 0.2 is less than 0.5, then it belongs to class 0, which is certainly right. So ultimately, it belongs to class 0. somewhere over here, 2 2. Okay, this 2 and this 2, sort of. Okay, so and what if our classifier, our decision boundary, uh, let's say our decision boundary is 0 0.1 rather than 0 0.5. Let's say it's 0 0.1. Okay, now if we will say 0 0.2 is greater than 0 0.1, yes, so it belongs to class 1. So this circle will be belonging to class 1. So this will not be a circle, this will be a cross. So that's how our decision boundary can affect our decision making of the model. Now, how to select this number? There is no rule of thumb to select this number. This number can be this number can vary with respect to data sets. And you will see later on, we will be working with two data sets later on, and you will see that we will be working with different values. So this is a hyperparameter that you will have to tune. You will have to engineer it. You will have to put a lot of values for this decision boundary, and then you will see what is the best outcome, what is the lowest error, where is the lowest error. So wherever there is the lowest error, that decision boundary will be finalized. Just for the sake of example, let me tell you. Let's say if you are you're predicting uh, if someone has cancer or not. You can you have a leverage to say if someone doesn't have a cancer, but you can still say you have a cancer. So if that person will go for further medical test, it will be diagnosed that he doesn't have a cancer, so it's almost fine. It's not that much dangerous. But if someone has a cancer, so if someone has a cancer and you will say no, you're fine, you do not have a cancer, so that person will say, okay, I'm fine. He will go home, he will live a life, and then that cancer will go up to the dangerous stages that we call level 1, level 2, or level 3, that is not curable generally. So your wrong prediction here will be affecting a life. So there are chances, there you have chances somewhere that you can make wrong predictions, as I said earlier. And there are chances, there are situations where you cannot make wrong prediction at all. So in that case, we manipulate this boundary. We will say, okay, so let's say if these crosses says you have a cancer, and this zero says you do not have a cancer, then we will say, okay, our boundary will be somewhere close to this, like this. Somewhere it will not be 0 0.5, it will be very less than 0 0.5, so that I will not tell a cancer patient that you do not have a cancer. I hope this prevails the sense, and I hope you understand the importance of decision boundary and how to choose the decision boundary, how to choose the better decision boundary. The only thing left is how to choose thetas. It will be discussed when we'll be coding live. uh, so far, we are just discussing a few concepts. Just one or two concepts are left, and then we will go to our coding environment, and then we will be implementing everything live. One more thing that is left is cost functions. And what is a cost function? We have already studied what is cost in machine learning, and what are the cost functions, and what is the cost function that we will be using in logistic regression. We will discuss it in next lecture. Until then, bye. So the cost function is something that tells us how wrong we are doing, how wrong our model is performing. So we want to define a cost function for our data that tells us that, okay, your model is that much wrong. So how can we predict our how can we define a cost function in logistic regression? Every model has almost its own cost function. The most important feature for the cost function is it should penalize the model. It should penalize the model if the prediction is wrong, and it should do nothing if prediction is right. So it is the, the characteristic of cost function. You should choose cost function for a model that has these two properties, the following two properties. It should penalize at the maximum level the wrong prediction, and it should do nothing if prediction is right. So here is the cost function that we use for logistic regression, and let me define it let me briefly define it, how it works. So if our output is 1, if y equals to 1 and it's wrong, so our model should be, it should penalize it. It should give us a very higher value. So if log of 1, what is the minus log of 1? It's 0. So if prediction is y equals to 1, which is a prediction, so if it's right, then it will say okay 0. But if it's wrong, then it will come over here, 1 minus 1 equals to 0, and minus log of 0 is infinity. So it will penalize it. Same the case goes for 0. If 1 minus 0, which will be 1, and minus log of 1 is 0, but if it will be wrong, then it will go up to this level, and minus log of 0 is again infinity. So it will penalize it a lot. Infinity is the maximum level of penalization. So that's how you find the cost of your model, and that's how we write it mathematically. If you do not understand it, that's totally fine, but it's just a mathematical formula in mathematical form. We will be implementing it in our coding environment as well, so you will see how handy, how easy it is to implement it. Let's get rid of this. And after that, we have only one topic left. And after this discussion of this gradient descent, we will be moving toward our coding environment, and we will be implementing everything on Jupyter Notebook. Until then, bye. So our final topic before going into the coding environment is gradient descent. Now we will be discussing the difference between global minima and local minima, and how can we achieve the global minima by using gradient descent in logistic regression. So before in logistic regression, I was right. So uh, before going into what is gradient descent and how we use it to achieve global minima, before that, let's discuss what is the difference between global minima and local minima. And after that, we will be implementing our project in Python. So first of all, what is global versus local minima? Let's say we have a graph like, let's say like this. Okay, this is a graph that has high and low values in it, and this is, let's say, x and y axis. Now here we can see that if we will start from here, you can see that this is a minimum value. But if we will move forward, we will find even more minimum value. If we will move forward, we will again find the maximum, the value which is minimum out of all the values. And then we will move forward, we'll find more values that will be minimum, that will be at lower sides of curves, but it will not be the most minimum values. So the point is, the value in the graph that is at very minimum level, like this, these are called global minima. And all the values that are at this level, these are called local minimas. So these are the local minimas. Now why are we discussing these minimas over here? When we will calculate the cost function, what is the goal actually? What is our goal? Let's say our cost function makes a curve like this on our given data set. So we will need to find this point where the value for cost function is minimum, is absolutely minimum. we need to find this point. Why do we need to find this point? Because those parameters for what the value of our curve is minimum, those parameter will become our what? They will become our thetas. Now you remember thetas? Let me take you to a few slides back, and here we go. I told you that this is what actually we call machine learning. These thetas, where these thetas come from? These thetas come from this. Um, Here we go. These thetas come from this gradient descent thing. Now, what is a gradient descent? Let's move forward and discuss gradient descent in a bit. How can we achieve global minima rather than local minima by using logistic regression? We will start at any point. Let's take that drawing back. We will start from any random point over here, and we will be let's say we are, for now we are over here. Okay, we will calculate the derivation over here. Derivation is a pure mathematical term. We will not go into the details. Do not worry if you don't understand. So the derivation will tell you that if you have to go upward or downward. So we will be going in the opposite direction of derivation. So if derivation will say go upward, we will go in the negative direction of derivative. So we will go downward here. And here we will again calculate the derivative. It will say go upward, we will again go downward, and so on. And ultimately we will achieve our global minima. Now question is, if we will reach over here, right here, our derivative will give us value 0, because both of the sides have the higher side of curve, and this is sort of for the derivative, this will be the minima. So derivative will not go anywhere from here. This is what we call the problems of local minima. But fortunately, the function for the cost function that we have studied for logistic regression is convex function. Now, what is a convex function? Convex function is a function that makes this bowl sort of curve that doesn't have any local minima. It only has the global minima. Okay, so if we will start let's say we will start from here, we will ultimately be reaching, by taking some steps, we'll be reaching the global minima over here. So wherever the value for derivative is equal to 0, that will be our local minima. Now, how long this step should be, this will be decided by learning rate. Here you can see that it is also a hyperparameter that will have to be decided by us. And finally, when we will reach the global minima, the parameters where this global minima lies, that will become our thetas. That will become our theta 0 and theta 1 and so on. And these thetas depends on the number of features. Let's say we have n number of features, then the number of thetas will be n plus 1. This 1 theta is extra over here. So that's all about the details, the theoretical part of logistic regression, guys. And believe me, we are done with theoretical part. And in next lecture, we will be starting implementation of logistic regression from scratch, totally from scratch, without taking any help from sklearn. We will be implementing what is exactly happening in sklearn's model of logistic regression. So I hope you're excited. I hope you've studied at least, you have got at least 20% of theoretical part. Remaining 80% of theoretical part will be made clear in Jupyter Notebook, and you'll be having some ambiguities that will be made very clear in next part, because we will be implementing everything that we have discussed in exactly same manner by using Python. So until next lecture, bye. Welcome back, guys. So now we are going to implement logistic regression, implementing logistic regression from scratch. We'll be doing everything by ourselves. And first of all, let's import pandas as PD so that we can easily read our dataset. Then import matplotlib dot pyplot as plt, and finally import numpy as np. Some people also call it numpy and a few people call it numpy. Both are fine. So let's run it, and libraries are being imported. Now, now we will be doing everything in functions. We will not be doing everything in just one script. Will be Everything will be done in a structural format from now to onwards. So first of all, we will define a function that will read data, and in this function we'll say pd dot read underscore csv. And what is the name of csv? Name of csv is this random data. So I'll say random data dot csv. So we'll store it in, let's say, data frame, and here we will do something like return data frame dot to numpy. Now, why we are converting it into NumPy? Because we will not be doing everything on data frames. From now to onwards, we will be manipulating arrays. Manipulation of array is much faster than the manipulation of data frames. That's why we are converting it into an array of NumPy. We have not used NumPy a lot, so NumPy will be used a lot right now. So that's why we have learned it before. So this function will return us an array of our data. Let's run it. There is an error. It says invalid syntax. Okay, so that's how we define a function. And here I'll say, let's say data set equals to read data. And let's call it, and let's see how our data set looks like. Data set. This is our data set. Let's go to the Excel file. Now this is our data set. It contains some x-axis and some y-axis and their labels. It's just a dummy data so that we can easily visualize what we are doing in logistic regression. So this data has been read, and now we should not be doing data pre-processing steps over here because there is no missing value, there is no outlier, there's no nothing. So we will straightforwardly going into the hardcore thing. But one thing that we missed out in data pre-processing, that is called data normalization. We have not done that. So let's do that right now. Now, what do we mean by data normalization? I'll explain it. So I'll say normalize. And here I'll say data. I'll pass data into it. It will say minimums equals to numpy dot min of data, and I'm talking about rows. X is 0 equals to rows. So what this normalize will be doing, it will be normalizing all the features. It will be scaling these features from 0 0 to 1 so that their impact will not be changed, but they will become a uniform format so that we can easily implement our model onto it. So first of all, we'll find the minimums, then we will find the maximums. Exactly almost the same thing. So I'll say max and data, and x's should be 0. Here indentation, perfect. And then I'll say range, sorry, RNG. Range is a keyword, that's why we're using RNG as maximums minus minimums. And then I'll say normalized data is equals to 1 minus, it's just a mathematical formula. So if you don't understand, do not worry about it. So we'll say maximums minus data divided by, sorry, the whole divided by RNG. And finally, we'll say return normalized data. Okay, I think we're right. Let's run it and let's see what do we get in x. So x equals to normalize, and we'll pass data set into it. And it says normalize is not defined. Okay, maybe there's a typo. Yes, there is a typo. So let's run it again, and it's giving us another error. It says normalize again. There must be a typo. So copy again. We have missed R over here. So let's run it again. Then this. Here we go. So our data has been normalized. Let's see how our data looks like now. Here we go. Now you can see that every element has been scaled from 0 to 1, but the impact of element will remain the same. So that's how we do it. And it's really a good approach, a good data pre-processing approach in order to implement any model on your data. So that's how we do it. And now let's see how our data looks like. Let's do some visualization things, and let's plot our data. So I'll say define visualize, and here I'll say data. Here, let's say x. We'll be passing x and y separately. We do not need to pass y right now, so let's play with x only. So I'll say x0 equals to x, and here I'll put a condition that numpy where y equals to 1. Now what is y? We have to define y as well. Actually, it should be equal to 0.0. Now what is y? We should be passing y from here so that it can easily distinguish. Now normally what is x and what is y? You should know that. X are the features, and y are the labels or target or whatever you want to call it, or classes is also another synonym for that. So I'll say let's call it normalized. Okay, and let's copy and paste it over here, and from normalized I'll copy I'll copy all the rows apart from last column, all the rows and columns apart from last column. I hope you understand what's happening. And then y equals to, again, normalized, and here we will just be copying the last column. So how do we do it? All the columns, all the rows and last column. I think we have made a mistake over here, because yes, we should be doing something like this. Yeah, so it seems fine. Yes, so let's see. Y contains what? Y contains all the labels, and X contains what? X contains all the features. Perfect. So one more thing, that we should do, it's a convention, we should append one more column over here, like one more column before this, that should say 1111 for all the entries of this data set. So how can we do it? It's not a difficult thing to do. So I'll say x equals to numpy 8 numpy dot 8 stack, and here I'll say pass a numpy matrix. Will be write a very generalized code, so we'll not be hard coding anything. So I'll say numpy dot ones, an array of ones, and what should be its length? Its length should be x dot shape, and here we'll say 0. And any guess what's happening over here? Then we'll say take its transpose and then x. Let's run it. It says at stack takes one argument, and okay, sorry, I've done something wrong over here, probably. Again, it's an error. Let's see. So yes, we have missed a bracket over here. Over here. Let's run it and it's fine. Let's see how x looks like right now. Here we go. You can see that ones are over here, and then the features, and then we have also y as well. So we'll be taking x and y in data visualization, and we'll copy paste. So this will contain all the x's where x equals to 0, and this will contain all the x's where x equals to 1. Now what else? We want to plot this data, and we want to plot a scatter plot. I told you in one of the lectures that we'll be plotting the scatter plot as well. Now scatter plot is one of the types of plot where data visualization becomes very handy and very explanatory. So I'll say x underscore 0 of all the rows and first column, comma, then x underscore 0 all the rows and second column, and then color should be blue, and another parameter can be the label, and label will be y equals to 0. Perfect. And then we will just copy and paste, and we'll just have to change the labels. So I'll say 1, and its color should be red, and it should be x1. Here it will also be x1, and that's it. Then I'll say plt dot show. Let's see how it looks like. And then the most important thing is we have to call it visualize x and y. Here we go. You can see that how our data looks like. So we have two classes. One is blue class, other is red class, and that's how our data looks like. So from right now we can see that there may be some decision boundary like this that will ultimately classify them. And by the end of this session, when we will be done with implementation of logistic regression, you will see that we will ultimately find a boundary that will exactly be like this. So hold on, and we will continue this lecture from right now, from right here, and we will be continuing developing our own logistic regression. So far we are done with data reading, we are done with data normalization, and we are done with data visualization. In next lecture we will be actually implementing the logistic regression. So far we have done some sort of pre-processing stuff. Until then, bye. before continuing, let's make our graph a little bit more beautiful. By the way, what's happening over here? We are drawing two scatter plots. One scatter plot for the blue labels and the other scatter plot for the y labels. First of all, we separated these y equals to 0 label and y equals to 1 labels, and then we drew them separately. So now let's distinguish them by giving them some sort of labels. So I'll say plt dot x label, and here I'll say x1, and plt dot y label, here I'll say x2. And then I'll say plt, you'll see the magic right now, LET, yeah. So plt dot legend, and that's it. Let's run it. Let's visualize the data again, and here we go. You can see that so it is now telling us the y equals to 0 are blue and y equals to 1 are red. So, and this is x1 and this is x2, or these are the x-axis and these are the y-axis. In our data, if you can see that this is x1 and this is x2, that's why we have given the labels like x1 and x2. I hope you followed me a lot and along. You followed me along, and you have understood what has happened yet. In this lecture, in this video, we will not be doing a lot. We will just be writing our own logistic function that we have studied yet, and that is define logistic function. Now, what will be the parameters of this function? So parameters will be theta, thetas, and x. Now, what are the thetas? If you have followed a few lectures back, if you go a few lectures back, we have studied that there were something like written something like this: theta 0 plus theta 1, and then x1, and then theta 2, and then x2, something like that. Okay, let me do. Okay, it looks so beautiful. So now what are these thetas? This is exactly those thetas, and where these thetas will come from, the gradient descent we have discussed in theoretical part, and we will be doing it practically over here as well, not in this video, but somewhere in the videos. So we'll say return. By the way, what is our logistic function? If you remember, so it was 1 over 1 plus exponential of minus z, where z was the dot product of, where z equals to the thetas, all the thetas, dot product of thetas, and this is, let's say, dot, and the features. So exactly, we will be implementing exactly this thing in just one line. So I'll say return 1.0, just to be sure, just to be, cater the floating values as well. So 1 divided by 1 plus, now where this exponential comes from, numpy, np dot exp, which means exponential, and we'll say negative of numpy dot product, this numpy dot dot will take the dot product of features, and we'll say thetas dot transpose. So thetas will be in a row form. We will have to make them in a column form, so that we can take the dot product. So that's how it is. That's how our logistic function, and some people also call it, let me write it over here. Some people also call it sigmoid. So both are the synonyms, both are fine. You can call it whatever you want. This is what actually logistic regression, this is what makes different logistic regression from other classification models. That's it. that is logistic regression function. Let's run it to be sure that there is no syntax error, and it is running. So far we are done with data visualization, data pre-processing, data loading, and the definition of logistic function. In next lecture, we will be doing two things. One, we'll be writing the gradient descent function, and second will be writing the cost function and maybe a few helper functions as well. That's all from this video. Until then, bye. Okay, guys, we have already studied the theoretical part of cost functions and what should be the characteristic of a good cost function and why do we use it. We have already studied it in theoretical part. Uh, this was the cost function of logistic regression, and let's implement this cost function in our coding environment. So let's say define cost, and in cost I'll say thetas. It will be needing thetas so that it can find the cost uh, for those thetas, and what are the features and what are the labels. And then here we'll do something like log func equals to, actually we'll say log function value equals to that logistic function that we have just written, and here we will pass thetas and x. So it will give us some value, some logistic value, and then we will subtract the, no, we will not subtract, actually we will move forward, and step one will be what should we say, let's say step one. Okay, step one will be y. Exactly, we are doing exactly this thing. So exactly this thing, these two things. So step one will be y multiply by the product of y with the numpy dot log of log func value. Okay, so we'll be taking the log of actually whatever will be the answer of this function. As you can see that we are taking the negative, forget negative for now, we will add negative later. So for now we're just taking the log of it with the product of y, and then we will say step 2 equals to 1 minus y. Indentation should be followed properly, and then numpy dot log 1 minus log func value, and that's it. Now the final step is to return what? Return minus step 1 minus step 2. So so if we will talk about this, so this was our step 1, and this was our step 2, and we have added minus signs later. And let's go back to the environment, and here you can see that. And finally we are returning some cost over here. By the way, this will be a string, this will be an array, a complete array. So we have to return one value. So the array can consist of values like 100, or let's say 5, 5, 2, and so on. So what value should be returned? The better answer is, it is arguable, but the better answer is we should be returning its mean value. So I'll say numpy dot mean, and that's it. This is our cost function. This is our whole cost function. Whatever theory we have studied over here, that's it. So let's compile it. just to know that there is no compilation error, and yes, there is no syntax error. So let me remove this from here. Okay, so it was the implementation of our cost function. We are done with our logistic function that has not been used yet. It will be used in next lecture. We have implemented our cost function that has not been used yet, and it will also be used in next lecture when we will be implementing our most important feature, that is gradient descent. We do not know what are the thetas. We just know we have x, we have y, but thetas are not, we do not have thetas yet. So where these thetas will come from? These thetas will come from one and only gradient descent. So let's write its definition. So I'll say gradient descent, and I'm not going to pass anything. I'm just going to pass it. If you do not want to write the details of function, you can just write pass in order to avoid any error. So I'm leaving it for the next lecture. In next lecture, we will be using this cost function and logistic function, both functions, in this gradient descent. And this gradient descent will finally give us these thetas, and these thetas will be used in, then finally there will be a function return predict, and thetas will be used in the predictions. So I'm also writing pass over here. So in next lecture we will be writing the details of gradient descent, and then we'll be writing the details of predict function. Until then, bye. We are going to implement gradient descent in this lecture. Just for the sake of revision, let's revise what was the gradient descent. So so let's say we have a convex function like this, a convex cost function like this. So we will be initializing thetas with some random value. Let's say we are initializing thetas over here. We will be calculating um the derivative, and derivative will tell us where to go, where is the steep, where is the minima lies. So in the first step is to take derivative, and then second step is to take actually the step. So then we will take a step, and then at this place we will repeat same thing again. We will calculate the derivative, we will again take a step, we will again take a derivative, again we will take a step. So ultimately when we will reach somewhere over here, let's take it blue, over here, the step will be 0 because there is no further minima from this point. So here the step will be 0, and then we will stop our loop. We will stop going further downwards because we cannot go further downwards from the global minima. So first of all, let's define the parameters of gradient descent, and the parameters are, of course, x, y, and thetas. Now again, what are the thetas? For now, we'll assume that thetas, not assume, actually thetas are just some random numbers, and we will generate these random numbers from our main call. And then I'll say learning rate. Learning rate will be the step that will be taking in the direction of global minima, and this will be finally we'll say convergence criteria. Now we will let's say okay, we will pass it from the main function. So let's say this is our gradient descent function, and in gradient descent function, first of all we will calculate the cost, and cost will be the cost function. Actually we should rename this function because it will confuse us. So I'll say cost func. Okay, and let me see if I have called it anywhere else. No. So okay, I'll say cost is equal to cost func, and here I'll pass thetas, then it needs x and y as well. After that, I'll say I'll just initialize another variable that is called change, which will be, let's say, let's initialize it any number, let's say 1. And then I'll calculate the number of iterations. So I'll say iter count. I'll just return this number. This is not necessary to count, but I'm just counting it so that I know how many steps it has taken in order to reach the global minima. So I'll say initialize it with 1, and then there will be a while loop. We have studied it in Python course, and here I'll say run something while change is greater than the convergence criteria. Okay, now this change has been initialized with 1. Convergence criteria will surely be some value less than 1 less than 1 in the beginning. And we will keep updating the change, and whenever change will be, let's say for now, for the sake of simplicity, I'll say convergence criteria is 0.001. So whenever the change will become equal to this or less than that, this loop will break. So what is going to happen inside the loop? So I'll say old cost equals to the cost that we have just calculated by using our cost function. And then I'll say thetas equals to, we are going to update our thetas. How we are going to update our thetas? There's a formula. So I'll say thetas minus learning rate. Actually, I should write it something like this. So learning rate into log of. Now here we will have to write the derivative. And what is derivative? We have not defined it yet. So let's define it over here. It's a pure mathematical function, so we do not have to go into its details. I'm just going to paste it over here for you. Just know that this function will take some parameters and it will return the gradient. It will tell us you have to go in that direction. So I'll take the log of log gradient. Actually, I'll have to say log gradient, and then I'll pass thetas x and y to it, so that it will tell us you'll have to go in that direction. We'll go in that direction with that much step in this direction, which is opposite direction, and thetas will be updated. Okay. By the way, I'm repeating that thetas are initialized randomly, so it can be anywhere. It can be anywhere, but it will ultimately comes to the global minima. And then I'll say cost. I'll update the cost, and cost equals to our cost function. Cost function. And now we are going to pass this updated thetas into it. So I'll say thetas and x and y will be the old ones. Then it will again calculate the cost with the updated thetas. It will return the cost, and we will update something. We will update change, and change will be the old cost minus the new cost or the cost. And finally, we will do something like a number of iterations. What is the name of variable? It's iter count. So it will be plus equals to 1. By the way, again, I'm repeating, this variable is not very important. I'm just writing it over here so that I could ultimately return this variable iter count, so that I could know how many steps it has taken to converge, or how many steps it has taken to reach the global minima. So up till now, I have two things: the number of steps it has taken, and one more thing, the important thing, which is thetas. Now these thetas will be those thetas that are at global minima, that are at sort of this level. Okay, So let's say it has started from here. It converged and converged and converged, and then goes, and then it comes over here. Now the value of thetas over here is very important. That's I'm going to return. So the value of thetas at this global minima is that value that will give me the minimum error, because the cost is minimum over here. So our gradient descent function is exactly ready. Let's just compile it. And yes, it has been compiled, so there is no error. And this predict function, in next lecture we will write the details of this function as well. But for now, let's test our gradient descent function. We have used the cost function in gradient descent and logistic function as well in gradient descent. So, and we have also defined this log gradient, that is also called the derivative in mathematics. So let's test our gradient descent. Let's pass all these values to our gradient descent, and let's see what thetas are we going to get. So let's add a more cell. No, let's do something over here. Okay, so how can we call it? First of all, we have to define a few variables. That is learning rate that we should pass. Let's say for now it is 0.01, and convergence criteria has already been hard coded over here. But let's remove it from here. I wrote it here just for your understanding. It's not a good practice. It should be written over here, so it will be 0.001. Now what should be the convergence criteria? What should be the learning rate? We will discuss it later. We will surely discuss it, and these are very important values, and we will discuss it later. So now here I'll say I'll have to initialize thetas as well. So I'll say thetas equals to numpy dot matrix, and I'll initialize it with zeros. So numpy dot zeros. How many zeros? So zeros will be how much? X dot shape of rows or column, shape of columns. So thetas will be the number of shape of columns. And from here to onwards, what we will be doing is, so let's our thetas are ready. Thetas are nothing but just an array of zeros. I told you that we have to initialize it with some random numbers, so let's take 0 for that. And here we are going to call the gradient descent function, and let's copy it from here, and let's paste it from over, sorry, not from, let's paste it over our main function. Let me write that this is our main function. Okay, not a function but main cell. Perfect. So this is gradient descent, the name of the function, and it takes x is already defined. It takes y already defined. It takes thetas are arranged. Learning rate is 0.01, and convergence criteria is 0.001. Now, as you know that thetas are are been initialized with zeros, and we are passing thetas into it, and from here thetas are been updated, thetas are been returned, and number of iterations are also been returned. So we have to store it somewhere. So I'll say final final thetas, and the second is um, iteration counts. Okay, so I'm going to receive these values into the following variables, and then I'm going to print them. Okay, perfect. So let me run it, and here you can see these are the values for thetas, this and that. Since we had two columns of x You can see over here 1 and 2. In third column, we added over here that says 1 1 1 for every row. So that's why three values are there, 1, 2, and 3, and it took 2,607 iterations in order to reach the global minima. So so that's all about the gradient descent. Up till now, what we have done, let's take a brief summary. And actually, let me tell you guys, we are done with logistic regression. That's it. Implementation of gradient descent what is logistic regression. Now we will just have to predict and validate that how accurate our model is. So let's take a summary. First of all, we wrote a function that reads data set, then we normalized the data set, then we visualized the data set. We saw how our data set looks like over here, and then we defined our sigmoid function or logistic function. Then we wrote a cost function, and then this is just a function that takes the derivative and returns the value. It's an empty cell. I have to delete it. I've done it. It was difficult, but I've done it. So gradient descent, we wrote this function gradient descent, which is the heart of logistic regression. What is happening over here? We are just iterating over, and so there are actually two types of conditions that people usually follow. One is we will run this loop until it doesn't converge. Second is we will run this loop for specific number of iterations. Both of the things have its own pros and cons, but we are going with that. You can also play around with it. We are updating the thetas, and we are counting the number of iterations, and we are returning the thetas, the updated thetas and number of iterations. And here in our main cell, we are just printing them out. That's about it. That's it, guys. We have got these thetas, these this machine learning thing. We have got that. Now we just need to predict that how our model is performing on this data set. Our model is almost been trained. These thetas tells us that our model is trained. Now we will just be predicting how better our model is being trained. So until next lecture, where we will be probably there will be our final lecture of implementation of logistic regression. We'll just be doing the predictions. How can we predict uh, by using our own code? Until then, bye. Okay, guys, so let's write the predict function, and let's see what it takes. So it takes thetas and x, and here I'll say prob or probability. So my logistic function will give me the probability. So I'll say thetas, and then I'll pass x. So it will return me some value from 0 to 1, some floating point value. And then I'll say predicted value is numpy dot where we're going to write a sort of if else statement but in one line. So you will see the prob. So if prob is greater than equal to 0.5, then return 1, otherwise return 0. So what it will do, it is sort of if else statement. So if this is true, if probability 0 is greater than or equal to 0.5, it will return 1, otherwise it will return 0. And finally we will return exactly this predicted value. And since this will be a 2D array, so I'll have to convert it into 1D array. So I'll say numpy dot squeeze, yeah, and that's it. Guys, if you have paid attention, this is a familiar number. This is where we implement our Decision boundary. So I'll say Decision boundary. If we go back to our lectures, here we have learned that how to how can we calculate this decision boundary number. For now, it's 0 0.5. There will be a data set that will come later, uh, and we will be implementing another boundary over there. And we have already discussed that what should be the decision boundary and what should be the scenarios that you'll have to change the decision boundary. For now, since our data is very simple, so we will stick with 0 0.5. Let's compile it and let's see how can we predict our values. Um, I'll say y predict. Okay, so these are the predicted y's. Y's stands for labels. So I'll say predict. I'll pass thetas, thetas, and x to it, and it will return me some predicted some y predictions. So I'll print these y right over here, and you can see that okay, so it is returning me only once. It is not returning me, it has never returned me 0. uh, if you look into our data, there are almost equal ones and then equal zeros over here. So why it is doing this? Any idea, guys? We are passing thetas to it rather than final thetas. Final thetas that we got from gradient descent. What is the difference between thetas and final thetas? Thetas are just an array that has been initialized with zeros. Final thetas are the updated weights that we got from gradient descent. So we should be passing final thetas rather than thetas. And here we go, let's see. So yes, it's predicting almost fine. And let's see how many predictions were correct. So I'll say print correct corrects equals to here I'll say numpy dot sum, and then let's say y were our original labels, and I'll compare them with our predicted labels. So okay, 98 labels were correct, and how many labels were total? Let's see. By the way, let me do something like this. Let me cut this from here. Let's say corrects equals to this, and total equals to y underscore underscore len underscore this. So I'll say corrects, and here I'll say total number is total, and here I'll say the accuracy. We will calculate the accuracy. How can we do that? So corrects, by the way, spelling of correct is not correct. I think it's CO. I'm not sure. I'm very bad at spellings. So corrects divided by total multiplied by 100. That's how we calculate the percentage. And we have got an error. It says y underscore underscore len is not defined. It's right. We have missed dot over here. Let's run it again, and you can see that total were 98, corrects were 98, and accuracy, hence accuracy is 100%. Since our data set was so simple that it doesn't made any error. So you can see that if data set is so simple, our model is performing so well on it. Now we should visualize that how our line looks like over here. Our thetas have, our model. Before the beginning, I told you we will fix a line something like this over here, and let's see how our line looks like now. So in data visualization, that visualize function that we wrote, We will also pass the final thetas, and let's go to its definition. Here it is. So I'll say visualize. I'll have to pass thetas over here as well. So thetas, and then uh, what should we do? We should write something like, okay, let's write it over here. Mm, how can we plot it? Let's say x1 equals to numpy dot arrange from 0 to 1 with the difference of 0.1, and then x2, which will be our y-axis, it should be equals to minus, it's just mathematics. So thetas of 0 and 0 plus thetas of 0 and 1 multiply by x1 and divided by thetas of 0 comma 2. So that's how you can draw a line over there, but we have not we have just defined x and y axis. We have not plotted yet, so I'll say plt dot plot and x1 comma x2. Let's make it a little bit beautiful by adding some colors into it. So I'll say color is, let's say, k, and that's it. Let's run it. Let's add a label to it as well so that we will know what it is. Label is equals to regression line. Perfect. So let's compile it. Let's go back to the function call, and it gives us an error. It says numpy has no attribute arrange. Again, a typo is here. It should be 1R. Let's go back. Let's run it again. Another error. Now it says array used indices. Okay, so this. Okay, I got it. Now let me tell you what is a blunder. Guys, let me show you. This is a blunder. Okay, what have I done? I don't know. What's happening? I don't know. So let's cut and paste it over here. I hope you understand. Okay, it happens sometimes. So let's again compile it, and I hope it will not give me an error now. Oh, thank God. So here we go. You can see that this is our regression line that is, beautifully classifies red dots from blue dots. That's all, guys. That's really all. This model is giving us 100% accuracy. This is all. Let's have a very quick review what we have done in it, and then I will assign you an assignment that is supposed to be done by you. So let's see what we have done over here. We have made a structure of logistic regression. This is sort of code that is written behind the scenes of logistic regression code of sklearn. So importing libraries, reading the data, normalizing the data, pre-processing thing, then visualization, and then the hardcore stuff starts. We have defined a sigmoid or logistic function, then the cost function we have defined over here. We have studied the theory of it already, and then the a function that returns us the derivative. Finally, the gradient descent, the heart of logistic regression implemented, and then a prediction function. In our main cell, we are reading the data set, then normalizing it, then initializing the learning rate, the step size. It is also called the step size. Then convergence criteria, usually convergence criteria is this one. It can be low, it can be high, depends on the data set. Then we are not appending one with X, you know, a column of 1 with X on extreme left side. Then we are distinguishing features with labels, and then we are just randomly initializing the theta. Finally, the gradient descent, running the gradient descent gives us theta and iterations. And then we have thetas, we have original labels, we have X, which is the feature. We are good to go. So we went for prediction, and prediction tells us we have predicted all the labels correctly. So in our data set, we had 2 features and 1 label. So these features were x-axis and y-axis, and we are done. This is our final line over here. Now, assignment for you. We have done this for this data set. This is, I don't know how can we call it even a data set. It's a rough sort of data set. Now your assignment is to implement exactly this sort of logistic regression on Titanic dataset. We have already done all pre-processing stuff on Titanic dataset. You just have to make a very few changes into that dataset, and exactly this code will be running for you guys. So you have to see where you'll have to make the change. One change that you'll have to make is the first change. Let me tell you, you'll have to read a different dataset. Okay, I know it's quite obvious, but that's all I can tell you right now. I don't know how can we manipulate that Titanic dataset. How can we fix that Titanic dataset into this structure of logistic regression? I hope you will at least try this. At least try this. Give it a try. Give it some time. Try to understand this code. You have any questions? Put your questions in the comment section. If you understand this code, then the playing with any data set is not difficult for you. So I hope you will get done with Titanic data set by yourself. Otherwise, in next lecture I will do that for you. Do not worry at all. Okay, guys. So this is our Titanic dataset that was cleaned. I know you're wondering that it doesn't look like that because I have removed its columns. We do not need that over here, and I have shifted this survived column, our label column, from top left, from extreme left to extreme right. That's it. Otherwise, it's exactly that dataset. You can match it. That we've worked with. It is exactly that dataset that we implemented in sklearn's implementation of logistic regression. Now we are going to use this dataset in our own implemented logistic regression code. So it was supposed to be done by you. You just had to make I guess 3 changes in our code, and that's it. So first change is, first of all, you'll have to read the right file, which is Titanic dataset.csv. And then what you'll have to do is, what you'll have to do? You'll have to do absolutely nothing. That's it. You'll just have to read another file. And our code is so generic that it will exactly work for that. So let's run it from first cell like this, tick, 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 and here we go. So this is our final cell. Let's run it. It has given us an error. It says what? It says file doesn't exist. Okay, again. So there's a typo. It is a data set. Let's do it again. Tick, 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 tick. And let's see. Here we go. You can see that it has run, and correct predictions are 552. Total number of the tries that we did is 890, and hence accuracy is 62%, which is not a very good accuracy. So how can we improve this? Now here comes the game of decision boundary. This thing, a decision boundary is way too high that it doesn't consider the zeros, because the number of survivals and number of dead people in our data set has a lot of difference. So one of the features of a good data set is it has equal number of records for each class, but in our case it is not the case. So let's manipulate this value and let's say it should be zero point 0.1 rather than 0.5. Let's compile it again. This is the second change that we made. And then let's again run our main cell, and here we go. You can see that our accuracy has been changed just by changing the decision boundary. It has become 81%. And if you remember, I don't remember exactly, that when we implemented the sklearn's logistic regression model, our accuracy was almost equal to this accuracy. It can further be optimized by changing the learning rate, by changing the convergence criteria. These hyperparameters can be tuned, and data can be more, efficiently, more pre-processed in a good way, so that the accuracy can be, even increased. My responsibility was to tell you how you can implement logistic regression on any dataset. This is the framework. This is a frame that will help you in implementation of any dataset, implementation of logistic regression on any dataset. So we are done with it. We are done with the implementation of logistic regression from scratch on a dummy dataset as well, and Titanic dataset that we were working with from the beginning. Guys, we are done with it. Just two changes. We made two changes, one in the reading file and then the learning rate, and that's it. Our accuracy is almost fine. This accuracy is fine for me. You can more work with learning rate and convergence criteria as well. So guys, that's it. That's about it. And we are done with implementation. And from now to onwards, very few videos left. In upcoming videos, I'll be telling you how can we implement uh, multi-class classification by using binary classification. As I told you, logistic regression works only for binary classification. So if we want to achieve multi-class classification, we can do that, but we can do it by using binary classification. We have hold our grip on binary classification, and upcoming thing is multi-class classification. We will just be reading its theory. We will not be implementing it from scratch, but you can use the sklearn's model of logistic regression for multi-class classification. That works exactly the way that was working for binary class classification. So until next lecture, bye. Okay, guys, so we are done with the practical implementation of logistic regression in Python. There is a little bit of theoretical part over here. I'm going to explain you how can you implement multi-class classification by using binary class classification. So, so far, let's say this is a binary classification problem. We have solved it by doing something like this. You know how to solve this problem. And let's say now we have this sort of problem where there are three classes. There are squares, crosses, and triangles. So how can we do it? There's a rule, we call it one versus rest rule. So first of all, we will divide them into two classes, something like this triangles will be one class, and this crosses and squares will combinedly become another class. So we will train a model. After that, we will train another model that will do something like this, that will consider squares as a one class, crosses and triangle as another class. This will be our model 2. So we have model 1 and then model 2. This is for triangle, this is for squares, and finally we will train a model something that will be something like this, that will be trained for, let's say, model 3, that is for crosses. So three models will be trained overall. um, And now, if another shape will come in for classification, how would we know from which class it belongs to? It's simple. We will predict all of them on all three models, and the model that will give us the best probabilistic value, that shape will belong to that class. For example, this will give us, let's say, 0.6, and this gives us 0.7, and this gives us 0. Let's say 9. So that new shape will become, we'll say that that new shape belongs to this cross family. So that's how you can you can implement it as well, and that's how the logistic regression model of sklearn implements multi-class classification of logistic regression. So that's how you can implement it. And finally, this is not for everyone, but for those who already know what is SVM. This is only for those. Other people can neglect it. The difference between logistic regression and SVM is really, it's really a very thin line, because in logistic regression, the main difference is of cost function. In SVM, let's say we have this sort of data, okay, and another data is something like this. In SVM, we consider the closest point to the decision boundary on both sides. So in from blue side, this seems the closest point, and from red side, this seems the closest point. So we calculate the cost function with respect to these closest points in SVM. Whereas in logistic regression, we compute our cost function with respect to all the points. So, excuse me. So this is the main difference between SVM and logistic regression. Now, in the beginning, we have studied that logistic regression works well for linear boundaries. So what if our boundary is not linear? As we have seen in the case of Titanic dataset, our boundary wasn't linear. We had almost 11 features, which means 11 dimensions. So why logistic regression was working almost fine over there? 80% plus accuracy is a good accuracy. So why it was working fine over there? The answer is, that's how you can implement even a logistic regression in higher dimensions as well. You can calculate, you can take the powers of your features, and then you can, but for that you'll have to calculate more thetas. In order to calculate more thetas, the more computation powers involved, and if thetas are really huge, which means if your number of features are really huge, such that the number of features are greater than the number of records, then logistic regression is not going to perform well on that. And I'm afraid it may not even train its model on in such scenario. So that's all, guys. Our next video will be the concluding remarks, where I'll be giving you some instructions and some answers to frequently asked questions. And even then, if you'll be having some questions, you can post. I'll be answering your questions. Our next video will be final and last video of our course. So until then, bye. Okay, guys, welcome back to our final video of this course. So it was a long journey and we are almost done. This video will just contain some concluding remarks. So how can we implement logistic regression on any dataset? And I'll be answering some frequently asked questions as well. So guys, I've already discussed this with you. Let me repeat it for you as well, so that you should learn it by heart. This is a road. This is a roadway. You'll have to pass through it if you want to implement any machine learning algorithm, not just logistic regression. First of all, get the labeled dataset. Dataset is very important. You should have, you know, I usually do not use word best a lot, but you should have the best data set. Then do a lot of data pre-processing, spend a lot of time on data pre-processing. So remove its outliers, remove its missing values, or fill its missing values. Normalize the data set, scale your data set, and then if you're sure that your data set is now, um, is it's all the pre-processing is done, then throw your data set to the training model, then tune your parameters, your hyperparameters like learning rate or convergence change and something like that. And finally, test your model, validate your model. If it's working fine, you're good to go, hurrah. Otherwise, train your model again, tune your parameters, train your model again, tune your parameters, train your model again. Do it. And if you're still not getting good results, this means you should again be doing data pre-processing. You should be following your own footsteps. That's all about. It's a roadway, it's a generalized roadway that will let you implement any machine learning algorithm on any data set. And finally, guys, some frequently asked question about logistic regression, which is if is logistic regression a supervised machine learning algorithm? Yes, it is a supervised machine learning algorithm. Is logistic regression mainly used for regression? No, it doesn't use. Logistic regression is not used for regression at all. It's in the very first video we started our logistic regression section with a question that its name is regression, but it is used only for classification. Why this is so? So here is the answer. Logistic regression, logistic function, actually we call it sigmoid as well, that returns us a value. Its curve is like something uh, like this. Okay, so it returns us a value from 0 to 1, any continuous value from 0 to 1. So this from 0 to 1 is sort of a probabilistic value of our model. So this, since this is a continuous value from 0 to 1, so that's why maybe it is named as regression. There is no any solid answer why it is named as regression, and it does actually classification. There's no solid answer, but one of the answers can be, since it returns us uh, a continuous value from 0 to 1, and then we apply the decision boundary on it, that we applied, usually we applied 0. 0.5, and for Titanic we applied 0.1. This is the decision boundary, then we apply this decision boundary on this regression, and then it becomes the classification model. So no guys, it is not used for regression, it is used only for classification. Okay, so is it possible to apply a logistic regression algorithm on a three class classification problem? Yes, not only three class, but it can be implemented on n class classification. N class means it can be implemented on any number of class, 5 class classification problem, 10 class classification problem, and so on. But if the number of classes are going to increase, then the amount of data is also going to increase. Otherwise, it will cause some trouble. These three are some frequently asked questions that if you go for interview, people ask these questions to you, and I gave you the answers. And finally, if you have any question, do not hesitate to ask. You can ask any question anytime you want. So that's all, guys. We are done with our course, and let me write this thing for you. I used to watch Tom and Jerry when I was a kid, and in Tom and Jerry, when the episode ends, something like this appears on the screen. So it's the end, guys. I'll keep updating this course if I will get any update regarding logistic regression or Python. And I'll also be keep answering your questions, whatever question you will ask. Um, so that's it. I'll also be making a few more courses. Um, right now, I'm making a course on random forest as well. You'll also be able to take that course, and a lot of more courses are also coming. So stay tuned and best of luck. Bye. A final bye